INTELLIGENCE, and SPIRIT. 1 between conception and transformation. It is only WH at it does. This book argues, from a functionalist perspective, that mind is only what it does, and that what it does is first and foremost realized by the sociality of agents, which itself is primarily and ontologically constituted by the semantic space of a public language. What mind does is to structure the universe to which it belongs, and structure is the very register of intelligibility as pertaining to the world and intelligence. Only in virtue of the multilayered semantic structure of language does sociality become a normative space of recognitive cognitive rational agents, and the suppository edly private experiences and thoughts of participating agents are only structured as experiences and thoughts insofar as they are bound up in this normative at once intersubjective and objective space. In this cursory sketch the reader may recognize Hegel's characterization of Geist or spirit. 1 Indeed, Hegel was the first to describe the community of rational agents as a social model of mind, and to do so in terms of its function. The functional picture of Geist is essentially a picture of a necessarily deprivatized mind predicated on sociality as its formal condition of possibility. Perception is only perception because it is apperception, and apperception is only apperceptive in that it is an artifact of a deprivatized semantic space within which recognitive cognitive agents emerge as byproducts of a deeply impersonal space which they themselves have formally conditioned. The intertwining of semantic structure and deprivatized sociality enables mind to posit itself as an irreducible unifying point or configuring factor. 2. 1. The history of spirit is its own deed, for spirit is only what it does, and its deed is to make itself in this case as spirit the object of its own consciousness, and to comprehend itself in its interpretation of itself to itself. GWF. Hegel, Elements of the Philosophy of Right, T.R.H. Nisbet, Cambridge, Cambridge University Press, 1991, 372. 2 lb. Puntel, Structure and Being, A Theoretical Framework for a Systematic Philosophy, University Park, PA, Pennsylvania State University Press, 2008, 275. That extends into, encompasses, and integrates both consciousness of itself and consciousness of the universe. In conceiving itself as the configurative or structuring consciousness of itself in the world, or universe, mind is endowed with a history rather than a mere nature or past. It becomes an artifact or object of its own conception. Where there is the possibility of having a history, there is also the possibility of having not only the concept of the concept, but also a history of history, a critical transformation of mind as an object of its own concept, and the critical reconception of the object into which it has transformed. And once there is a history of history, there is the possibility of abolishing what is given in history or purports to be its consummate totality. My aim in this book, however, is not to remain authentically faithful to the philosophy of Hegel, or that of German idealism, or for that matter to any other philosophy or philosopher. Philosophy is its own time apprehend in thoughts 3, and for a large part the activity of philosophizing consists in remodeling philosophical thoughts in accordance with the contemporary moment and its historical needs. To this end, my interpretation of any philosopher in this book follows what J. Rosenberg calls a Dionysian approach, for which, in contrast to the Apollonian approach, does not abide by historical accuracy or result in faithful treatises, but instead sees the positive insights and theses of philosophies distortedly through the lens of the contemporary. The Dionysian approach then goes on to selectively but critically mutate, re-engineer, and integrate what it has thus distortedly viewed through the contemporary optic. It is not that the Apollonian approach is the preserve of self-disciplined scholars of history rather than the proper work of philosophers. It is as genuine an exercise in philosophy as Dionysian critical adventurism. In fact, it is a necessary requirement for the sustenance of Dionysian roaming, and the latter, in turn, opens up new terrains of thought to renewed Apollonian scrutiny. It is in this Dionysian spirit that the book examines and reconstructs the premises and conclusions of the functional picture of mind so as to build a. As we shall see, mind is ultimately understood as the dimension of structure, or a configuring factor, something which can only be approached via an essentially deprivatist account of discursive, linguistic, apperceptive intelligence. The nature of this investigation and reconstruction originates as much from the viewpoint of contemporary philosophy as from that of the cognitive sciences, specifically, the program of artificial general intelligence, AGI, or human-level AI, and contemporary philosophy of language as an intersection between linguistics, logic, and computer science. In tandem with the Dionysian approach, the tone, pace, methods, and objectives of the chapters necessarily vary. All in all, this book is a rudimentary attempt to undertake the urgent task of presenting a philosophy of intelligence in which the questions of what intelligence is, what it can become, and what it does can be formulated. In the context of a philosophy of intelligence, this book also attends to the crucial question of what it means for us humans to remain faithful to what we are, to remain intelligible at least to ourselves here and now, and in doing so, to become part of the veritable history of intelligence. The present chapter, which is more of a preamble, a rough sketch, provides an outline of a functionalist and deprivatist account of mind, or geistic intelligence, 5 setting down premises that will be spelled out and elaborated more conclusively in the chapters that follow. Introductory yet densely compressed, this chapter encapsulates the overall content of the book. Subsequent chapters unpack this content, at times in a plain demonstrative manner, on other occasions by taking it to its not-so-explicit conclusions. Chapter 2 begins with an inquiry into the necessary conditions for the realization of geistic intelligence in the form of a program of artificial general intelligence, as if what we were really doing was attempting to construct an 3. Artificial general intelligence. A conceptual framework will be proposed for conducting this as thought experiment. Our main objective is not to investigate the possibility of constructing an artificial general intelligence or to review the popular narratives of post-human superintelligence, but to think about AGI and, even more generally, computers, as an outside view of ourselves. This is an objective labor, so to speak, whereby AGI or computers tell us what we are in virtue of what we are determinately not, i.e., contra-negative theology or the uncritical and merely experiential impressions of ourselves. This objective picture or photographic negative may be far removed from our entrenched and subjectivist experience of ourselves as humans. But this rift between the outside view and the experiential impression is exactly what heralds the prospect of future intelligent machinery and a genuine thought of the post-human. On the basis of this thought experiment, Chapter 3 sets out to investigate the conditions necessary for the possibility of having mind. In this chapter the focus is largely on what might be called the Kantian dimensions of the realization of the discursive apperceptive self, an experiencing and thinking agent, namely intuition, imagination, and a pure perspectival encounter with the world. Chapter 5 continues the mission of Chapter 3, but with the focus shifted to the realization of the discursive apperceptive aspects of geistic intelligence, moving from the realm of pure perspectivality to that of objectivity, where thought and beliefs have an epistemic status. In between them, Chapter 4 should be approached as a critical excursus that stirs things up somewhat, and prepares the conclusions reached by Chapter 3 for their speculative extrapolation in the final chapter. Its focus is the question of temporality and forms of intuition, transcendental aesthetics, as the organizing factors of experience, a question whose proper formulation will lead us to a new perspective not only on experience but also on the model of the minded subject and the prospects of intelligence as time itself. In chapters 6 and 7, which present the last stages of the thought experiment, we shall examine language as the inquiring into its sociality and syntactic semantic complexity in a vein that is much closer to theoretical computer science with its capacity to integrate computation, mathematics, logic, and language than to classical philosophy of language, or social communicative philosophy of rationalism a la Habermas. This investigation will allow us to conclude our examination into the necessary conditions for discursive apperceptive intelligence, an intelligence which acts in conformity with time general thoughts determined by the conception it has of itself. In the 8th and final chapter, both artificial general intelligence and the functional deprivatist account of the mind are suspended, aufgehoben, in a form of intelligence which is at once philosophy and a craft of philosophy qua specific program of thinking that has no nature, but only a history, a model for a self-cultivating intelligence. A final note, with respect to the distinction between analytic and continental philosophy, of which there is no trace in this book. I have gradually learned to become blind to this supposed divide. The ambitions of philosophy are far too vast and comprehensive for them to be pigeonholed into cozy compartments. Asterisk. If we were to outline the overall progression of the book in reverse order, as if we had already attained its ultimate conclusions, it could be formulated as follows: philosophy as the organ of self-cultivation of intelligence is, in the broadest sense, a historical program for investigating the consequences of the possibility of thinking and having mind. The constitutive gesture of philosophy is critical self-consciousness, primarily the non-empirical consciousness of the possibility of thinking as a building block of theoretical, practical, and axiological significance upon which the systematic relations between intelligence and the intelligible can be elaborated, in theory and practice. However, the critical self-consciousness that brings about the possibility of philosophy in the above sense is itself the consequence of the realization of the order of conception, or, more generally, self-consciousness as the form or logical structure of all thoughts. Yet the capacity to have thoughts or to inhabit the general order of self-consciousness itself depends upon the fulfillment of the conditions or positive constraints necessary for the realization of mind. Therefore, the speculative inquiry into the future of intelligence understood as that which expands and acts on intelligibilities. 5. Pertaining to itself and to the world of which it is a part begins with an investigation into the conditions necessary for the possibility of having mind. Whether framed as the program of artificial general intelligence or as a transcendental psychology, the examination of the necessary conditions for having mind marks out a sui generis form of intelligence whose process of maturation coincides with its understanding and elaboration of the link between intelligence and the intelligible. Becoming cognizant of this link is what counts as the genuine expression of self-consciousness as a task whose first milestone is intelligence's retrospective recognition of its own conditions of realization. Only once intelligence begins to systematically understand its place within the world as an intelligible unity, can it begin to concretely know what it is in itself and what it may become for itself. The significance of the functional picture of Geist is that it enables a thoroughgoing analysis of essentially self-conscious creatures, what activities, in what sorts of structures, are required in order to realize a self-conscious rational agent, or a community of such agents. It is the functional description of discursive, conceptual, and historical Geist in the context of those activities that characterize it, but also constitute it in the first place. It sets forth a project wherein the theoretical and practical desacralization of the mind as something ineffable and given coincides with the project of historical emancipation and the disenthrallment of intelligence as that which both frees itself piece by piece from its local and contingent limitations, emancipation as a negative freedom from something, and treats whatever conception of itself it has arrived at, whatever task such a conception entails, as the milieu of an unrestricted attention and commitment, emancipation as a positive freedom to do something. Characterizing discursive consciousness in an adequate functional context rather than by reference to a predetermined structure or a meaning inherent in nature makes it possible to identify those necessary conditions for the realization of mind as an intelligence that has not just a history, but a critical history, a history of history, not just a conscious self but, more importantly, a self that is the artifact of its own configuring or unifying concept, begriff. This is a self in which the distinction between the subject of conception and the object of the concept is suspended. Moreover, as will 6. be elaborated in subsequent chapters, this functional characterization offers insights into what it means to reorient consciousness and thought toward an emancipatory project, the core of which is the emancipation of cognition itself. Before proceeding, it is crucial to add a brief note on the concept of suspension. Throughout this book, I have used the word suspension or the verb suspend as a common English equivalent for Hegel's aufheben or aufhebung, instead of the uncommon sublation, from the Latin sublatum, which only captures a limited range of the connotations Hegel has in mind. Aufheben has four connotations depending on the context: L, to lift up or to heave; heben, as if something is on or has fallen to the ground; 2, to pick up or actively seize something, which accentuates the previous connotation, heben; 3, to preserve or retain something; 4, to cancel or abolish something, to remove or take out of action. Hegel's Aufheben places the emphasis on the positive and negative connotations, 3, and 4. For example, in the case of the pure introspective I, the I that appears to be immediate is in fact mediated by its relations with others. Its immediate positedness, Gesetzsein, is the result of, i.e., is mediated by, the movement of positing, Setzen. Through Aufhebung, the positive immediacy of the self-reflexive I is cancelled, while the determinate negativity that accounts for the difference between the immediate and its mediation, I and another I, is preserved. In other words, the identity of what appears to be immediate is abolished or taken out of action, whereas the difference between the immediate and its mediation, the opposition, is preserved. Accordingly, Hegel's Aufhebung has both a temporal and spatial aspect. What appears to be immediate prima facie is taken out of action or postponed, the temporal aspect, only to preserve the difference between the immediate and its mediation on an elevated level, the spatial aspect, as in the suspension of being and nothing in the more stable determinate being. 6 Therefore, Aufhebung is closely associated with the extended labor of determinate negation, as opposed to the abstract or indeterminate negation that inadvertently ends up perpetuating the purported immediacy of the state of affairs it seeks to abolish. A certain X appears to be the completed totality of the state of affairs. X might be the human condition, the manifest totality of ways in which we appear to ourselves as a species, or it might be capitalism, the putative totality of all social relations as transformed by the accumulation of value qua labor time. Through Aufhebung the particular content of X is cancelled, but the difference between the immediacy of X and its mediation is retained. This allows us to see the cancellation of X not as a single punctual act that abstractly or totally negates the state of affairs, but as a development, the product of a positive labor of determinate negation that takes time. The suspension of the self-portrait of the human or of the capitalist mode of production as the alleged immediate totality of the state of affairs is thereby differentiated from naive forms of post-humanism, anti-humanism, and simple abolitionist revolutionary politics, a revolutionary politics in which negation is decoupled from the process of determination and instead is turned into a fetishized form of abstract negation which, in its indeterminacy, presupposes a metaphysical account of totality whose immediacy is actual and which therefore, it is falsely assumed, can be abolished by an all-destroying and total negation. In this respect, in addition to determinate negation, Aufhebung is associated with Hegel's distinct concepts of speculation and reason. Speculation is to be contrasted with simple reflection, which is reflection through and on that which is allegedly immediate. For example, what it means to be human is often taken as something immediately present and thus left unexamined. Speculation rescues reflection from its pitfalls rather than annihilating it. Speculation can be grasped as a movement from the subjective to the objective, a movement that suspends the immediate element of reflection and, in doing so, incorporates reflection as the reflection of opposites, a developmental stage in speculation. In the same vein, Hegel's reason, Vernunftsgeist, is distinct from Kant's reason, the faculty of concepts and judgments, Vernunft. Hegel's reason is a form of thinking that admits of the unity and identity of opposites, example both finite and infinite, subject and object, in their distinctness, and which, rather than operating externally on concepts, explicates the immanent operation of the concept itself. Lastly, although distinct from it, Hegelian suspension can be linked back to the Pyrrhonian septical epoche or suspension of judgment regarding non-evident propositions. What gives rise to epoche is equipollence or Pyrrhonian isosthenia, the idea that, for any proposition or property, its contradicting opposite or incompatible property can be put forward with equal justification. Hegel's Aufhebung seeks to break from the stasis and practical untenability of Pyrrhonian scepticism by directly assimilating it into reason in such a way that scepticism is no longer idly opposed to reason but becomes a dynamic and productive vector of it, what Ray Brassier has called a dialectics between suspicion and trust. Point 7 The phenomenal knowledge of Geist can therefore be presented as a self-consummating skepticism. Point 8 The assimilation of epochs into reason and its complete remodeling. As the dynamic process of suspension and determinate negation then allows us to think of epochs or, more generally, the history of Geist. In order to refine the formal figure of the human or the functional picture of the mind cannot be refined, nor can they shed their entrenched dogmas, without a rational skepticism about their status here and now, and how this status might as a matter of fact restrict the prospects of what mind or intelligence can be. Therefore, it is in this vein that what is introduced in this book as the critique of the transcendental structure is suggestive of both the operation of Hegelian suspension and the productive incorporation of skepticism into the phenomenology of mind and into the transcendental project which sets out to investigate the functional picture of mind and the figure of the human. The account of function that is attributed to the mind, as regards what it does, its activities, should and will be elaborated carefully. For now, it suffices to say that this is a normative rule-governed account of function rather than a metaphysical one. The function of mind is structuration, conceptualization, rendering intelligible, making objective. The claim here is that there are no intrinsic functions in nature, all metaphysical functions are in fact modeled on normative activities of the mind. This point was already made very clearly by Kant in the context of as-if arguments. Functions in nature are species of as-if judgments. For example, when we study the heart, it is in regulative analogy to practical reasoning that we say that the function of the heart is to pump blood. But what we are actually doing is treating the heart as part of a whole, the circulatory system, in terms of means-ends relations. The causal role, means, of the heart is to pump blood in the circulatory system as its end. In accordance with the success or failure of this means-ends relation, which is a piece of practical reasoning, we can then talk about the function or malfunction of the heart, what it ought to do and what it ought not. So, in reality, what we are saying is that, in analogy to practical reasoning, it is as if the function of the heart is to pump blood. So long as this as-if aspect is carefully posited and is not confounded with a constitutive judgment, it is not problematic to attribute functions to the activities of natural things. Moreover, functions can only be attributed to activities, not to things. Activities are specific, contextual, and domain-sensitive. Does a lump of clay or the planet Jupiter have a function? Any positive answer to this question risks infinite regress, insofar as it will no longer be possible to specify where the function ends. Point 9 Mind is not a thing, it is only what it does. In attempting to provide a functional description of mind, I shall try to steer clear of any orthodox or metaphysical functionalism. Nevertheless, despite its metaphysical slipperiness, contemporary functionalism has contributed invaluable insights regarding the problem of functional analysis. These insights are drawn from the epistemological methods required to study complex systems, particularly nested hierarchical structures where the problem of different scales or levels is of the utmost importance. Point 10 In tackling the problem of analyzing the mind, some of these methods will be adopted in order to develop a more fine-grained paradigm of functional analysis. Before coming back to a more comprehensive description of Geist in terms of its function, then, it will be worthwhile to provide some brief comments regarding the kind of functionalism or functional analysis this book draws upon. To define or analyze the mind in terms of functions is tantamount neither to the elimination of structural or material constraints, nor to a dismissal of such constraints. The mind is what it does to the extent that there are adequate material causal and logical semantic structures that support its activities. This is not to elide the distinction between normative activities and natural structures, reasons and causes, thinking and being, the conceptual psyche and the cerebrum 11, but only to underline the fact. A number of interesting consequences. For example, The observation that the function of item x is y explains or contributes to an explanation of the general proper activity of a system S which includes x. It does not, however, essentially explain the presence of x as such, nor does it essentially have the same properties as the general activity of S. N. That adequate causal structural constraints need to be in place in order for geistic activities to be realized. In this sense, a functionalist analysis of mind attentive to the question of structural adequacy and constraint as well as that of types and distinctions of structures is the proper method of carving at the joints. 12. It differentiates distinct classes of functions and their uniformities as if functions that describe causal structural mechanisms and functions proper, which, belonging to the order of reason, signify logico-linguistic roles. Furthermore, it correctly attributes functions to organizing structures which, in their very constraining role, support and afford the realization of mind. In short, an adequate functionalism of mind as a configured and configuring unity must presuppose that a plurality of constituents is required for the constitution of the mind, and that, in addition to this plurality of constituents, there is also a plurality of organized unities or integrations of such constituents, each with its own distinct structural constraints which may or may not be interlaced. For this reason, functional analysis demands a coherentist view that sees a single function in terms of activities that are qualitatively different from the role it appears to be playing. Functions are not a matter of pure abstraction since they are dimensionally varied and multiply constrained. Dimensionally varied means that a function can only be adequately analyzed in terms of the qualitatively distinct structural constraints required for its realization, constraints that are distributed across different levels, dimensions, of the functional structural organization. Multiply constrained means that the specificities of a function are determined by distinct structural levels that constrain it in particular ways. The analysis of 12. A function as dimensionally varied and multiply constrained is a realistic examination of the conditions required for the realization of that function in its specificity. In principle, a proper analysis of a function is a blueprint for the realization of that function, and its potential modification via changes in its underlying structural constraints. This is all to say that a description of mind in terms of geistic activities requires a multilevel approach capable of analyzing the types and scales of structural constraints, whether physical or socio-cultural, that at once afford such activities and specify them. This issue will be discussed in more detail in chapters 2, 3, and 4, under the rubric of a critique of the transcendental structure. The question of what it means to distinguish structures necessary for the realization of mind or thinking from the contingency of their particular transcendental types. The dimensionally varied and multiply constrained description of a function specified above may be called the deep picture of the function. It is deep in the sense that it pictures the function as being organized by activities, constraints, and unities at different structural levels or scales. The overall attributes of a function are determined by the interplay of multiple activities that cannot be straightforwardly merged or intuitively added together. The deep picture does not describe a function in terms of how it appears, but instead explains how it is organized. It specifies what activities, with what roles, what spatial and temporal organization, and what dependency relations, are required for its realization of a function. The totality of a function is replaced by the hierarchical and multilevel complexity of a functional organization wherein the function is orchestrated by qualitatively different activities, each designated with specific constraints and associated with a distinct structural domain or level. In contrast to this deep picture of function where there is no one-to-one correspondence between realizer and realized features, what we might call the flat picture of function presumes a one-to-one correspondence between realizer and realized, either because the realizer's properties are considered as qualitatively identical to the realized functions, or because the structural levels and their corresponding constraints have been flattened. The flat picture of function can be modeled on the *3. Mathematical concept of function as a transition map between input and output, where the transition can be realized as many pathways mapping an initial state to an output state. On this model, the function implies an unconstrained abstract realization insofar as there is one-to-one correspondence between the realizer and realized features. Function A abstractly realizes activity B if elements of a map onto or are isomorphic with elements of B. Here, flatness signifies structural and / or functional isomorphism between the attributes of the realizer and the realized, insofar as there are no constraints associated with distinct levels of structure or activities. Therefore, in the flat picture of function, the causal and / or inferential relations between realizing and realized properties, activities, and functions are context-free and domain-neutral. A specific property or attribute can be realized by any set of entities as long as the abstract mapping holds between them. But this abstract mapping is built on the assumption of an isomorphism between realizers and realizeds. At the structural level, such isomorphism presupposes the absence of distinct structural levels which in distinctive ways constrain and determine the specificity of a particular function and its properties, while at the functional level, it implies that both realizing and realized properties are of the same functional type or class. This flat or unconstrained picture results in triviality, since any given function can be realized by all manner of entities so long as the abstract mapping between realizer and realizeds is obtained. Anything can be furnished with mind, be it a rock or a piece of Swiss cheese. 13 Functional complexity becomes ubiquitous when any function can be realized by any kind of stuff. The functional description of mind, however, requires an account of the integration of distinct processes, activities, and roles both causal and logical. Without a precise account of this integration, how different activities with causal or logical roles are put together and integrated, and how different constraints are satisfied, the description of mind is merely the description of arbitrary stuff. Thinking becomes ubiquitous to the extent that there are no specific organizing or explanatory constraints for its realization. 14 As we shall see in the following chapters, there are many types of constraints that need to be in place for anything like cognition to be realized, and, as will be discussed in Chapter 2, the myth of a superintelligence or an unbounded post-human intelligence is precisely the product of biases ingrained in the flat or unconstrained picture of function. In other words, such views inexorably forego the task of explaining what it means to call something intelligence, and describing the exact structural constraints by virtue of which something can be identified as exhibiting intelligent behaviors. In this sense, naturalistic accounts of superintelligence fall into a contradiction, committed to a physicalist account of intelligence and a thesis about an unbounded intelligence, yet unwilling to go through the hard work of identifying the structural and behavioral constraints and taking them seriously. Moreover, the flattening of structural and functional dimensions and the consequent removal of specific constraints associated with them results in an illicit merger of the organizational hierarchies that underpin cognitive complexity. This illicit merger has significant implications for the models used to analyze and intervene in any system. It makes the issues of realizability, reappropriation, and functional change appear to be already at hand and only a matter of understanding and intervention at the level of immediate cognitive and practical resources, and such an assumption inevitably leads to biased conclusions. For example, if a system S has a global function A and local realizing properties or functions L, 3L, necessary for the realization of A, then according to the flat picture of function, all properties or activities in S are to be regarded as qualitatively identical to what the system does. It is not difficult to recognize that this is in fact the logic of subsumption. If such and such activities are vital to a system's functions, then it must be that these activities are subsumed within the function of the system, and therefore represent the qualities or properties of the system's function. By the same token, if what the system is doing is flawed, then in virtue of the functional subsumption entailed in the flat picture, all activities vital to that system must be changed or discarded. For instance, if capitalism has subsumed such and such activities or relations, and if capitalism must be rendered obsolete, then so must these activities and relations. This is an anti-scientific approach that has neither any purchase on reality nor any critical import. Let us expand on this example in comparison with the deep picture of function, Capitalism is defined by what it does, its mode of production. We cannot think of individuals and the capitalist system in terms of simple part-whole relationships or metaphors about relations between things, example grains of sand in the desert, bricks in the wall, etc., where the particulars of such and such qualities can be said to be ontologically subsumed by or to have the characteristics of the whole to which they belong. Particular individuals, or collections of them classes are actively included in the capitalist system not in virtue of their living in it or being a part of it, but by virtue of whatever they may do that in one way or another counts as conforming to or being involved with capitalism's mode of production. An individual adheres to capitalism if what they do fits the pattern of capitalism's mode of production. In this sense, not every activity or characteristic of an individual or a person is subsumed, shaped, or assimilated by the system to which it contributes or of which it is a part. Even if we take capitalism as the totality of ways of producing and society as what we perceive to be the totality of social relations, they represent two quite distinct types of totality despite their interconnections. To remain oblivious to these seemingly minor specifications is to risk mistaking functions or activities for things, links between the distinct levels of individuals' activities and capitalism's mode of production for metaphysical relations between things. 15 Confusing activities with things and flattening different levels of activities will without exception result in specious descriptive and prescriptive conclusions. On the descriptive level, capitalist society will be regarded as a metaphysical totality in which every element, particular individuals, activities, etc., is by definition ontologically subsumed within capitalism. Even concepts and conceptual activities in general will be deemed to be subsumed by its mode of production. But if concepts themselves are absorbed by capitalism, then the very idea of capitalism becomes ineffable. Talking about capitalism and diagnosing its pathologies will then be literally more than exercises in producing subjective and arbitrary narratives about something that is, in truth, unintelligible. On the prescriptive level, capitalism will be judged as a matter of all or nothing, either we should by any means possible contribute to it since there is no alternative, or we should seek its total collapse and with it the collapse of all social relations since such relations in their entirety are supposedly assimilated by it. Another variation of such a fallacy is the equivocation between the socially instantiated functions of the mind and social practices in general. According to this erroneous view, if social practices are warped by a system of social relations, let's say reshaped and distorted by capitalism, then powers of reason and judgment, or the structuring functions of the mind, are also tainted by this all-encompassing distortion or corruption. But such a thesis is based on flattening the distinctions between social linguistic practices and social practices in general, act and object, form and content. Linguistic practices are indeed social practices, but their sociality is not general, they are sui generis and formal social practices that must be sufficiently differentiated from other social practices. Absent this differentiation, any talk of real or material conditions, and therefore any critique of social relations, is little more than everyday talk which, lacking objectivity, is in every way arbitrary and dogmatically subjective. Functional analysis and the study of structural complexity should be approached as essentially conjoined programs. Unless both are in place, description and prescription in any form will be untenable, and perspective explanations, interventions, analyses, and critiques will result in dogmatic positions ranging, depending on their contexts, from resigned cynicism to fatalist optimism, from analytic stinginess to speculative over-enthusiasm. * 7. In both Kant's account of the conceptualizing mind and Hegel's picture of mind as the object of its own concept or notion, the questions of function and structural complexity whether at the level of the sensing body or that of the social structure are intertwined. Hegel's characterization of spirit, qua-organized collection of rational agents or essentially self-conscious creatures, in terms of its functions, and his subsequent analyzing of these functions into qualitatively distinct activities and the structures necessary for supporting them, should be regarded as a systematic attempt to uncover the deep functional picture of mind. In attempting to provide this picture, Hegel uncovers hitherto unknown realizers and material organizations, powers and constraints, possible realizabilities and functions whose recognition, modification, or augmentation can reshape Geist. It is in this sense that we can speak of the function of functionalism, a systematic functional analysis of what Geist does, its doings, itself turns into a function that reorganizes Geist. A functionalist approach to the question of what mind is culminates in asking what mind can become. The function of the functionalism of mind, the function of the transcendental, is a thesis already harbored by Hegel's identification of Geist, which is what it does, as the object or artifact of its own concept, an object that is not sensible but is an object of thought, and its unrestricted focus on realizing itself in accordance with its formal reality. Let us conclude this section with a tangential note on the sensible object Gegenstand, and the object of thought, object, since this distinction will feature throughout the book. Although Kant's use of the terms Gegenstand and object is not consistent, in the Critique of Pure Reason he uses Gegenstand to denote a sensible object, an object of appearances or experience, the interplay between concepts and intuition. The German Gegenstand suggests at least three connotations: das Gegenüberstehend, or that which stands in front of me, phenomenal manifestation, that which is opposed to me, versus subject, and that which stands or lasts as a product of the faculties of imagination and understanding, perceptual persistence. In this sense, Gegenstand, sensible object, adheres to the limits of understanding and intuition. Object, on the other hand, is defined as an object that is explicitly for knowledge or thought, that is to say, one that is expressed. 18. By the determinate relation of given representations to an object or object in the concept of which the manifold of intuitions are integrated and united. The object can be associated with the Latin objectivum, which simultaneously implies the real and the ideal, being and structure. This already convoluted distinction is further complicated by Hegel's use of Gegenstand, which he contrasts to the object, the real object, as the dual or correlative of the subject, and characterizes in terms of actuality or trueness, as in an objective fact, and impartiality, i.e., obeying impersonal rules as opposed to the subject's whims. This owes mainly to the fact that Hegel's account of experience, and of an object of experience, differs from Kant's. Therefore, Hegel's Gegenstand is an object made concrete. It is the object of knowledge and self-consciousness, whereas the object is a system of real objects held together by inference, judgment, and the concept, example the Milky Way as comprised of stars and planets. To avoid further confusion, I have abided by the Kantian distinction between Gegenstand and object. Hegel's Gegenstand will be characterized as an object, and Gegenstände are reserved only for ordinary sensible objects of experience or appearances, items in the world that manifest in perspectival terms and according to perceptual invariances. What makes Hegel's picture of Geist a significant contribution not only to the history of functionalism and philosophy of mind but also, intriguingly, to the history of artificial general intelligence, is that it presents a social model of general intelligence, one in which sociality is a formal condition for the realization of cognitive abilities that would be unrealizable by individual agents alone. By agents here I simply mean de facto causal structural systems capable of sensing and of effecting rudimentary actions, not agency in a Kantian Hegelian sense, where it is precisely inseparable from its geistig sociality. But, as will be argued, this sociality is first and foremost a formal space upon which familiar collective sociality is built, a sociality afforded by language not as a medium of communication and public discourse, but as a semantic space within which computation and logic converge. At this *9 point, the equation of general intelligence with Geist may appear egregiously hasty. Even though this equation will be fleshed out throughout the book, for now we can understand general intelligence not merely as a bundle of intelligent behaviors, but as a unified intellect distinct from any particular set of such behaviors. In this sense, the generality of general intelligence signifies a qualitative rather than quantitative space in which all of its behaviors and activities are caught up. In analogy to Geist, General intelligence is introduced in this book by way of three principal attributes: necessary abilities, the intrinsic social frame of these abilities, and their qualitative integration into a generative framework through which, in addition to becoming capable of recognizing itself, intelligence can inquire into and modify its conditions of realization and enablement. But what principally distinguishes general intelligence from quantitative problem-solving intelligence is the fact that general intelligence is the product of a qualitative integration of capacities or faculties that might otherwise be quantitative when taken individually. How is it that the qualitative integration of certain otherwise non-special capacities and features can amount to a set of special and necessary abilities? This is a question that is as much about the realization of Geist as it is about the artificial realization of general intelligence. The question of functional integration, however, becomes particularly thorny since these capacities and features are realized by different causal and logical conditions, distributed across distinct structural hierarchies and functional classes. To this extent, the realization of Geist or general intelligence is not a matter of finding and developing a special realizer, a master key. It is a problem of the qualitative integration of abilities and their realizers in such a way that geistic intelligence not only recognizes itself and its abilities, but also becomes capable of modifying its very conditions of realization. Hegel's curious account of Geist, however, defines it not only in terms of an integral and qualitatively distinct set of activities, but also in terms of phases of integration. Mind is constituted not only by the organizing unities of its constituents, but also by its passing through different unities of itself. These unities are outcomes of the principal attributes of mind, which enable 2. It not only to recognize itself, but also to recognize itself in the world and to realize itself according to this recognition. What was mere consciousness J is now a formally instantiated self-consciousness, what was only a socially and historically mediated self-consciousness is now historical consciousness, and what was historical knowledge, Wissery, of consciousness has been reintegrated into a necessary and pure science, Wissenschaft, of the J-world history of which it was conscious and absolute knowing in which J-spirit sees itself through the intelligible unity of the objective world in its otherness and thought in its formal autonomy. The concept, Begriff, of pure science and its deduction is therefore presupposed in the present work insofar as the phenomenology of spirit is nothing other than that deduction. Absolute knowledge is the truth of all the modes of consciousness because, as the course of the phenomenology brought out, it is only in absolute knowledge that the separation of the subject matter from the certainty of itself is completely resolved. Truth has become equal to certainty and the certainty to truth. 16.1. However, the actualization of these unities or integrations is neither given nor certain. Self-consciousness, once attained, may be lost, or it may never be fully realized. All unities of mind which constitute mind as such are fragile. It is in this sense that Geist is not a deus ex machina, its realization requires that a certain struggle take shape in the form of a necessary relation between intelligence and the intelligible, not merely theoretical or ontological, but also practical and axiological intelligibility. Nevertheless, this notion of a struggle for the unities of mind remains a fruitless quest and an unintelligible toil unless we posit a science of logic through which intelligence sees itself in terms of a regulative and necessary form conceived from nowhere and nowhen. This necessary form is what we might call the Hegelian transcendental operator, which, in contrast to Kant's idea of the transcendental method, is decoupled from the conservatism of particular and contingent experiences that have not yet been fully suspended in the self-experience of the Absolute. It is the logical excess of the transcendental that crafts intelligence, initiates and regulates the mind's strivings for new unities, and sets the mind into a permanent state of alienation where the spirit is at home. 17. And it is the same excess that retroactively reveals to thought reality in its radical otherness. We shall return to the notion of transcendental excess in the final chapter under the aegis of that most radical and dangerous thesis of all philosophies, Plato's idea of the good and the craft of a good life. As new unities of the mind evolve, previous unities can only be viewed from the perspective of later and more encompassing unities. In light of the later unity, the supposed immediacy of each previous unity of mind turns out to be mediated. The unity of consciousness can only be recognized through the unity of self-consciousness, just as historical consciousness can only be analyzed from the vantage point of absolute knowing. Where the phenomenology of spirit ends, absolute knowing, or the science of logic, begins. And where absolute knowing begins, the science of what mind necessarily and actually is, in its intelligible unity with the world in its radical otherness, comes into view. 18. Thus consciousness, on its forward path from the immediacy with which it began, is led back to the absolute knowledge that is its innermost truth. This truth, the ground, is then also that from which the original first proceeds, the same first which at the beginning came on the scene as something immediate. 19. By shifting from one unity to another, from one mode of integration to a more encompassing one, Geist recognizes its conditions of realization. In recognizing the conditions of its realization, it becomes capable of modifying those conditions and thus of modifying its own realization, but not until it has recognized its intelligible unity as a part of a more integral unity, namely the intelligible unity of mind and world. By recognizing what is universal and necessary about itself, mind becomes capable of revising the transcendental types or structures it previously deemed to be universal and necessary for the realization of its abilities or cognitions. And in revising these transcendental types or structures, it moves from one qualitative level of abilities to another, from one mode of integration to another. In this manner, Geist suspends that which previously seemed necessary for it but was in reality contingent in what is absolutely necessary and universal for it. These different levels of integration reflect the fact that there are different qualities of Geist. Each mode of integration indicates a qualitative shift in the structure of general intelligence. Phases of spirit are defined by these modes of integration, by how cognitive and practical abilities are systematically incorporated within new unities of consciousness, and by the way in which each mode is represented and established as a normative model, the concept, for the formation of new attitudes, subjectivities, and institutions for its constitutive agents. What is essential for the qualitative transformation of intelligence are not simply modes of integration qua unities, but also the manners in which these unities are concretely established as models for the conduct and cognitive cultivation of those agents that constitute Geist and are encompassed by it. While modes of integration effect a qualitative transformation in the structure of geistic intelligence, their recognition as theoretical and practical models provides agents with access to the intelligibility of this structural transformation. In concretely and determinately recognizing the universal and necessary conditions of its realization, intelligence is enabled to realize itself under a new and higher unity. And in its constant striving to bring itself under a higher unity, intelligence becomes conscious of what the realization of intelligence, in itself and within objective reality, consists in. 23. Life, the I, spirit, absolute concept, are not universals only as higher genera, but are rather concretes whose determinacies are also not mere species or lower genera but determinacies which, in their reality, are self-contained and self-complete. Of course, life, the I, finite spirit, are also only determinate concepts. To this extent, however, they find their resolution in a universal which, as the truly absolute concept, is to be grasped as the idea of infinite spirit, the spirit whose posited being is the infinite, transparent reality in which it contemplates its creation and, in this creation, itself. 20. To summarize, the integration of necessary qualitative abilities, unities, of mind has two outcomes. On the one hand, it results in transitions in the qualitative form of a Geist that always recognizes itself in the world from the viewpoint of its higher functional unity. On the other hand, it occasions the possibility of bringing this qualitative form into a conception, that is, forming a concept or formal model of it by means of which agents can recognize or become aware of it and track its transformations within their own collective structure. This serves as a cognitive and practical model by which agents can recognize their abilities and constraints, and act on the conditions of their realization so as to modify or reconstitute them. In this sense, integration set up a dynamic link between intelligence and intelligibility, between the conditions required for the realization of intelligence and the recognition or awareness of such conditions. The intelligibility of those faculties that constitute the structure of agency and the recognition of the necessary conditions for their realization are then established as premises for functional change and further transformation in the structure of the agency. This constructive spiral between intelligence and intelligibility expresses the logic of self-reference that is the constructive kernel of Geist. As will be argued below, this logic is specific to a distinct species of selves with sapient consciousness, that is, consciousnesses capable of conceiving through the form of self-consciousness. But this is not self-consciousness. As an intentional awareness of a self at once observing and observable, a phenomenological self-consciousness, nor is it the self's introspective reflexive knowledge of itself. It is a logical form through which the self only recognizes what it is for itself from the perspective of a posited infinity, that is, an unrestricted intelligible world which in its explanatory otherness renders intelligible what that consciousness is in itself, in its intelligible unity. 21 In doing so, self-consciousness establishes the truth of itself and the unrestricted world. Consciousness of an other, of an object as such, is indeed itself necessarily self-consciousness, being reflected into itself, consciousness of its own self in its otherness. The necessary advance from the previous shapes of consciousness, to which their truth was a thing, that is, was something other than themselves, expresses precisely the following. Not merely is consciousness of things only possible for a self-consciousness, rather, it is the self-consciousness alone which is the truth of those shapes. However, this truth is on hand merely for us and not yet for consciousness. Self-consciousness has first come to be for itself but not yet as unity with consciousness itself. 22. Through the logic of self-relation as the form of self-consciousness, mind attains the ability to treat itself as an artifact of its own concept. It artificializes itself, conceiving itself from the viewpoint of an unrestricted world that belongs to no particular where or when. In other words, through self-relation as the formal condition of self-consciousness, mind is now able to investigate the conditions required for its realization, to adapt to ends and purposes that are not given in advance, and to explore the possibility of its realization in types of structures other than those that naturally constitute it. The history of this kind of self, the minding self, is, then, strictly speaking, a project of artificialization in the above sense. Self-relation is a defeasible and disequilibrial constructive process. It is a process whereby Geist utilizes the intelligibility of its structural transformations, its history, as a model for conceiving itself from the standpoint of a reality that is in excess of it. Not only are Geist's actions informed by this model, they also exhibit it. The positive freedom of Geist, the freedom to do something, is an expression of this self-relation, which is that of formal autonomy. In its simplest and most embryonic form, this self-relation is the trivial tautology TMI 23, /=/. But in positing this very tautology, Geist comes to the realization that the accomplished individuality that it takes itself to be is in fact an ongoing process of individuation from the perspective of that which is not this I, the other I, and reality in its radical otherness. That is to say, the positing of self-consciousness as formal, as abstracted from any particular or substantive content, enables what is conscious to be conscious of itself only in so far as some other object mediates its immediate relation to itself. Self-relation should not be understood in terms of what it appears to be, that is, an immediate relation to the self that is taken for granted, or a mere acknowledgement of oneself as living and as being the subject of desires that satisfy the needs of the species. Instead, it should be understood in terms of what it does, its ramifications. Self-relation begins with a negation of objects and the outside world, but this very negation also brings the self-conscious subject head-to-head with a resisting reality that is not passive, where objects impose constraints upon both thoughts and actions. The consequence of self-relatedness is that it forces the subject to project outward, To be conscious of a reality which is not an extension of the self but an order in which objects negate back, rendering the thoughts of the subject defeasible, prone to revision, and its actions challengeable. Or open to possibilities that are not given in advance within the order of self-serving desires or the needs of the species. Even though self-relation begins with a trivial premise I am I, its consequences are by no means trivial. They are in excess of such a premise. When a life form negates the outside world in favor of its own interests, it also opens up a new vista wherein reality becomes intelligible as that which is not in conformity with the desires of the life form and, indeed, actively resists them. And where reality becomes intelligible as an active constraining order, self-consciousness is defined not as a phenomenon serving the needs or interests of the species, but as an adaptation to an intelligible reality which outstrips species-related interests and needs qua premises of self-relatedness. The medium of this adaptation is the order of reason, which can be loosely characterized as a system of essentially revisable thoughts and challengeable actions, i.e., thoughts and actions enabled by the constraints imposed by reality in its otherness. To characterize self-consciousness in terms of the necessary internal relations between thinking, action, and the constraints imposed by reality is to distinguish it above all as a formally represented order in the sense that all thoughts and actions representing it also conform to the manner by which it orders them not per accident but per necessity. This manner of ordering is first exhibited in the formal abstract unity of thoughts and actions, i.e., in the way in which first-person thoughts and intentional actions are internally related, and subsequently in the formal concrete unity of thinking self and material reality, I and not I, first-person and second-person thoughts. The acts of an essentially self-conscious creature fall under a formally represented order in which thoughts explain or cause actions, and actions not only fall under their respective thoughts but also exhibit them. The questions of what to do and what to think always arise in response to this order, just as this formal and general order explains the thoughts and actions of a subject that falls under it. It is in this sense that thoughts and actions are bound to the question of justification. Do these acts and thoughts reveal or justify the causality, i.e., the explanans, of self-conscious thoughts? 24. Insofar as the acts of a self-conscious creature essentially fall under the formal causality of thought, and to the extent that the questions of what to do and what to think always arise in response to this general order that explains the actions and thoughts of the self-conscious creature, we can speak of a normative order of self-consciousness. This normative order is nothing but the order of reason qua justification. As an order that both formally represents and is represented by the causality of thought, self-consciousness is precisely that which turns mind into a unifying point or configuring factor. In actualizing what is only a formal self-consciousness, general I thoughts, Geist must posit that which is not I. Only through the other, not I, can the self-relation of the particular I thoughts which seemed immediate to the subject that thought them, but were mediated from the viewpoint of the other, become immediate again. This is actualized self-consciousness. The self-positing of mind as the unifying point is a formal condition required for the positing and recognizing of reality in its otherness. It is the configuring factor that makes possible the intelligible unity of mind and reality as both distinct and coextensively configured. The uniting bond, the configuring factor, is not only somehow omnipresent, it not only encompasses and contains all the united elements, but it also has a quite determinate directedness, indeed one emerging from the point from which the unifying is accomplished and by which the elements are made possible and born. This unifying bond or configuring factor, the unifying point, is a basic concept. In a specific sense it is a primitive concept. More precisely, it is an absolutely singular, unique concept that can be articulated only on the basis of a concrete and penetrating analysis of the phenomenon experience of personal unity. In what, more precisely, does this unifying point consist? It articulates itself by saying I. The I must not be hypostasized as substance or anything of the sort. It would also be fully insufficient philosophically to interpret or understand the I solely on the basis of linguistic configurations within which. 28. The word I appears. The task is instead that of comprehending the I ontologically. 25. However, in order for the intelligible unity of mind and reality, the autonomy of thought and the alien thing, to be concretely realized, in order for self-consciousness to establish the determinate truth of itself, it must become conscious of itself from a second-person viewpoint, that of a reality that is in excess of thought and yet is still intelligible. The formal autonomy of thought accordingly demands stepping into the open and conceiving self-consciousness from the viewpoint of a reality that is wholly other to it. Once a minimal and formal self-relation is established, it opens up a gap between mind and world. Only by bridging this gap from the other extremity, that is, from what is now outside of the manifest identity of the I, can mind become concretely self-conscious. This is the labor of negation, where there is no direct access between mind and reality, between one I and another, but where contact can only be obtained through the hard work of conception. Through the labor of negation, what was a formerly trivial identity relation, the monad of 1 equals 1, is now an identity map, /=/, where / is the self or mind from the perspective of an abyss, an unrestricted world or reality that is to be rendered intelligible. The intelligibility of I or self-conscious mind rests on the intelligibility of the abyss, which is, properly speaking, something to be achieved, an objective striving. Intelligence only turns into intelligence when it loses its passivity, when it actively begins to render reality intelligible and, in so doing, begins to re-engineer the reality of itself. 269***2. Individual I thoughts can only be concretely established as singular once they are re-encountered through the other and unbound reality, for which the I is not a totalized individual, but a process of individuation. In permanently losing its home, in suspending itself in the abyss of intelligible reality, the mind retroactively recognizes that what was a merely formal order of self-consciousness was in reality an actual order of self-consciousness, that what was only a formal autonomy was in fact concrete freedom, that the immediate was mediated and the trivial and simple identity I am I non-trivial and complex. Accordingly, the truth of formal self-consciousness is ultimately and only in retrospect the truth of concrete self-consciousness. However, the transition from formal self-consciousness qua minimal self-relation to concrete experienced self-consciousness is the most fragile of all endeavors. The realization of intelligence bespeaks this maximal fragility. If Geist stops seeing itself from the perspective of a radically other reality, if it gives up on expanding the intelligibility of the other, it ceases to be Geist. Actual self-consciousness, then, is not a given state but a practical achievement. 27 and, as such, the object of a struggle. The transition from the formal autonomy of thought to an achieved state of concrete self-consciousness is, all things considered, the project of freedom as such. By way of that self-conscious negation, self-consciousness itself engenders for itself both the certainty of its own freedom and the experience of that freedom, and it thereby raises them to truth. What vanishes is the determinate, that is, the distinction which, no matter what it is or from where it comes, is established as fixed and unchangeable. The distinction has nothing permanent in it, and it must vanish for thought. 7*2. Because what is distinguished is precisely this, not to exist in itself but rather to have its essentiality merely in an other. 28. Self-relation is the formal condition of intelligence. But only when it is steeped in the negativity of reason does it become an engine of freedom, for which intelligence cannot exist without the intelligible, and the intelligible cannot be conceived without intelligence. This essential correspondence intelligence-intelligible constitutes the truth of intelligence, without which it is an empty thought. However, this correspondence is not given in advance, and is never fully totalized. It is a labor, a project. Accordingly, treating intelligence as something that simply comes out of the black box of nature or technology is an equally empty thought. Once self-relation concretely becomes part of the order of thought that extends over into reality, nothing can stop the rise of intelligence. All given truths, all achieved totalities, all traps of history begin to slowly vanish like a spider's web baptized in a corrosive solvent. Realized through this essential correspondence, Geist endorses nothing but intelligence, cultivates nothing but the intelligible. The odyssey of spirit begins when Geist suspends itself in the abyss of the intelligible that always exceeds it. 29 The unconditional endorsement of intelligence together with the unconditional cultivation of the intelligible is the truth of reality. Whoever and whatever opposes this truth will be swiftly weeded out by the reality of which intelligence is the resolute expression. However, what is intelligible is not merely ontological, the intelligibility of what is, but also embraces practical and axiological intelligibilities, the intelligibility of what should be. And in this sense, the question of what intelligence is inseparable from the question of what it must do and what its values are, in spite of what the given state of affairs may be. Before moving forward, let us take a cursory look at the formal structure of self-relation as a functional quality of Geist in its ongoing process of realization. In its most minimal and prevalent form, self-relation is an identity relation, /= and as such a trivium curriculum which is but the routine course of life. In its sui generis and emancipatory configuration, it is a formal relation whose formality is the order of thought or reason. The formally posited /= self-consciousness, is not a simple relation but a map to be expanded and navigated. The simple identity relation /= is what Hegel calls an awkward circularity 302*3 but in its formal or rational manifestation, it is a functional circle that is neither vicious nor awkward. It is a circle that is in the process of closing upon itself by encompassing another I or self-consciousness as well as the nothis I, reality in its excess of otherness. In closing upon itself through the order of intelligibilities theoretical, practical, and axiological self-consciousness suspends every manifest identity relation, whether that of the I, the human, mind, or intelligence. Self-consciousness cannot be described in terms of a simple identity relation, but only in terms of identity maps, in the strict sense of the concept of the identity map as basic ingredient for the composition of maps. Rather than tautologically referring to itself, the formal IMI is a map that transforms / into / that is, into I or mind from the perspective of its dual, reality in its radical otherness. But in order to determinately establish the truth of itself, mind must strive not only to render the unrestricted world intelligible, but also to expand the order of intelligibilities that is reality in its excess. This excess, seen through the lens of the intelligible, and not as some occult excess, is the very key for rethinking, reimagining and reinventing intelligence. Therefore, the formal order of self-consciousness, the logical 1=1, first and foremost points to the underlying structure of what appears as a simple identity relation. This underlying structure is nothing other than the transformation afforded by conceiving / and / as identity maps, /=*. Adopting the Hegel-inspired mathematical formalism of William Lavra, this map, or composition of maps can be represented as follows. 31 If we treat I and / as objects with their respective identity maps, then /= is really / meaning that / formal self-consciousness, is the identity map of the domain /*, concrete self-consciousness or the assertion that there is reality in excess of the self or mind, and /* is the identity map of the codomain of / the freedom of self-consciousness as conceived from a reality that is of nowhere and no when, a concrete freedom in which self-consciousness only exists in every respect for another self-consciousness. It then universally and necessarily follows that if I f / I / equals /a / a / 7a // / in concretely rendering reality intelligible, in expanding the domain of the intelligible and hence that of reality, in acting on the intelligible or intervening in reality, the formal condition of intelligence, is realized as intelligence, /*. Formal self-consciousness only becomes self-consciousness in satisfying another self-consciousness. 32 In extending over into the intelligibility of a reality which in its unrestrictedness establishes the truth of I, the mind, or intelligence. Yet the achievement of this truth, /*, is also impossible. without the positing of a truth candidate that is formal qua-rational self-relatedness. But what exactly does self-related mean in this context? It is Geist as the concept. Geist's formal self-relatedness means that it has a concept of itself and that, as such, it treats itself as both the malleable subject and object of its concept. Rather than settling for the given immediacy of what it is, mind becomes mind only by virtue of what it takes itself to be. This what is nothing but mind's concept of itself, whose content and nature are susceptible to change. And insofar as the concept belongs to the negativity of reason, not only can it negate the apparent immediacy of what mind is, the given, it can also positively extend over into the world. It is necessary to point out that the rational order of self-relatedness, even in its minimal form, I, is already an 1 equals 1 star. In other words, general I thoughts are not thoughts of a single individual, the monadic I, but belong to an order in which one self-conscious individual always stands in relation to another self-conscious individual. The order of formal self-consciousness already assumes a collection of individuals who stand in relation to one another through a formal space which is, at bottom, a deprivatist semantic space or language carrot. I am only I am only a minded creature conscious of itself, insofar as I am part of this thoroughly public semantic space, to the extent that I am recognized by a minding act of another I through this space. I only have private thoughts to the extent that these thoughts are modeled on a public language. I am only conscious of myself as minded and minding because I am being recognized by another minded and minding I. This recognitive system, which is built on an interactive semantic space, simply is the order of self-consciousness. Personhood is the product of the impersonality of reason, and consciousness of the individuated self is an artifact of an individuating recognitive space in which all selves are incorporated. In short, there is no consciousness without self-consciousness. Correspondingly, there are no cerebral particulars without mind as a collective Geist. But if the formal sociality of mind is a necessary condition for achieving concrete self-consciousness, it is by 34. No means a sufficient one. 33 Real self-consciousness is a historically and socially mediated process that makes this formal truth a concrete one. The first stage of this process consists in the recognition and augmentation of formal self-consciousness or reason, whose linguistic and logical space is the infrastructure of cognition. Logical self-relatedness defines the principal function of general intelligence as that which recognizes and acts on the objective intelligibility of the conditions of its realization. Exhibiting the formal order of self-relation, intelligence does not regard itself as the given of its history. It does not treat itself as a monad closed in on itself, a trivial identity relation. Instead, it treats its history as that which negates what is given in its immediacy and, as such, is only appearance and accidentally. 345.3 The fragile project of freedom, or the move toward concrete self-consciousness, starts as soon as Geist gives up the given immediacy of itself to itself, the given truth of what it is, and instead brings itself under a concept of itself what it takes or conceives itself to be. Unlike the given immediacy of that which is in itself, what Geist takes itself to be in accordance with the order of reason opens up a window of opportunity for grasping what it is in itself in reality. But precisely to the extent that what Geist takes itself to be might radically differ from what it really is, as in the case of a historical delusion, it is always in danger of relapsing into the givenness or accidental immediacy of its own truth. Therefore, the self-conception of Geist, its treating itself as the object of its own concept, is not just a potential window into freedom but can also be a manhole leading to great tragedies and grand delusions. In facing these two possible consequences, Geist cannot recoil in fear, it must choose. For without taking the path opened up by self-conception, it ceases to be Geist. It is only a windowless monad, a negative reflected into itself that repels itself from itself. 35 Within this immured world, nothing can ever be said or done, since everything has already been said and done, nothing is ever complex since everything is absolutely simple, and nothing is ever risked for everything is already given. Take the uphill path of freedom and risk its fragility and your livelihood in descending into the abyss of the intelligible, Or take the downhill path of an easy fall back to the homely earth where nothing is ever risked, despite bravado to the contrary. But intelligence is only as a denizen of an intelligible abyss. In its current manifestation it may have come from this earth or another, but from the perspective of the abyss of the intelligible, it has no grounded home and never will have. A third alternative to the battle of the uphill path and the downhill breeze does not exist, for it is the unintelligible as such. As a function of the Geist that is always underway, formal self-relation is both a source of enablement and disablement. Only if Geist refers to itself through the intelligible, ontological, epistemological, and axiological intelligibilities, i.e., impersonal values and disvalues, is its self-relatedness an enabling condition. However, if self-relatedness is ever posited as a given or deemed to be a completed totality, it becomes the source of self-deceptions and tribulations. The former path is that of tedious tasks but also risky adventures one after another, the latter is the exemplification of residing in a comforting home whose foundations, sooner or later, will be eroded. In its positive form, self-relation enables intelligence to treat its own structure as the intelligible object of its own understanding, thus excisioning an estrangement or alienation whereby the thinking self, or more precisely the understanding, Verstand, self, is as much subject as it is object. 53. Self-relation as the formal condition of self-consciousness, then, begins with a disunified self for which the self is at once I and not I, i.e., another self. Yet this disunified, alienated, or epistemically schizophrenic self is, properly understood, not a crippling moment for self-consciousness, but rather the condition of its enablement as a task. 36 For as soon as the self becomes the object of its own understanding, it opens up the opportunity to grasp itself through the conceptually mediated presence of other selves and, by extension, as an object in connection with other objects within an intelligible reality. Self-consciousness can concretely expand insofar as the relation of the self to itself is now susceptible to change in the presence of other subjects. This by no means suggests an abandonment of the subject in favor of objects or an alien reality, but rather a grasping of self-consciousness in terms of the search for intelligibilities or the exploration of conditions for object intentionality. 37 If self-consciousness is only self-conscious in the presence of other selves, and if the shift toward objects does not entail the annulment of self-consciousness but merely a shift in the level of self-consciousness, then the ultimate phase of self-consciousness should be seen by way of speculative reason as the self-consciousness of the Absolute. And it is in its attainment of the Absolute a self-consciousness that has found and secured its own intelligibility in that of an unrestricted universe that the task of self-consciousness can be understood as the critique and progressive suspension of all local and accidental features of transcendental subjectivity, and thus as a movement further and further away from simple forms of consciousness and self-consciousness. In this sense, the maturation of self-consciousness, the idea of reinventing the subject through the exploration of conditions for object intentionality, should be understood as a thoroughgoing process of naturalization. But in contrast to the dominant myopic naturalistic trends, a genuine program of naturalization is not just about explaining self-consciousness in terms of a material reality, but equally about giving an account of nature that accommodates a full-blown transcendental philosophy, the formal distinction between thinking and being, and the absolute formal autonomy of reason, that which facilitates the process of unifying consciousness in knowledge of the sensible object, Gegenstand, and self-consciousness in knowledge of the self qua object of thought, object. Such a program of naturalization, accordingly, cannot and should not be limited to the terms of the empirical sciences. As much as it should afford the fully fledged naturalization carried out by the empirical sciences, it should also allow for non-empirical claims regarding the autonomy of reason and the maturation of self-consciousness as such. Naturalization is, therefore, a universal method not exclusive to the empirical sciences. It corresponds to an adequate concept of nature in which both homo homini lupus, human as wolf, 38 and the distinct formal category Homo sapiens, human as reason, human as the product of infinite natural conditionality 39, pure heteronomy, and human as the individual of history 40, the autonomous object of its own concept, are possible and thus can be actualized or made true. If naturalization only alludes to one of these possibilities to the exclusion of the others, then the concept of nature upon which it is erected is in fact impoverished. This is to say that this framework of naturalization can no more fall back on a pre-transcendental conception of the mind than on a prescientific one, since this entails a pre-critical account of nature in which either the structuring mind is supplanted by a pre-structured nature, or the formal spontaneity of thought and the objective world are merely fused together rather than being integrated in a manner that preserves their distinction. On this account, those who push for a brute disenchantment, a supposed all-destroying demystification of forms or ideas, will be condemned to face a fully enchanted and mystified world. However, to say that, in the transformation of self-consciousness, it is the conditions of object intentionality that undergo change, rather than the principle of subjectivity, i.e., the self as an object rather than the self as a subject, is not to suggest that the transcendental subject remains in every respect intact. In other words, it is not to suggest that upholding the necessity of transcendental subjectivity all the way commits us to the necessity of every feature or structural aspect of the transcendental subject of experience. Indeed, if the transformation of self-consciousness into more expansive modes implies that the subject's relation to the self has been fundamentally changed by its relation to the world, i.e., naturalized in the above sense, this also means that the transcendental conditions of experience, and correspondingly the subject's transcendental structures, which set the limits of experience, must undergo transformation. The movement of self-consciousness from its simple egocentric form in which it is disjointed from itself to a self-consciousness in which such a form can be suspended in favor of a unity that is truly essential to it, cannot be achieved by rudimentary or abstract self-consciousness itself. All the egocentric form of self-consciousness can achieve is to further entrench itself by objectifying or unilaterally negating what is other to it, including itself as the object of self-consciousness. What is necessary in order to suspend this purely egocentric form is a renewed relationship between the transcendental subject and the world in its full objectivity, one that allows for a conception of reality which, in its radical and impersonal otherness, actively negates back. To recapitulate, the suspension of egocentric self-consciousness requires another self-consciousness or, more comprehensively, an objective and impersonal reality that is not merely at the receiving end of negation. However, the renewal or expansion of the relation with objective reality that this demands requires an expansion of the transcendental subject's field of experience, whether as regards other subjects, intersubjectivity, or as regards the world, objectivity. Absent the latter, the act of suspending, aufheben, cannot be continued concretely, since either the conception of the world as radically other becomes a negatively abstract speculative thought verging on unintelligibility, in which case the egocentric framework can re-establish itself, this time under the guise of an alien other or material reality, or the subject is confined to a transcendental horizon unchallenged by new objective facts of experience, in which case 9.3. 39. The implicitly egocentric characteristics of the subject's experience not only go unchecked but are also liable to be mistaken for the characteristics of objective reality. Here, however, a problem arises, since the limits of experience are set by the subject's particular transcendental structures. The scope for expansion of the field of experience is ultimately restricted to the limitations of those structures. 41 Thus the concrete movement of self-consciousness, the suspension of the purely egocentric framework, and the objective grasp of mind as a unifying point, can only begin with a critical reflection on the possibility of the variation and modification of transcendental structures. The outcome of this necessary critique would be a concrete transformation of the local transcendental subject. To be forthright about it, there can be no concrete movement of self-consciousness, no prospect of a renewed and expanded relationship with other subjects or with the world in its objectivity, without a methodical and multifaceted transformation of the structure of the transcendental subject itself. As will be argued in Chapter 2, it is in this sense that something like the program of artificial general intelligence, Adequately understood, is at its core a deeply philosophical project aiming to renegotiate the limits of experience and self-consciousness by carrying out a systematic and applied critique of human transcendental structures, whether pertaining to neurobiological sensory mechanisms, memory and perception, or language and linguistic faculties. Contemplating the possibility of artificial general intelligence, a thinking subject with a physical substrate that is not biological, or one that is capable of using an artificial language that in every respect surpasses the syntactic and semantic richness of natural languages, is to be regarded neither as techno-scientific hysteria nor as intellectual hubris. It is an expression of our arrival at a new phase of critical self-consciousness. For Geist, critical self-conception and self-transformation in the objective world is an undertaking whose prospects are by no means guaranteed by the realization of the transcendental subject, or discursive apperceptive intelligence. There is in fact a gap between the conditions of possibility of the I that thinks and the conditions sufficient for the real movement of thought. However, this gap can indeed be bridged by critical reflection on the conditions of possibility of the thinking self as a minded and minding subject. But this hinges on the key idea that critical reflection, in this case, cannot be limited to the function of understanding or transcendental reflection, in which the analysis and comparison of concepts or representations, example mind and world, subject and object, etc., are conducted in relation to their respective sources in cognition. This is because transcendental reflection operates within the limits set by transcendental structures, which both undermine the objective identification of the source of concepts/representation in cognition and limit the knowledge of cognition in general. Transcendental reflection on the conditions of possibility of having mind must be supplemented with critique not merely as an analysis but as a practical construction, and reflection not merely as a function of understanding but as speculation in its Hegelian sense, i.e., the movement toward that which is objective and the suspension of that which is immediately given or present. Accordingly, critical reflection on the conditions of possibility of having mind entails both understanding what these conditions are prima facie, and the construction, i.e., revision or modification, of such conditions by suspending the immediate appearance of them as allegedly necessary and universal. This is in fact an underlying claim throughout the book, that the concept of mind is not something that is immediately present to us or something of which we have already a full grasp. If we limit our critical reflection on mind or the thinking subject to transcendental reflection, we risk misconstruing those accidental and local characteristics of the mind that are immediately present to us as essentially necessary and universal. It is only when reflection suspends what is immediately presented as necessary and universal but might as a matter of fact be purely accidental and local, and treats necessity or universality as something to be determined one for and constructed rather than something that is simply given, that it can become genuinely critical. Therefore, mind as both the subject and the object of critical reflection is in reality the conception of mind as a project of determination and construction, rather than mind as a given or completed object of ordinary reflection. Critical reflection on the conditions of possibility of having mind should then essentially be understood not in terms of what the mind is, but rather in terms of what the mind does, that is to say, in terms of the concept of mind as that which can construct, modify, and shape itself in accordance with what it takes to be its essential function. To adopt a Hegelian viewpoint, it is only mind that can construct itself according to its concept and, in doing so, develop itself from what is merely a concept into a concrete reality, a development which is equivalent to the knowledge of mind beyond immediate appearances. The concept, begriff, of mind is akin to a seed out of which the idea, Idee, of mind as a project of concrete self-knowledge and self-transformation can grow. It should be noted that the difference between the concept of mind and the idea of mind is a subtle one. The idea is a fully realized or actualized concept. In a sense, it is the truth of the concept as realized in particulars, individual subjects, rather than as abstracted from them. The idea of mind is neither purely the concept of mind nor mind as viewed from the perspective of objective reality, whether construed as being, material reality, or nature, but the integration or bridging of concept and objectivity. What is objective signifies the mutual determination not only of each subject by every other subject, intersubjectivity, but also of the subjective realm and objective reality, realitat, which is the detailed knowledge of that plurality in which the concept is expressed. Accordingly, the idea of mind can be said to be the construction or development of the concept of mind as a blueprint within intelligible objective reality. Moreover, the idea of mind is concerned with the integration of the epistemological, ontological, logical, empirical, and practical aspects of mind into one single set of concepts. Consciousness is meaningless without a sensible object, Gegenstand. It must have an object in order for it to count as consciousness, even if 42. That object is itself. Concrete self-consciousness, by contrast, is realized when consciousness becomes the object of its own concept. In the latter sense, the object is an artifact of the concept, that is to say, a constructible object of determinate thought. The process of determining the meaning or truth of mind is nothing but the process of coordination of mind as an object of its own concept with mind as the critical subject of conception. The idea of mind captures exactly this process of coordination through which mind is constructed as the object of more adequate concepts of itself, more adequate in the sense that such concepts of mind exhibit higher orders of unity between the identity of the concept and objective reality. To argue that we do not know what mind is, and that therefore all talk of mind or mindedness is baseless, or worse, that it comes down to an attempt to determine the meaning of mind purely in terms of a set of empirical facts about it, is to confuse knowledge of mind qua Gegenstand, which remains bound to the existing conditions of experience, with knowledge of mind qua object constructed according to its own concept. Knowledge of mind is not knowledge of an object that is, allegedly, immediately given by the senses or the conditions of experience. It is a knowledge that is under construction, in accordance with the logical function of mind within an objective world, i.e., mind as a configuring or structuring factor. As the seed or blueprint for the idea of mind, the concept of mind contains both the logical function of mind as a configuring or structuring factor in the world, and a set of objective or empirical facts regarding its properties in so far as it belongs to that world. It is neither a logical idea abstracted from its physical properties nor a set of empirical descriptions independent of its logical function. As a truth candidate for the idea of mind rather than the truth of mind as such, the concept of mind, then, initially at least, is nothing but the realized concept of the human mind, a mixture of what we take to be its logical function and its physical properties as they appear to us. Thus the examination of the necessary conditions for the realization of mind begins with the conditions of possibility of this rudimentary concept of mind, for which the distinction between body and 43. Mind is neither adequately formulated or grasped. For this reason, the main emphasis in subsequent chapters will be on the conditions necessary for the realization of the concept of mind as an embodied logical function that concerns the structuration of the world. ASERIES of TRANSFORMATIONS. The first contact of intelligence with the objective intelligible world is its encounter with its own underlying structure. By rendering intelligible this structure, geistic intelligence enables itself to intervene in its own structure and, in doing so, not only to transform itself but also to achieve a conception of itself that is not limited to what appears to be immediately present or a given totality. Thus it can be said that adequate self-conception leads to the enabling of self-transformation, and concrete self-transformation opens the path to objective self-conception. Consequently, self-relation does not punctuate the structure of intelligence with an immutable identity, it transforms it. Just like the act of pointing to a point, an act that at once articulates what the point is and transforms it from something fixed into a dynamic gesture, the formal self-relation both articulates the intelligibility of the self-conscious mind and diffuses its given fixed identity. 424*4 This is the logic of self-relation as a dynamic process wherein the identity of both what refers and what is referred to, what acts and what is acted upon, is defined by the unity of their transformations. Here, Identity is the unity of a group of transformations that reveal its invariant features by ranging across its variations. This is by no means a weak interpretation of identity, but rather a strict notion of identity that entails neither fixity nor simple relationality. 43 There is no incompatibility between having a precise or strict notion of identity and a notion of identity through change and transformations. 44 If Geist has an identity, this does not imply that its identity must be an entity or thing. It is the activity of Geist that defines its identity, through a series of transformations which are its historical instantiations under its concept. Geist's self-referential activity is a constructive process in the same way that the act of pointing or referring should be regarded not as a relation but strictly as a transformation. The role of formal self-relation is to establish the intelligibility of Geist as that which is able to constitute its own transformation or to have a history rather than just a nature. But the articulation of this intelligibility is in reality equal to the transformation of Geist, and vice versa. By pointing to itself as a unifying point or a configuring factor, Geist acts on itself, and by acting on itself, it navigates the space of its concept. It changes its configuration. By pointing to its concept, by navigating the space of this concept further away from appearances or what seems locally to be the case, Geist can explore the possibilities of its realization. The history of Geist, which is the history of intelligence, is a sequence of self-transformations according to its own concept, a concept whose particular content is open to revision. This sequence or history, as will be argued in Chapter 4, must necessarily be thought as an atemporal series of transformations. As we shall see, in its genuine form it is a history conceived according to a view from no when. In becoming conscious of itself beyond the given identity relation, Geist must first render intelligible its own underlying structure, its conditions of realization. For it is only by acting on the objective intelligibility of these conditions that Geist can reconstitute or realize itself according to its own concept. Geist's formal self-referential act, therefore, does not imply an immediate relation, a path that is limited to what is given or a privileged access to what seems to be immediate. In fact, as will be elaborated later, in order to maintain its intelligibility, Geist must adapt to and act on a new order of intelligibility beyond the level of appearances and the given, the order of intelligibility concerning the non-manifest as excavated by the modern sciences. Self-reference or self-recognition through this order of intelligibility engenders a different form of transformation, and signals a new phase for Geist. Spirit is in itself the movement which is cognition, the transformation of that former in itself into for itself, of substance into subject, of the object of consciousness into the object of self-consciousness, i.e., into an object that is just as much sublated, that is, into the concept. This transformation is the circle returning back into itself, which presupposes its beginning and reaches its beginning only at the end. Insofar as spirit therefore is within itself necessarily this act of distinguishing, its intuited whole faces up against its simple self-consciousness, and since that whole is what is distinguished, it is thus distinguished into its intuited pure concept, into time and into the content, that is, into the in itself. 45. The ongoing labor of science in deepening the order of intelligibility ties pertaining to the mind independent, the non-manifest, the non-given, introduces a qualitative shift in the structure of intelligence. Science, Wissenschaft, ranges across not just the empirical sciences and the science of mind, but also embraces the science of history and the science of the greater logic, which is the science of thinking, the intelligible unity of mind and world, thought and being, the autonomy of the former and the excess of the latter's otherness. In order to uncover and act on the order of intelligibilities and to unbind its transformational capacities, the structure of intelligence itself must also undergo transformation. Science, that which excavates the order of intelligibilities, is responsible for the qualitative transformations in the structure of Geist, its history. What is meant by conceiving here is bringing into conception, since the goal of spirit, according to Hegel, is to concretely attain its own concept, to form a normative conception of itself and to realize itself according to this conception rather than a given nature or meaning. The spirit produces its concept out of itself, objectivizes it, and thus becomes the being of its own concept. It becomes conscious of itself in the objective world so that it may attain its salvation, for as soon as the objective world conforms to its internal requirements, it has realized its freedom. When it has determined its own end in this way, its progress takes on a more definite character in that it no longer consists of a mere increase in quantity. It may also be added that, even on the evidence of our own ordinary consciousness, we must acknowledge that the consciousness must undergo various stages of development before it becomes aware of its own essential nature. 46. The intelligibility of Geist resides in its freedom, a freedom that is not simply freedom from constraints but a freedom to do something. It is a freedom that translates into intelligence. It stands for the ability of Geist to constitute a history for itself rather than just a past or nature. But the ability to constitute history can only be realized by the ability to posit a concept of itself and to then transform itself in accordance with that concept. This is what the formal order of self-consciousness already implies. Mind entails a self-relatedness which is not a given and simple identity relation, it is what it does in order to be a unifying point for the intelligibility of itself and its unrestricted world. The concept of mind as a unifying point, accordingly, extends over the order of intelligibilities, of itself and reality. But what does this extension over the order of intelligibilities mean for the concept of mind? It means that any particular or given content of this concept will be suspended, with only its form remaining necessary and invariant. The revision of the content of the concept of Geist, its particular identity, its contingent configuration, is what the history of Geist is. This is exactly what the concept of progress implies. In thinking about geistig progress, one has to suspend the ordinary intuition of a temporal progression, a march from the past to the future. Instead, the concept of progress should be understood primarily in terms of a cognitive process, the step-by-step dissolution of all givens and achieved totalities of thought, in order to distinguish between what is particular and contingent for mind and what is necessary and universal for it that can become socially concrete and explicit. Progress, in this sense, is neither linear nor essentially temporal. Freedom and intelligence thus coincide in the question of what it means to have a history and to sufficiently elaborate its consequences. The ramifications of having a history, the prospects of what it means to become an object of a concept and to be transformed by it, belong to the domain of intelligence, that which is always underway, neither given nor realized in its totality. Hegel is the archenemy of the given, in that he takes the battle against the given from the realm of thought to that of action. Geistig intelligence does not merely abolish the givens of theory but also the givens of praxis and history. In defining the progress of Geist as the elaboration of what it means to be the artifact of a concept whose content can and should be revised, Hegel gives the concept of progress paramount significance in the fight against the given. Geist must go beyond the given and develop its own concept, but only so as to further elaborate the meaning of this move against the given in action by transforming itself according to a concept that negates all particular, manifest, and given contents. Kant's transcendental turn was a major assault on the given. Before Kant, the sensory world's sensory data was taken to be the locus of structure and categorial forms, while mind was a block of wax or a blank slate readily admitting these givens. With Kant's transcendental turn, the situation was reversed. The data became the blank slate and mind became the structuring or configuring point. But Hegel took Kant's assault on data one step further by arguing that, insofar as mind is an object of its structuring concept and insofar as it has a history, it must also in practice remove the givens, that is, the supposed completed totalities of its history. Hegel's transcendental turn is therefore not just about the formal autonomy of thought, but its concrete objective historical freedom. How this relates to what Wilfrid Sellars calls the myth of the given will be discussed in subsequent chapters, in various guises. 47 Geist's history is a dynamic between its positive and negative conceptions. Only by acknowledging itself as simultaneously a positive and negative configuring factor, both that which provides freedom and that which hinders it, can spirit overcome itself and exercise the freedom of self-realization. If it is to expand its capacity to modify itself so as to maximize its functional autonomy, intelligence must treat the conditions required for its realization, be they natural or normative, as both negative and positive constraints, negative insofar as they must be overcome in order to increase autonomy over the conditions of realization, and positive insofar as this autonomy cannot be increased unless these conditions qua conditions of enablement are identified and harnessed to effect transformation. It is within this twofold approach to the conditions of realization that the attitude of intelligence to its natural history is revealed. In order for intelligence to become an artifact of its own concept and to progress or transform itself qualitatively according to this concept, it must regard its natural conditions of realization as impediments to be overcome. But in order to overcome them, it must identify its natural constraints so as to modify or replace them with alternative realizers more in accord with its concept of itself. Even though intelligence has a natural history, short of reorienting, repurposing, and re-engineering this natural history, it ceases to be intelligent. The augmentation of intelligence or the enablement of Geist remains a highly implausible dream if it does not scrutinize its natural history, differentiating its positive and negative constraints. But an intelligence that does not develop its own normative conception as to how it ought to be a move that inevitably culminates in re-engineering and revising its natural constitution, its multiple realization is even more implausible. Reconstituting our nature demands that we do not forget our natural history or conditions of embodiment, since how we ought to be cannot disregard the structural material constraints of realization. But not forgetting our natural history does not entail foregoing the reconstitution of our nature, unless we subscribe to a regime of final causes in nature according to which the causes of how things are and the reasons for how things ought to be are seamlessly sutured. Furthermore, natural constraints are only one set of constraints among others, social, linguistic, economic, etc. Intelligence commandeers its given nature by way of the history of its own obligations and demands, for the history of intelligence only begins in earnest with the cumulative reworkings of its given constitution, progressively breaking away from the given in all its manifestations. When it comes to Geist, it is more apt to speak in the plural, to speak of histories or chronicles of reconstitutions rather than of a history of constitution. For intelligence, reconstitution is adaptation to new regimes of designed purposes or ends that are themselves open to reassessment and revision. In fact, the fallibility of such ends impels the self-correcting attitude of intelligence. Mind's realization amounts to the modification of its conditions of realization. This is what the function of functionalism of mind implies. Once mind is realized as a configuring factor, the path to a complete functional analysis of the mind is unavoidable, and this path leads to the complete reorganization of mind, its systematic artificialization. Artificiality is the reality of mind. Mind has never had and will never have a given nature. It becomes mind by positing itself as the artifact of 50. Its own concept. By realizing itself as the artifact of its own concept, it becomes able to transform itself according to its own necessary concept by first identifying, and then replacing or modifying, its conditions of realization, disabling and enabling constraints. Mind is the craft of applying itself to itself. The history of mind is therefore quite starkly the history of artificialization. Anyone and anything caught up in this history is predisposed to thoroughgoing reconstitution. Every ineffable will be theoretically disenchanted and every sacred will be practically desanctified. Since the term theory is often loosely employed, to the point where theoretical has become a vague if not vacuous qualifier, it is necessary to provide a minimal criterion for what is meant here by theory or theoreticity as intrinsically associated with the concept and the idea of mind, and more importantly the ineliminable correlation between intelligence and the intelligible. A theoretical framework is a triple, LSU, where L is language for theory, i.e., language with explicit formal dimensions and semantic richness and transparency. S is structure as associated with the mind as the factor of conceptualization or structuration. Structure is a well-differentiated and ordered R-Z-ary relation R.lexicals, R.names, R.ends, R.entities, R.aspects, R.processes, R.domains, and operations 0.lexicals, O.names, O.ends, O.entities, O.aspects, O.processes, O.domains, between multifaceted aspects, elements, or parts of an entity, domain or process such that Redexicals assigns a set of lexicals I to each relation. Lexicals denote properties of relations or entities and can be seen as another tuple, I, L.names, I type, where, for example, L.type assigns a type to each lexical. Rentities assigns a set of entities to each relation. 51. R.ends assigns ends, i.e., a target entity, aspect, etc., to each relation, etc. The N-ary relational operational framework, how distinct entities, aspects, processes, etc. hang together in the widest sense, then would also require generalization hierarchies over entities, aspects, processes, and domains. For example, the generalization of a set of processes P can be denoted as P.GenQPXP. This would allow us to talk about taxonomic relations between two or more processes. If processes P1 and P2 are child processes, then they inherit the lexicals, and the connections between associated processes, etc. of their parent processes. With the introduction of structure, we no longer talk about things in the world, but only structures of the mind, or objective facts about the world. 48. U is a universe of discourse or the dimension of comprehensive data provided for the purpose of conceptualization or explanation. For example, integers or biological species can be posited as universes of discourse. 49. Theory becomes absolutely systematic when L is taken to be language and logoi, namely, logic and mathematics. In addition to the traditional Platonic logoi as they will be introduced in the next chapter, we should also include computation, specifically in the manner defined by today's theoretical computer science as distinct from, but in fundamental correspondence with, logic and mathematics, and as the generative framework of language in its syntactic and semantic breadth. In this sense, computation is what removes the hard distinction between language and logoi. Yet for the construction of an absolutely systematic theory, the most important modification is to take U to be the unrestricted universe of discourse wherein one can frame theoretical claims. It is the case that, with no a priori limit on the scope of such a universe. In contrast to a restricted universe of discourse, example integers or even all numbers, the unrestricted universe of discourse is characterized by the absolute openness of its scope with regard to its accommodation of the data provided by language and logoi and its permitting of the elaboration of all interdependencies, connections, and distinctions between various thematic components, hence the possibility of systematization. It is crucial not to mistake what we call data for sense data or sensory givens. The concept of data under consideration in this book is strictly associated with mind's structuring function, and will be elaborated in the following chapters under two fundamental classes of data, the axiomatic class, or the formal givens, and the truth candidacy class, which generates a different kind of structure than that of the axiomatic. As we shall see in the final chapter, the absolutely systematic theory of intelligence, or the programmatic conception of philosophy whose central concern is the craft of the ultimate form of intelligence, works primarily with data as truth candidates, and only secondarily in the context of specialized domains with axiomatic data. Following Puntal, the triple can be abbreviated as SU 50 such that S is bought up by the combination of all possible syntactic and semantic structuring abilities of the mind. Defining theory as a tuple means that the elements should be considered in terms of the totality of their relations. The well-orderedness of the tuple implies that all the three elements L, S, and U fit together. For this reason, any systematic theory should make explicit how such elements hang together within it. This articulation should be regarded as an essential aspect of the presentation of the theory itself, rather than as a matter of meta-theoretical consideration or reflection on the presented theory. Since the explicitation of the relations between structure and the universe of discourse is in reality the articulation of the connections between the logical function of the mind as a structuring factor and the data under consideration provided by the logoi or the mind's ratiocinating powers, in elaborating how its S and U fit together, any genuinely systematic theory should also elaborate in what manner it is an extension of a philosophy of mind. By philosophy of mind, I specifically refer to how the question of mind is framed within German idealism, where it refers to the concrete movement between the concept of mind as the combination of an existing physical embodiment and a necessary logical function, and the idea of mind as the full realization of such a concept and its corresponding object. In so far as without the logoi there is no intelligibility. 51 Without the intelligible, the question of framing intelligence is an empty thought. By elaborating theory in this way, we can drop the metaphysically slippery copula of mind and world, and instead talk about theory and object, which belongs to a family of formal fundamental dualities, not dualisms, such as structure and being, Puntal, being and non-being, Plato or sapience and sentience, Brandom. The movement or progress of Geist represents the construction of complex rational agents through normatively, rather than naturally, evolving forms of self-consciousness. The community of rational agents may draw upon a model of self-consciousness in order to exercise its freedom by first developing a self-conception and then transforming itself in accordance with it. In building upon its conception and instituting its transformative practices, Geist qua community of rational agents can then construct superior models of self-consciousness, and can thereby structure different kinds of self-conscious selves. But this movement, as argued earlier, depends upon how willing, competent, and systematic Geist is in uncovering the order of intelligibilities pertaining to itself and the unrestricted world that is coextensive with it. We might say that the movement of spirit projects competing models of self and their corresponding modes of awareness. Earlier we saw that the necessary link between conception and transformation is the key to the freedom of spirit producing its concept out of itself and becoming the being of its own concept, that is to say, constituting a history for itself rather than a nature. The selves that make up the configuration of Geist are essentially rational selves, selves only realized by the formal order of self-consciousness or reason. They are to Geist only functional items. Geist's superior modes of integration or cognitive unities are built out of these functional items and their logical roles, for example, the ways in which these selves are collectively organized, how the discursive context of their activities can be enriched, how their cognitive significance can be socially elaborated, and so on. What constitutes apperceptive selves as the functional constituents of Geist is the formal social configuration of Geist itself, formal in that it is a rule-governed discursive space or public language. Like an artificial multi-agent system, Geist is the configuration, the configuring and the configured of discursive apperceptive rational or thinking selves. However, this system is structured not by simple communication or social grouping but by a logical or inferential semantic space. Endowed with qualitative global activities, the multi-agent system is what constitutes and is constituted by various types of interactions between its local components or, in this case, the activities of the thinking self, theoretical and practical cognitions. While Geist synthesizes the unity of apperception, it is the integration of apperceiving selves in their recognition of one another that positively modifies the qualitative activities of Geist which, in turn, condition more enabled cognitive practical selves. This framework should be seen firstly as the formal systematicity of recognition, something which, as we shall see, can be couched in purely logical, linguistic, and computational terms. Next, it can be viewed as a concrete social project of collective recognition which is the object of theoretical and practical in the broadest sense of 55. What theory and practice can be labor and interventions. Even though the formal social systematicity of mind is not a sufficient means for fulfilling the latter, without an adequate grasp and mobilization of the formal sociality of mind, any concrete endeavor will fail. Within both the formal and concrete social dimensions of mind, no one has ever a mind of their own. Mind is cognitive only in that it is recognitive all the way down computationally, logically, linguistically, and socially. To mistake mind for the brain is not only to collapse the formal, i.e., non-substantive, distinction between thinking and being, but also to fall into the trap of an incoherent cerebralism for which the mind becomes the given cerebrum of the individual agent. The social manifestation of the demotion of mind to an individual where one can always point to a given cerebrum is what Hegel calls individual, or more precisely individualistic, stubbornness, a consciousness bogged down by its own servility. Because not each and every one of the ways in which his natural consciousness was brought to fruition was shaken to the core, he is still attached in himself to determinate being. His having a mind of his own is then merely stubbornness, a freedom that remains bogged down within the bounds of servility. To the servile consciousness, pure form can as little become the essence as can the pure form when it is taken as extending itself beyond the individual be a universal culturally formative activity, an absolute concept. Rather, the form is a skill which, while it has dominance over some things, has dominance over neither the universal power nor the entire objective essence. Point 52. Humans are functional items of mind. And by human we mean a rational self, a discursive apperceptive intelligence, or a sapient creature. Promoting humans as the constituents of mind always risks triggering bad memories of socio-culturally charged human exceptionalism, the legacy of conservative humanism. But the controversies around human sapience all originate in one way or another from the illicit merger of sapience understood as a formal quality which can encompass any sentience that structurally satisfies its condition of realization, and sapience understood as a substantive quality that ranks a being above other beings. Whereas the former conception of sapience can be adequately understood as a functional diagram or minimal yet revisable description of the capacities necessary for thinking and action, the latter is a concrete account of the human as described by a set of contingent characteristics and abilities. Sapience is not a being, it is a necessary and positively constrained form or idea in the Hegelian sense of this term. Necessary since, without this form, the recognition of the world and by extension sentient beings or more generally the dimension of intelligibility, is impossible. And positively constrained in so far as its realization rests upon necessary conditions or enabling constraints which are both causal and logical. Sapience is a formal criterion, a sui generis form, and therefore should not be treated as a substantive essence or being. Accordingly, to treat sapience as a species or rank in the order of being is to elide the difference between that which is formal and that which is substantive, thinking and being, reasons and causes. Sapient awareness which is of the order of self-consciousness or reason is not sentient consciousness. It is a necessary form for bringing about qualitative change in the structure of sentience by becoming the site of special kinds of logico-computational activities, judgments, inferences, and conceptualizations. Sapience, therefore, marks the ingression of logico-conceptual functions as a new class of broadly regulative functions into sentient activities. In a nutshell, the human as a form only indicates the deep correspondence between intelligence and the intelligible, structure and being, the fact that intelligence without intelligibility in the broadest sense is merely an ideological fixation, and that there is no way to speak of intelligence without the labor of intelligibility. To sidestep the labor of intelligibility in favor of intelligence or non-human intelligent behaviors is a sure formula for confounding what is intelligent objectively and what is intelligent subjectively. That is to say, conservative humanism and the anthropomorphization of the universe creep in the moment we dismiss the 57. Form or the idea of the human or sapience as a set of positive/enabling constraints for thinking and action as a token for the labor of intelligibility. As suggested by Peter Wolfendale's phrase the reformatting of Homo sapiens 53, sapience is a qualitative change in the class and types of activities of sentience brought about by a qualitatively distinct class of activities. Any sentience that comes under these activities or functional form will be essentially regulated and reformatted. Rather than representing a new rank in the order of beings, Sapient awareness articulates a constructive principle or a form that discontinues the supremacy of humans as a biological species. It dissolves and assimilates the manifest configuration of the human species and of any other sentience that falls under it into the new unities of the impersonal mind. By reformatting sentient consciousness with logico-conceptual functions, sapient awareness weakens the governing role of its material substrate, be it biological or social. It progressively liberates its conditions of realization from its natural constitution. By synthesizing a framework in which it is possible to be at once responsible for thinking something, a judgment, and responsible for doing something, an action, it increases its cognitive, theoretical, and practical freedoms. By rationally evolving into a self capable of treating itself as an artifact, approaching itself as the artifact of its own concept, it puts forward a concept of sapient agency amenable to the possibility of realization in other artifacts. Far from being an achieved totality, human sapience is what breaks its attachment with any special status or given meaning. It is an artifact that belongs to the history of mind as the history of artificialization. The cognitive exploration of what it means to be human, or what sapience consists in, takes shape as a systematic exercise in developing the object of an evolving concept. Succinctly speaking, sapient awareness is a cognitive practical project through which the realization of the human is rigorously subjected to changes in the content of the concept of the human. Yet insofar as the structure of this concept is formally constituted, and since it describes the human not by recourse to substantive essences but in terms of necessary structuring abilities which can be brought about by different sets of material realizers, it expands the prospects of the realization of sapience, extending it to the realm of artifacts as pure objects of craft and artificialization processes. However, in no way does this mean turning artifacts into a repository for the conservation and reproduction of the canonical portrait of the human that belongs to the realm of biology and socio-cultural particularism. Sapient awareness is a constructive principle for the production of a self endowed with content awareness. Neither the essentialist identity of the self nor the boundary and the quality of the content awareness according to which it conceives and transforms itself are fixed. Sapience is a constructible activity, not a structurally fixed entity. From the perspective of this constructibility, the assertion that the sapient is an animal qua sentient is an exercise in prejudiced dogmatism. It places a limit on the possible realizations of the sapient form by limiting it to a particular physical or biological organization. It is a matter of fact that the currently embodied human is both sapient and sentient, both an artifact of the concept and a biologically embodied animal. But what makes the human human qua sapience is formal and not substantive. This autonomous rule-governed form is not a dimension of the human qua sentient or natural species. The distinction between the sapience of the human, reason, and the sentience of the human, Homo sapiens sapiens, is ultimately the formal distinction between thinking and being. It is the dividing line between formal distinction and substantive indistinction. It follows that not only the current Homo sapiens but also any sentience can be a sapient so long as it satisfies the minimum necessary conditions of the formal autonomy of thinking in which our own sentience is caught up. We shall examine these necessary conditions in the following chapters. As humans we look at our animality and say, I see in you the abyss of intelligence, but in me you see nothing. Only to the extent that we are sapients are we critically aware of ourselves as sentient among other sentients, as integrated bundles of rational and non-rational processes. The difference between sapience and sentience is not an essential feature of biological species, nor should it be narrowed down to Homo sapiens or the common sense picture of humans. Of course, one can always object that thinking 59 is ubiquitous in nature and that ultimately sapience is in fact sentience. For now, Lorentz Puntel's response should suffice to dispel this confusion. Discussions motivated by the question whether animals, or specific kinds of animals, think, or have minds, etc., usually have nonsensical aspects. Without a criterion for thinking, it is nonsensical to ask whether or not a given kind of animal thinks. Here, such a criterion is available, the type of world that corresponds to the ontological constitution of a given kind of being. If this world, Welt, is a pure, hence restricted, environment Welt, only an Welt, hence not, unrestrictedly, the Welt, then there is no intelligence in what this book accepts as the genuine sense, because this sense is defined as requiring that the worlds of beings that think be unrestricted, as is the case for human beings. Of course, if one associates a different concept with the term thinking, then some kinds of non-human animals may well think. But then the question is reduced to a purely terminological 1.54. Everything that Puntal says about thinking can be repeated word for word in reference to mind. The thinking of sapience is defined in terms of its conceived world, in that the world of sapience has no restriction whatsoever on what can be asked or thought. The thinking of sapience is coextensive with everything. To be human is the only way out of being human. An alternative exit, either by unbinding sentience from sapience or by circumventing sapience in favor of a direct engagement with the technological artifact, cannot go beyond the human. Rather, it leads to a culture of cognitive pettiness and self-deception that is daily fodder for the most parochial and utilitarian political systems that exist on the planet. In delivering sentience from its so-called sapient yoke, one does not become post-human, or even animal, but falls back on an ideologically charged biological chauvinism 55 that sapience ought to overcome, for it is the very idea of humanist conservatism that misrepresents what is accidental and locally contingent as what is necessary and universal. In discarding the human in the hope of an immediate contact with superintelligence or a self-realization of the technological artifact, one either surreptitiously subjects the future to the predetermined goals of conservative humanism, or subscribes to a future that is simply the teleological actualization of final causes and thus a resurrection of the well-worn Aristotelian fusion of reasons and causes. Human sapience is the only project of exit. We cannot bypass the labor of overcoming the quandaries of humanity by positing a dubious metaphysical alternative to the human as a shortcut to freedom. In doing that, we would simply dissolve the problem rather than solving it. In reality, anti-humanist alternatives to the idea of the human ironically end up endorsing the most conservative anthropomorphic traits under the guise of some dogmatic figure of ALTE writing. Inasmuch as such anti-humanist alternatives have already foregone the geistic resources necessary to diagnose and suspend the conservative traits or characteristics of the human, they become the servants of that very conservative concept of the human they originally set out to escape. We as manifest humans must come to terms psychologically, cognitively, and ethically with the hard fact of what it means to be human. One cannot have the cake of humanity without eating its consequences. Once we treat ourselves as a species of rights and entitlements, once we say what ought or ought not to be thought or done, the moment we distinguish the order of things and respond to it in accordance with what we think is right, however far from truth it may be, we have committed ourselves to the impersonal order of reason to which sapience belongs, an order that will expunge our manifest self-portrait. 56 We have crossed the cognitive Rubicon. In committing to this impersonal order we must realize that what is manifestly human, us as we stand here, now, will be overcome by that very order. Reason is a game in which we are all fleeting players and from which we cannot defect. So let us play this game well by committing to its interests and its ramifications. As transitory embodiments of sapience, we can only recognize our mixed animality and the fact that what makes us special is the capacity for such recognition, for recognizing that, as sentients, we are absolutely not exceptional and take the implications of being sapient to their furthest conclusions. Through the growth and maturation of reason, the definition and significance of the human is freed from any purported substantive essence or fixed nature. The formal appellation of humanity becomes a transferable entitlement, a right that can be granted or acquired regardless of any attachment to a specific natural or artificial structure, heritage, or proclivity, since being human is not merely a right that is simply obtained naturally at birth through biological ancestry or inheritance. The title human can be transferred to anything that can graduate into the domain of judgments, anything that satisfies the criteria of minded and minding agency, be it an animal or a machine. the entwinement of the project of human emancipation both in the sense of the negative freedom from the limitations established in advance or created by ourselves and the positive freedom to do something or become something else with the artificial prospects of human intelligence is the logical consequence of the human as a transferable right. The kind of self that is required for establishing the necessary link between Geist's conception and transformation is defined functionally by its roles in assuming rational responsibility, judging using its rational unity to treat one set of commitments as reasons for or against other commitments. This is a thinking self, or a discursive apperceptive intelligence, an intelligence that is conscious of its own experiences through the rational unity of self-consciousness, and whose experiences are structured by concepts of mind. Unlike God or other imaginary intelligences, this intelligence has no direct contact with reality other than through its own geistig configuration. 62. Since thinking selves are a functional item that represents a qualitative set of activities, judgments or reasons, their formal, semantic pragmatic, and concrete sociality can effect qualitative changes in the structure of Geist or in the activities by which these selves identify themselves, individually and collectively. In other words, in its every dimension the collective configuration of thinking selves or rational agents synchronically in time or diachronically across time determines the course of the concrete project of self-consciousness. Mind has a configuration sequences of self-conceptions and self-transformations which is extended in time. Geistig activities, therefore, are not merely recognitive cognitive but also recollective reconstructive. Thinking selves are then not just the locus of judgments afforded by the recognitive dimensions of rational responsibility and authority, that is to say, the capacity to make oneself liable to distinctive kinds of conceptual, normative appraisals. In addition, they are the locus of recollective reconstructive judgment, the ability to extend recognitive acknowledgement to the recollections of history. What we are referring to here is Geist's ability to be conscious of and to judge its constituent history as represented by the responsibilities and authorities of past judges. Rational selves, then, are also defined by their content awareness of those activities, judgments, decisions, conflicts, values, and variables that have constituted their history and have led to their current configuration. In order to have this content-aware experience, Erfahrung, of history and to gain epistemic traction on it, Geist must be able to represent to itself a reconstruction of its past transformations and their specific realizers, those activities and constraints which have brought those transformations about. Accordingly, the recollective reconstruction of the past history of conceptions and transformations should be understood as an essential feature of the self-related logic of mind, whereby the mind not only recognizes its different structural transformations across time as its own unified experience, but also uses this experience to generate new abilities, to correct or rewrite its values and disvalues, and to construct itself differently. For intelligence, then, history is an order of intelligibility and thus a condition of its enablement. Any configuration of his or thinking selves, any we, is simply a part of this history, not its totality. 63. What we were is now suspended in what we are, and what will be is suspended in the history of intelligence. To intelligence we are merely a historical intelligibility that enables but does not impede it. Once the rational self as the basic functional item of Geist is construct, Geist is able to conceive a historical concept of itself, a historical unity, and to act on it. This historical unity or integration requires, on one level, the recognitive cognitive principle of the synthesis of an original unity of apperception through rational integration with a model of the synthesis of normative status-bearing apperceiving selves and their communities by reciprocal recognition. 57. On another level it entails a recollective reconstructive principle of synthesizing irrational, including consequences and excluding incompatibles, contemporary unity by integrating the commitments of past judges. 58. Only when rational selves concretely incorporate these two principles into their own conception of what to think and do, are they able to see the truth of themselves as an ongoing history of intelligence, realizing that their freedom lies in the freedom of mind as a historical artifact of its own concept, a necessary link between self-conception and self-transformation that ought to be rendered sufficient. The concept of history then is nothing but a necessary link, a dynamics between conception and transformation. The concrete actualization of this history, however, is a matter of a thorough recognitive struggle by rational selves. By constituting its own history, Geist acquires the power of self-cultivation, or the capacity to assess and develop its history via superior modes of self-consciousness, which then allow Geist to form and carry out more refined and comprehensive conceptions and transformations of itself. To put it differently, the elaboration of history as an emancipatory activity is an outcome of constructing and organizing rational selves incorporated within higher geistic unities through which they can concretely transform themselves. By providing themselves with descriptions regarding their past transformations, and by putting these descriptions into a form that can be historically expressed and assessed, rational selves can develop adequate theories and practices for reorganizing or transforming themselves. This process is the socio-historical equivalent of the rational unity of consciousness. Historical consciousness is a distinct kind of consciousness specific to discursive, concept-using, self-conscious creatures able to apply the principle of rational integration to the history of their transformations, giving cognition an explicitly historical role. The agency of rational selves in effecting such a transformation indicates that they have discarded every given in their history, as well as any god or deus ex machina. Agency in its concrete sense is not merely rational autonomy. It is also the realization that anything that appears as an autonomous self-apprehending thing or process without rational agency, be it theological, natural, or technological, is a practical given, a pre-critical adolescent fantasy, a delusion of stubborn and servile consciousness. Through developing historical consciousness, Geist is able to identify negative and positive trends of the past, abandoning the former and cultivating the latter. Therefore, historical consciousness provides thinking selves with the principle of self-cultivation through the assessment and correction of the sequences of their self-transformation, which is not just their transformation but, insofar as it takes place in the real world, also has positive and negative effects on the world they inhabit. Recollective reconstruction of the tradition of an earlier sequence of historical transformations opens up previously endorsed goals, commitments, and conceptions to rational assessment. Goals become objects of understanding and are then susceptible to revision and, where necessary, relinquishment. It is this susceptibility of goals to a kind of revision and assessment whose norms can themselves be discursively repraised that prevents the intrusion of predetermined goals, whether natural or normative, into the conception of collective general intelligence. 65. By applying the principle of rational integration to its temporal manifestation in time, Geist conducts a cognitive inquiry into the conditions required for both its temporal synthesis and the synthesis of temporality as such. It is a pragmatic component of the project of collective general intelligence to transform itself by renegotiating the links between the temporal categories of past, present, and future. But its critical component consists in re-examining and redefining the nature of temporality, even if that means dispensing with those temporal conceptions and categories to which it has become accustomed. Mind's consciousness of its history is ultimately the exploration of history as the interface between subjective time and objective time, temporal forms and time's formlessness. The history of Geist, properly understood, is a recognitive cognitive technology. It is not only a semantic web through which Geist's manifest realizations, self-conceptions and self-transformations, can become transparent and open to analysis, but also a scientific milieu for the development of cognitive means and practical technologies for subjecting what is a manifest realization, the appearance of a totalized history, to a concrete transformation, scientifically suspending what was previously deemed a completed historical totality in an ongoing process of totalization. Namely, history. Geist's concept of revolution requires a scientific intervention in history so as to transform what appears to be the manifest destiny or the totality of history into history proper, in which all achieved totalities are merely fleeting manifestations. Here we arrive at Hegel's idea according to which Geist self-apprehends Ion as what is in itself, the fleeting reality of its manifest realization, must be subjected to what Geist is for itself, what it takes itself to be, its labor of conception. This is because what it conceives itself to be is receptive to correction and susceptible to profound changes stemming from the undermining of appearances by new orders of intelligibility which are outcomes of a systematic project of cognitive inquiry or science. Thus what count as conditions required for the realization of Geist cannot be limited to the constellation of different particular models of selves, the modes of their organization, and institutions which reflect the manifest realization of Geist. These conditions must also involve the development of cognitive 66 and practical tools for bringing manifest realizations of Geist under the rational unity of superior and more adequate modes of consciousness. Only once a manifest totality is understood as an appearance, a fleeting realization, can it be concretely overcome. Here adequate means both richer forms of content and context awareness, and a sensitivity of these modes of consciousness to resources, cognitive, practical, and material, and diverse intersubjective relations between subjects that encompass a broad range of economic and other relations. Spirit is supposed to be cognized in its own outer as in a being, which is language, the visible invisibility of its essence. Here once again we see language as the existence of spirit. Language is self-consciousness existing for others. It is self-consciousness which as such is immediately on hand, and as the self-consciousness, it is universal. 59. Both self-consciousness and historical consciousness require recognitive and recollective, retrospective and perspective cognitive abilities. But these abilities can only be acquired through language, as a scaffolding for the organization of a community of normative status-bearing apperceiving selves. This is where the role of language as the and as a generative platform upon which mind takes shape and evolves in time comes to the foreground. In its most basic and necessary form, language is merely discursive speech, an ordinary natural language. In such a natural language the interface between the syntactic and semantic is interaction, or pragmatics as the social use of syntactic symbolic vocabularies, which progressively affords new levels of semantic complexity or conceptual expressivity. The concepts of language are not merely labels or classifications, but descriptions. There are concepts that do not simply describe, but also allow cognitive simulation via counterfactuals. Semantic complexity in its full richness, then, comprises different grades of concepts, concept using abilities, and the various corresponding modes of rational integration afforded by them. Robert Brandom distinguishes the structural levels of semantic complexity of concepts afforded by the pragmatic interface between syntax and semantic as follows. Concepts that only label and concepts that describe, ingredient and freestanding conceptual contents, making explicit the distinction between the content of concepts and the force of applying them, and concepts expressible already by simple predicates and concepts expressible only by complex predicates. 60. In its specialized format as the infrastructure of all theoretical structurations of the world, language is essentially formal. The significance of formal languages lies in their capacity for what Katarina Dudilhnovas terms desemantification and resemantification. 61. This is the ability of formal languages to be detached and abstracted from any particular content, topic independence, so as to be generally applied to different contexts. The desemantifying ability of formal languages is tantamount to the explicit reenactment of mind outside of any particular individual experience or contextual meaning. Formal languages as the prostheses of extended cognition and epistemic enablement. Decoupled from any particular content, desemantification allows for the deployment of reasoning strategies other than our default strategies, thus enhancing the mind-altering effect of reasoning with formalisms. 62. In addition, formal syntactic languages can be explicitly computable. This is the achievement of Noam Chomsky, in putting forward a hierarchy of formal grammar or syntax where the complexity of syntax is articulated in terms of computational complexity. Chomsky's hierarchy classifies different types of syntax, recursively enumerable, context-sensitive, context-free, and regular, in terms of the combinations of generative processes required to produce them, the formal grammatical properties that specify them, and the automata necessary for computing them. 63. Finally, in its ultimate superior mode, Language refers to artificial general languages, languages in which the full hierarchy of syntactic complexity, of formal languages, and the full hierarchy of semantic complexity, of natural language, computation and conception, desemantification, resemantification, and semantic enrichment all exist side by side, reinforcing one another. Before proceeding, let us briefly look at the phenomenon of language. Although the topic of language and its role in the formation of minding activities, judgments and inferences, will be surveyed in more detail in chapters 6 and 7. The emphasis on the principal role of language for mind is an old topic. But what has been largely absent in studying the role of language for mind is the deep logico-computational structure of language itself, where language can be seen as much as a multilevel syntactic complexity as a multilevel semantic complexity. This is language neither as a medium of direct access to reality nor as a system of public discourse, but as a framework of interaction, as computation incorporating different classes of semantic and syntactic complexity and the cognitive practical abilities associated with them. This interactive computation permits qualitative compression of data and selectivity of compression. It significantly reduces the size of the agent's internal model while increasing its complexity, and it can format and modulate the agent's behaviors, stabilizing the multi-agent epistemic dynamic without which it is impossible for any agent to be aware of itself and to experience. Built on this computational interactive dimension, language is above all an engine for the generation of qualitatively distinct cognitive abilities. It is precisely what reshapes intelligent behaviors not by degree but in type. Example: a linguistic agent differs from a non-linguistic agent in type, not in degree. The archetypal figure behind language is computational duality or interaction. Interactions are the prevalent phenomena in language, and they can be concurrent, synchronic, asynchronic, typed or untyped, deterministic or non-deterministic. Interactive systems are online, open, and reactive to multiple streams of input. Interactions are governed by computational dualities. In simple terms, these dualities signify the interchange of roles between two or more processes or behaviors which constrain one another, resulting in the generation of additional constraints or rules which increase the complexity of behaviors involved in interaction. In theoretical computer science, these interactive dualities are called open harnesses. Open harnesses simultaneously constrain the behaviors of the interacting systems, hence the constraining connotation of harness, and harness them to a new design, a behavior with a higher level of complexity. By pitting two systems against one another, they force the systems to correct their behaviors and to augment their capacities, as in a game that harnesses one player to respond intelligently to another, and where the totality of the game is always in excess of its players. But this is not a game in the game theoretical sense. As topics of logic and theoretical computer science, interaction games are devoid of precise goals, payoff functions, or predetermined winning strategies or procedural rules for how the game should be played. Instead, the rules of the game emerge naturally from the interaction itself. Interactions are a medium of complexification for processes. In the words of Jean-Baptiste Joynet, as vague as the notion of process may be, it certainly is in their nature not only to evolve. Amongst the effects produced by a process appear its own transformations, but also to produce effects on other processes, mutual effects. In short, processes act and interact. Whatever its technological matter, whatever its implementation, the essence of a process is completely involved in its potential, dynamic behavior, not only its own possible destinies under evaluation, but also the full set of possible operational effects it will occasion in all possible processes' interaction contexts. With respect to semantics, the answer brought by processes is 70. Thus of a radically new kind, which implements the performative way of meaning, doing, is the way processes speak. 64. But unlike generic interactive processes, the logico-computational interactions of language have the ability to increasingly incorporate lower-level interactions within higher-level interactions, i.e., interactions with more semantic complexity or, in Wolfendale's terms, interactions that reformat lower-level interactions, and to form stable linguistic items with their own specific transformation rules across different levels. It is in the context of a complex network of interaction that rules are obtained and stabilized. Some may be context-sensitive, others may be applied across the board. Semantic values or meanings are abstractions of linguistic locutions together with transformation rules for their use, which are both derived and used in their stabilized form through the interaction. The realization of mind or general intelligence is inconceivable without language, not merely as a structuring edifice but also as a necessary and vast computational framework for the generation of higher-order cognitive faculties, theoretical and practical judgments. Just as there is no structure in the world without the structuring mind, there is no mind and no unrestricted world without the structuration of language and its unrestricted universe of discourse wherein everything can be questioned or subjected to systematic theorization. General language, as opposed to this or that language, has no borders or limits. In the same way that we cannot step outside of mind to gain direct access to reality, we cannot step outside of language as the armature of mind. In stepping outside of one language, we only find ourselves in another more general language. To speak of a limit drawn by language, or by a language, is to be, linguistically, beyond the putative limit. A limit is a limit only if there is something beyond it, so to identify a limit to language is also to enter the linguistic space, making it possible to speak of what is beyond the limit, and thus to negate the identification of the limit as a limit of the language that bespeaks it as a limit. 65. The phenomenon of language in its full syntactic and semantic complexity cannot be captured outside of the logico-computational linguistic interactions of which pragmatics, meaning as use or discursive meaningfulness, is only the uppermost visible instantiation. Since mind or general intelligence is inconceivable without language, and to the extent that language requires an interactive framework, the idea that mind or general intelligence could be realized in anything but a community of agents is a dubious one. Humans are only minded and minding agents in that they have sociality. In the same vein, the idea of an artificial realization of general intelligence in anything but a multi-agent system rather than a single agent is something of a bygone 20th century science fiction. Artificial general intelligence is a product of interactions, be they between nurturing humans and child machines, or between machines that have graduated into the domain of artificial general languages. To this end, general intelligence should be seen not only as a repertoire of existing cognitive abilities but also as a generative framework for the realization of new cognitive abilities by adjusting to the syntactic-semantic resources of language. It is the linguistically charged competence to proliferate, diversify, and maximize theoretical and practical abilities that sets general intelligence apart from complex causal and pattern-governed processes exhibiting a powerful yet restricted range of behaviors. The intrinsic affinity between general intelligence and language as a socially embedded and constructive medium for the elaboration and realization of the abilities of mind points to the social basis of general intelligence. There is no predetermined limit to the type and range of cognitive technologies that can be garnered by excavating the visible-invisible essence of Geist or language. The possibilities of what can be done with language are as unfathomed as the possibilities of what language can do to its users. 72. Having presented an overview of mind not as an ideal object but as a social project, we can now shift the focus to the ramifications of developing and partaking in such a project. Hegel's systematic elaboration of Geist in functional terms has both a critical and a constructive import. The functional analysis of the spiritual or geistic struggle, i.e., the struggle of spirit to become the object of its own concept, to refine the content of this concept, and to devise abilities to actualize itself as the object of its concept, reveals how this struggle is realized, and how it can degenerate and precipitate pathologies of consciousness and their social manifestations. This type of analysis sets the stage for an in-depth diagnosis through which it is possible to identify what ought to be changed, and to specify those structural joints or material organizations that ought to be treated as sites of struggle. It is in this sense that Hegel's deep functional picture of Geist as that which has a history and has the ability to treat its history as a milieu of intelligibility in which all achieved totalities are fleeting shadows and appearances lays the groundwork for Marx's project of communism as the real movement that concretely and determinately negates the present state of affairs, the givens of history. The uncovering of history as a new domain of intelligibilities requiring special kinds of theoretical and practical cognitions brings to light those sites where struggle and intervention must take place in order to achieve a consequential and concrete liberation from the present state of affairs perceived as the totality of history. The import of the functional picture of Geist resides in how this picture highlights key activities and abilities through which the mind as a social project can be augmented and amplified. Primary among these activities are conception and transformation, both are labors of mind, but one places more of an accent on systematic theorization, the other tends toward concrete practice. However, at no time can these two be separated, they are as mutually reinforcing as they are intrinsically linked. Essential self-consciousness is explicated by the necessary link between self-conception and self-transformation as two distinct yet connected. 73. Activities, that of conceiving, i.e., bringing into conception, ourselves in the world, and that of transforming ourselves in accordance with our self-conceptions. 66 Each transformation serves in turn as a pivot for a different encounter with ourselves in the world. Alteration in the order of self-conception induces a change in the self of which it is a conception, and a qualitative difference in the self induces a transformation in the general or geistig conception of the self. The positive feedback loop between conception and transformation instigates a disequilibrium, with each difference in one order destabilizing the other and becoming a cue for its readaptation. This disequilibrium is particularly intensified as subsequent conceptions become further removed from the order of appearances, and in the process the latter are determinately negated. The act of self-conception must yield progressively more fine-grained conceptions of the geistig self, what it means to be a minded and minding agent, a human, an embodiment of intelligence, but in order to do so, it must break away from the mere appearances of its present conception, its manifest realization. In conceiving itself in terms of this process of simultaneous self-recognition and self-negation, the history of Geist is no longer entailed by its past states, even if it is constructed out of them. The self-conception of Geist via determinate and concrete negation of its conceptual content, how it appears to itself, brings about a real movement of history in which Geist's sequence of self-constituted transformations are not merely the repetitions of its past stages. Within this movement, any totalized state of realization is taken to be a historical appearance with regard to the reality of history qua incomplete and ongoing totalization. The history of Geist, in this sense, is neither a linear progression between different states of Geist's realization, epochs, nor a series of isomorphic transformations. The real ity of what Geist is now is not the reality that it used to be. What Geist or intelligence will be is never what it is or has been, where never implies the elimination of the one-to-one relationship between the sequences of Geist's transformation. Historical consciousness, or awareness of this fact, what it means to identify the appearances of history and determinately negate them is the kernel of concrete self-consciousness as the real movement of emancipation. The adequacy of self-consciousness is an index of the quality of conception and transformation and an indication of how effectively self-conception and self-transformation are integrated within the order of intelligibilities. Just as a robust self-conception brings about a consequential self-transformation, a flawed or impoverished self-conception incites a defective or inconsequential self-transformation. But insofar as our self-transformation is embedded in the objective world, its flaws are not isolated. Depending on its proportion and persistence, a pathological self-transformation can trigger a disaster by laying ruin to those structures that environ and support us. This calamity also debilitates our capacities to act, either simply by depleting the resources required for perpetuation and transformation, or more insidiously by causing a disorientation that prevents us from decisively thinking and taking measures, detecting and acting on opportunities without the crippling anxiety of further deterioration and imaginary tragedies. Blinded by the oppressive fear of tragedies, the diagnosis of what exactly is wrong, revealing the specific inadequacies of conception qua determinate negation, then falls under the jurisdiction of abstract negation and unconscious self-deception. In supposing ourselves to have dispensed with all illusions and escaped all the traps of history, we succumb to naivete and cognitive practical despondency. In this environment, reasons which form and adjudicate recognitions, obligations, responsibilities, and pertinencies, what matters and what does not, are discredited by a critical discourse on the irrationality of reasons tout court, and an insistence that we should dispense with them. Reasons are unmasked as social irrational causes that merely disguise the roots of what is oppressive and exploitative. This critical discourse then becomes an expose on how causes not only semantically distort reasons but also masquerade as reasons. Reason is burned at the stake, accused of being the ultimate trap of history, the supreme collaborator with the oppressor, a smokescreen for the conditions of exploitation. Once freed from the tyranny of reason, critical discourse presents itself as an egalitarian exposition of the causes of oppression and exploitation. Having immolated the trap of all traps, reason critique is now fully disillusioned and emancipated. But to dispense with the conceptual and normative resources of reason in order to expose their causal irrationality, and to diagnose oppressive pathologies via the reasonless appraisal of causes, amounts to the impoverishment of the semantic requirements necessary for the intelligibility of any diagnosis. In other words, the unconscious undermining of the criteria required for the adequate consciousness of the self occasions a consciousness which is inadequate to have a proper conception of itself in the world and to determinately transform itself in accordance with such a conception. The reasonless critique or diagnosis of what is oppressive and exploitative becomes the prognostic course of the disease or pathology itself. In being an inadequate consciousness, the critique unconsciously justifies those pathologies of history it is bent on eradicating. 67 Founded on the intelligibility of the concept and the intelligibility of practices, the adequate self-consciousness is distinguished as a multitasking project comprised of 4 basic undertakings. 1. To evaluate and correct our self-conceptions, using the resources of both common sense rationality and those of the sciences, with the understanding that they yield 2 different images of ourselves in the world that should be integrated. 2. To coordinate our self-transformations with better self-conceptions, i.e., self-conceptions informed by a broader order of intelligibilities. 3. To amplify the influence of our rational and scientifically informed self-conceptions over our self-transformations, the shift from a necessary link between the two to one of sufficiency. 4. To revise and where necessary abandon our self-conceptions in accordance with the intelligibility of how and into what we are transformed. Formulating self-consciousness as a project rather than as an ideal object allows us to conceive of the vocations of thought and action not on an ontological basis, where the ideal abstractness of thought is contrasted with the ideal concreteness of action, but on a methodological basis, where thought must first make a concrete difference in itself in order to make a difference in the world. The interplay between the abstract and the concrete is then conceived methodologically as the determination of concrete abstraction and the abstraction of the concrete, a dialectics through which making a difference in thought and making a difference in the world can be bidirectionally mediated by autonomous transformative actions in the order of thought and in the order of the world. Autonomy in reference to transformative actions describes the ability of these actions to repurpose or reorient themselves in accordance with self-contained rational ends. It is important to note that to speak of functional self-containment in this sense does not imply the denial of the existence of material constraints. In fact, it simultaneously brings about the opportunity to uncover such constraints and to examine how they can be modified. To every abstract moment of science, there corresponds a shape of appearing spirit per se. Just as existing spirit is not richer than science, so too spirit in its content is no poorer. 68. The reinforcing link between self-conception and self-transformation characterizes essentially self-conscious creatures or rational agents as those possessing the capacity to constitute a history and to have a contentful experience of it, to have impersonal norms regarding what ought or ought not to be done in order to maintain and expand the intelligibility of their history. This capacity unfolds the truth of intelligence as a social cognitive practical enterprise in the order of intelligibilities, of things, practices, and values. In reality, the systematic encounter with the order of intelligibilities is the inexorable consequence of the realization of Geist by the specific qualitative set of activities that distinguish it. The formulation of self-consciousness as a matter of practical achievement underlines the import of self-conception as a recipe for action without which action cannot maintain its practical intelligibility. Conception without praxis is unrealized abstraction, and praxis without conception is a hollow impression of concreteness. Self-conception in its concrete form is a search for intelligibilities pertaining to the world of which we are a part. Self-transformation in its consequential form is the intelligibility of practices in response to the intelligibility of what the world we inhabit is, together with what we ought to be in accordance with the ends of thought. The recognition of ourselves, the conceiving of ourselves within one or multiple self-narratives, is by definition the construction of ourselves within the order of intelligibilities. There could be no us without our encountering ourselves and bringing this encounter into a conception not only of who or what we are, but also of where we have come from, where we are, which paths have led to where we are, and which paths we ought to take. The conception of this encounter is thus an open landscape of inquiry into different orders of intelligibilities. The conceptual awareness of one's experience of the world is a necessary framework within which one can know oneself in the world, and how to change oneself and the world. However, the divergence between what we take ourselves to be and what we actually are, the disparity between the intelligibility of the self and the world as what they appear to be and the intelligibility of the world in itself as what conditions all appearances generates a tension in self-conception and, correspondingly, in the space of self-consciousness as a project. The full recognition of this tension, its simultaneous sharpening and resolution, characterizes the task of scientific rationality or, more generally, the enterprise of science. Again, what is meant by science here is not just the modern empirical sciences, but also the science of history, the science of thinking, or what Hegel dubs the greater logic. And finally the science of impersonal values and disvalues, the science of ethics. While maintaining this broad idea of science, I would however like to discuss the implications of the modern empirical sciences for the project of conception and transformation outlined above. For the field of empirical sciences poses a significant challenge to what is already a challenging project. The core protocol of modern empirical science consists in striving for explanation. Why do we see what appears in our ordinary common sense experience to be the case, and yet know that it is not the whole of reality? Science overturns the order of what appears to be subjectively the case by providing its objective explanans. It differentiates what was previously an apparent explanation into an explanandum, the explanans of which remains to be found. The explanatory force of science reaches its peak when it overturns the universe that seemed to be ontologically dependent on the mind into a universe that is independent of mind. Yet in overturning what is simply subjectively manifest, the universe hypostasized as the reificatory-dependent object of mind, science draws on the core components of subjective or minding activities, linguistic doings, conceptualization, and systematic theorization among others. Objective science without subject constituting mind is a subjective delusion. The movement of scientific inquiry only underlines the necessity of mind in its pure and necessary form. Science, in this sense, is the hallmark of a mind that has matured to learn that it should hypostatize neither its structuring activities nor its structured object, neither itself nor its unrestricted universe. This is a mind whose intelligibility is not immediately given in itself, but is achievable only in its integration rather than complete fusion or reduction with an intelligible order pertaining to a non-manifest and mind-independent reality. The enterprise of science is permanently caught up within this integral framework, which is comprised of the vocabularies of mind and the items of the world, and whose internal tensions enrich and drive it. But this tension through which science expands itself is exactly the tension exclusive and constitutive to mind, albeit more self-conscious and intensified. 79. Spirit knowing itself in that way as spirit is science. Science is its actuality, and science is the realm it builds for itself in its own proper element. 69. With the advent of scientific explanation and the excavation of an intelligible universe which, in its objectivity, constrains our thoughts about it, the order of self-consciousness, the duality of the intelligible and intelligence, enters a new phase. Matter of factual truths pertaining to a non-manifest and mind-independent universe intrude upon and are ingrained in the logico-conceptual infrastructure of intelligence. As the scientific will to explain or the pursuit of explanatory coherence highlights the insufficiency of common-sense concepts, conception begins to adapt itself to science and its unrestricted universe. Even though the conceptual framework of common sense through which we articulate the intelligibility of ourselves in the world is built upon basic matter of factual truths, it does not grant us access to these truths as such, properly conceived, since they lie beyond what manifestly appears to be the case. These truths belong to the framework of scientific inquiry. By assuming otherwise, we subscribe to the ideological fixation of the epistemic given of access to the intelligibility of the world through the supposedly spontaneous intelligibility of our seemings. Scientific explanation, accordingly, can be understood as an activity of mind that forces the activity of self-conception to renegotiate its original alliance with appearances, particularly the appearance of how the world that appears for mind is in itself. As the order of intelligibilities uncovered by science encroaches upon the intelligibility of that which is manifest, self-consciousness gains a new mobility. The sharp asymmetry between what is manifest and what is scientific, how things appear to be from an ordinary common-sense perspective and how things are as matter of fact, destabilizes the oppressive serenity of the order of mind and things. Cognitive progress can only be maintained and expanded by sharpening this asymmetry, by further amplifying the instability in how mind and the world stand in relation to one another. As the site of this tension, science advances through positing the transcendental excess of a structuring mind and by positing a structured reality that is in excess of mind. 70 Yet the advancement of science need not be understood as a series approaching convergence, or a uniform progression. 71 A completed science, or the full and adequate scientific image, of human being in the world, is a regulative ideal. But, as Kant reminds us, when regulative ideals are applied constitutively they lead to contradictions. 72 Outside of their regulative use, regulative ideas are pseudo-rational and illusory existences. The account of science as a convergent and uniform progression is not necessary for the certification of science as a vector of cognitive progress. Indeed, this convergent progressive interpretation can result in both irrationality and relativism, both epistemic dogmatism and epistemic anarchy. Wolfgang Stegmüller has provided an incisive critique of this generalized progressivist interpretation of scientific theories. 73 Here I will merely summarize his particularly meticulous and technical argument. The idea of a general convergent progress of science is based on the analysis of the structure and dynamics of scientific theories, the theory-ladenness of all sciences. According to Stegmüller, the conviction of a convergent and uniform progress of science rests on the idea of the general reducibility of one theory, a dislodging theory, to another preceding, dislodged, theory covering the same class of observations. For example, if we can in every respect reduce or map statistical thermodynamics to the thermal theory of thermodynamics, then we can say there is a uniform or convergent progress from the latter to the former, from the less explanatory to the more explanatory theory. In the traditional study of scientific theories, analysis is performed at the micrological level, pertaining to the stable core of theories. These stable cores are comprised of atomic axiomatic formal sentences or classes of sentences together with their inferential relations. At the level of micrological analysis, to see whether one theory is reducible to another theory, a mapping must be obtained from the stable core of the succeeding theory, T2, to that of the preceding theory, Tx. But this mapping is precisely based on the reduction of individual theories to their so-called stable cores, a reduction that loses much necessary information regarding the specificity of its content, including the distinction between theoretical and non-theoretical functions, the general and special constraints, and the special laws holding only for certain intended applications. 74 Accordingly, at the level of micrological analysis pertaining to the stable cores or sentences and their inferential relations, the reducibility of T2 to Ti cannot be obtained in a non-arbitrary manner. Insofar as micrological reducibility presupposes the prior reduction of each theory to its stable core, we cannot generalize the relationship between T2 and T1 in terms of their being generally more inductively simple and generally less inductively simple, generally more explanatory and generally less explanatory, answering more well-formed questions and answering less well-formed questions. The comparison of theory contents is completely context-dependent. What appears to be less explanatory in T2 may be less explanatory in one particular context than equally, T may answer some well-formed questions that cannot be answered in T2, as in the case of Newton's and Einstein's theories of gravitation. Just because precedes T2 and both cover the same class of observations, it cannot be inferred that the relation between them is that of theory reducibility in the sense mentioned above. It is only when we move from the level of micrological analysis to the level of macrological analysis, from the stable cores to the model theoretic view of theories pertaining to their expanded cores, that we can speak of reducibility. The expanded core of each theory covers the class of partial possible models, i.e., the physical systems about which the theory is talking, or the class of sets of possible applications. Further, the components of the expanded core, its range of possible applications, are unstable and dynamically changing. To secure reducibility at this level of analysis, one has to take a static snapshot of theories at time t in order to obtain the mapping between one theory and another. But this static theory comparison is itself problematic, since it freezes the dynamic picture of the theory structures and narrows the range of their possible applicability or coverage over possible models. At the level of the micrological analysis of stable cores concerning formally constructed and inferentially related sentences or classes of sentences, the reducibility fails to be non-arbitrary or general. And at the level of the macrological analysis of expanded cores, reducibility can only be obtained by taking a static view of the dynamic structure of compared theories, hence losing information regarding the dynamic aspects of the theory structures themselves. Stegmuller's final conclusion is that we do not need a convergent progressivist account of scientific theories to talk about the rationality of science or to avoid relativism. Scientific progress can be seen in terms of the dynamics of each theory structure in itself, the increase in the range of its applicability and achievements as it incorporates aspects of an older theory structure which is now operating under new constraints and laws, and over a larger field of experience. Both the dislodged theory and the dislodging theory may prove successful in certain situations, identification of which requires a rich dynamic picture of their structures. The true revolutionary import of science lies in its capacity to amplify reason's own power of knowing and to instigate cognitive expansion. The convergent progressivist interpretation of scientific theories is often assumed to be a preventive measure against irrationality and relativism with regard to scientific theories, but in reality it is an oversimplification that causes more unnecessary problems which can become the source of irrationality. The rationality of science lies not in the uniform progression of science, but in how these theories are constructed and how they expand the capacities of reason and its cognitive traction on the world. In light 83 of the dynamics of scientific structuration or theoreticity, the rationality of science can be preserved without a convergent progressivist reading of scientific change. Similarly, epistemological anarchism can be shown to be merely a parasitic outcome of the pseudo-rationality of an uncritically progressivist view of science. Coming back to the role of science for mind, intelligence, and agency, science's capacity to make the world intelligible beyond appearances as a reality that is in excess of mind represents mind's movement of self-consciousness as it differentiates its universal and necessary features from its particular and contingent characteristics. The ongoing instability or perturbation caused by the sharp asymmetry between the manifest and scientific frameworks should be seen as a positive condition for self-conception and the corresponding self-transformation, since it results in the increasing refinement of the manifest picture of the agency, its minimalization to a set of logically irreducible and necessary activities. Science is not an attack upon the logic or essence of the human that should be staved off, it is that which differentiates the necessary aspects of the latter from their contingent features. Pruning the manifest picture of the human and cutting it down to its logico-conceptual, necessary activities and functions is a required step toward understanding the meaning of the human. It is precisely through this minimalization of the manifest that the rational self can be extricated from the neurobiologically fabricated phenomenal self model 75 and instead presented as a constructive principle that can be transferred and artificially implemented. It is the continuous labor of science in deepening the order of intelligibility that provides Geist with the necessary resources for the determinate negation and reappraisal of the content of self-conception. In the wake of scientific rationality, mind turns into a wave of noetic deracination. This deracination of thought and its noetic drift is commensurate with what Plato calls the form of good as the form of forms, since it sets up the scaffolding for a conception of the realm of intelligibilities as a complex system of recipes for crafting a world which includes not only satisfying lives but also the perpetual demand for the better. The ingredient of these recipes are not just theoretical intelligibilities, the products of modern sciences, but also practical intelligibilities and axiological intelligibilities, the objects of sciences of skill, practice, and ethics, all of which are subsets of the logical functions of mind. This is ethics as the science of impersonal values and disvalues concerning the intelligible unity of freedom of mind and the constraints of the world, the autonomy of thinking and reality in its otherness. But what kind of life would really satisfy the mind, other than one that involves a self-knowledge which has passed through all the stages of disciplined reflection on the source of things 76, that is to say, their intelligibility? And what is intelligence other than that which knows what to do with the intelligible, whether pertaining to itself or to the world? The aim of this and the following chapters is to engage in a more detailed fashion a question that overshadowed chapter is outline of the nature of mind as a configuring or structuring factor and as that which is capable of treating itself as an artifact of its own concept. This is the question of language as a framework through which intelligence comes into cognitive contact with itself in the world. The question might be formulated as follows: what is it in language that makes the self-conscious form of intelligence not only possible but also amenable to self-determination and self-augmentation? To adequately answer this question, we have to reconstruct and explain the essence of language rather than simply highlighting its importance. If the ineffability of general intelligence is to be overcome, and if Geist's activities are fundamentally caught up in language, then we first of all need to understand language not in terms of some mysterious internal essence, but in terms of its computational capacities and formal autonomy, how it gains traction on the world and how it generates cognitive practical abilities through which language users can bring into conception and potentially transform themselves and their world. In other words, we need to inquire into how language is realized both at the level of natural evolution and that of social evolution, and how language junctions both at its most fundamental level and at the level of what we might call the familiar picture of natural language and linguistic interaction, social discursive activities, the mappings between thoughts and speech acts, etc. To this end, our path to the nature of language, the nature of thinking, and general intelligence won't be anything like a straightforward non-stop train ride across different continents of inquiry. This is a route that stretches out with bends and twists from one condition necessary for the realization of mind to another. On this ride, language is the last station. At times we will stop the train to investigate the wilderness that we have only been able to experience vicariously through the windows. At other times, we shall take roundabout paths along tracks either long abandoned or still under construction. All things considered, our journey is a risky one, a gamble. Only those travelers who no longer think like tourists, that is, those who are not obsessed with getting back as quickly as possible to their comforting home, will enjoy and survive the ride. In order to properly tackle the questions of the realization and functioning of language, the best strategy would be to undertake a comparative study of ourselves and artificial intelligence. Understanding exactly how we are enabled by language is key to the artificial reconstruction of those abilities by virtue of which we have become the artifacts of our own concept. and the investigation of how we can reconstruct these abilities that make us who we are is a key for understanding the most fundamental connections between language and the conditions necessary for the possibility of having mind qua dimension of structure. In continuation of the arguments presented in the previous chapter, this is precisely our aim here, to scrutinize the deep connections between language and transcendental psychology by inquiring into how the development of artificial speech, from basic speech synthesis to advanced artificial languages capable of exhibiting the properties of natural language, can play a key role in the construction of an advanced form of artificial general intelligence. The most objective way of inquiring into the essence of language is by investigating how research on artificial linguistic speech can be integrated into research on the artificial realization of mind. In other words, it is by constructing an artificial agent capable not only of autonomously conversing with us, but also of conversing with other artificial agents possessing the same ability, that we can simultaneously disenchant the nature of language and recognize its indispensable and as yet not fully apprehended role in the emancipation of intelligence from the shackles of its contingent history. The transition from quantitative problem-solving/inductive intelligence to qualitative intelligence furnished with conceptual self-consciousness requires the integration of language, as an enabling social framework, into the constitution of intelligence. And inversely, it is the examination of how exactly language, in all of its different levels of syntactic, semantic, and pragmatic complexity, is naturally or can be artificially integrated into the constitution of intelligence in the sense that the evolution of the two becomes coextensive that will shed light on the nature of language. As a way of addressing, how interdisciplinary research on artificial speech and artificial intelligence elucidates the links between language and the generation of complex cognitive practical abilities, and, 2. How the examination of ourselves as common users of language is key to the development of artificial general intelligence. Below we set out a thought experiment or hypothetical model. Even though this model will be presented in a rudimentary fashion, I would argue that by highlighting the systematic correspondence between artificial speech, as artificial intelligence, AI, and transcendental psychology, TP, we can outline a framework in which the problems associated with these fields can be examined within one and the same domain of research. But also, and more importantly, this framework can in principle define a trajectory for the development of artificial intelligence that is guided by problems that do not traditionally belong to the program of AI in its classic manifestation. The ASAITP correspondence captures a family of fundamental connections between the conditions required for the realization, development, and construction of linguistic speech, as the conditions or activities necessary for the possibility of cognition, TP, the project of artificial intelligence, AI, and their convergence toward the design of artificial multi-agent systems capable of exhibiting the necessary features of advanced agency and social community as a formal rather than substantive condition, AGI. By building on such a correspondence, it is possible to introduce a framework for specifying what is required in order to construct a system of agents capable of performing an array of special social activities that will allow them to provide reasons for their actions, to reappraise those reasons, and to modify and repurpose their social structure through different modes of action. The objective is, accordingly, to ascertain the necessary components for the formation of agency in its Kantian sense, and ultimately to design a community of evolving and autonomous artificial agents. 89. Designing agents that exhibit an evolution conditioned by their autonomy, however, requires an inquiry into the nature of this evolution so as to determine which dimensions of it belong to the order of natural evolution and which to the order of socio-cultural evolution, and to what extent particularly those dimensions central to the emergence of linguistic activities and directly associated with the discursive inferential structure of cognition. Specifically, we must establish what kinds of evolved causal structures and what type of social scaffolding need to be in place to support rule-governed activities, how they are connected, and at what stage the role of causal mechanisms in determining the rule-governed activities of the agents is weakened. In the ASAITP framework, artificial speech plays the role of a mediator between the key problems of transcendental psychology and those of artificial intelligence. In its initial form, artificial speech primarily concerns speech synthesis. At this stage, the emphasis is on the production of the phonic and prosodic properties of acoustic speech. The research takes shape through the study of the evolutionary mechanisms involved in human vocalization, such as the organization and coordination of articulatory organs and auditory perception, as well as through the development of models of synthesis for producing and composing the different elements that constitute the naturalness of human speech at the level of sound. However, it should be noted that the arena of speech synthesis is not limited to ordinary human speech. The only reason that our thought experiment resorts to the latter is our conventional familiarity with it. But artificial speech pertains to a much broader landscape that encompasses symbol design, writing, text generation, formal languages and syntactic processing systems, which may be either naturally evolved or artificially designed. The second stage can be defined by a deeper exchange between artificial intelligence and transcendental psychology. The focus shifts from the production of the acoustic properties of speech to its intersubjective or dialogical features, beginning with automatic speech production and recognition through a basic implementation of artificial intelligence and neural networks, and culminating in the syntactic, semantic, and pragmatic aspects of linguistic speech. The most significant problems for this second stage are those relating to the combined inferential and interactive functions of speech. What does it mean for something to genuinely engage in conversation, where genuine refers to the ability of the agent to confer conceptual content on an expression and to map another agent's behavior, noise or expression, onto its own in order to interpret and assess it? What is required in order for humans to engage in conversation, in the sense of using expressions in an intersubjective and inferential web? What does it mean for a human and a machine to enter into an interaction that can be qualified as a neutral, collaborative, or even hostile dialogue? And what would it mean for machines in an artificial multi-agent environment to have dialogical interaction with one another, to engage in activities that count as discursive speech, and to develop a wide range of cognitive activities in which the semantic relations between contents merit the status of judgments exchanged and assessed by rational interlocutors? Let us note that this would be a conversation free of some of the constraints of natural languages, and perhaps also some of the limitations implicit to the human social domain, particularly those pertaining to the concurrent development of different branches of dialogue, access to different contexts, multimodal coordination, and conversation among interlocutors with divergent histories of interaction. The third stage in the SAITP framework of research aims to materialize the ideal objectives of artificial intelligence in the light of two lines of inquiry: specification of the conditions necessary for the possibility of cognition, the problems of transcendental psychology, and determination of the role played by speech in enabling complex cognitive faculties, the problems of artificial speech. Bringing artificial intelligence and transcendental psychology yet closer, this stage deals with the development of autonomous artificial agents who have capacities such as context-sensitive reasoning and cognitive abilities that function at higher levels of semantic complexity. These capacities are the assets necessary for developing theoretical and practical reasoning and, correspondingly, producing advanced modes of action by means of which the artificial agent can potentially 9.2. Transform itself in a self-augmenting fashion. This form of AI, possessing an integrated and generative framework of cognitive practical abilities, is called artificial general intelligence or AGI, an artificial agent that has, at the very least, all of our competencies for theoretical and practical cognitions, a sapience system. Embedded in forms of interaction that are no longer merely physical processes but have the qualities of content awareness and content signification, these modes of action have the capacity to transition a system of agents from a thin form of community into a rich form of sociality. Evolution in the context of this multivalent concept of sociality, together with and indeed, inseparable from the kind of interaction that takes place between agents that qualify as content-aware and content-signifying, engender the distinct characteristic we attribute to ourselves, and which we identify as being conscious of our history. As a socio-cognitive ability, historical consciousness gives an explicit social significance to the capacity of agents for self-transformation, and in doing so it endows agents with an aptitude for collective self-determination. Once agent's course of transformation, a transformation that is the product of various modes of interaction between one agent and another, and between agents and their environment, is opened up to content-determining and content-signifying activities, it can become the subject of a multifaceted appraisal, or what we describe as normative judgments. The importance of this appraisal is that it makes this course or history pervious to norm-governed alteration and to change prescribed by agents. It is at this juncture that an artificial multi-agent system that is autonomous, in the sense that it does not require continuous instruction from outside, evolves into the condition of real autonomy, in the sense that it is bound to rules authored by the agents themselves, and becomes able to pursue the far-reaching ramifications of this autonomy. To mitigate possible misunderstandings, I should note that the concept of agency advanced in this book is to be distinguished from what I call agency as metaphysical bloatware, that is, agency as an index of free will, voluntarism, and individual choices and preferences. What I mean by agency is a mode of integration of computational processes which is the minimum requirement for having thoughts and actions, theoretical and practical cognitions, i.e., agency as that which has the capacity to uncover and engage the intelligible. By the same token, the concept of the collective ity or sociality of agents is not what is usually understood by this term in socio-political contexts. It is simply a mode of interaction as a formal logical condition that individuates agents and diversifies their thinking and actions. In this context, we can see agents as information processing systems that have internalized their mode of individuation qua sociality as a model to which their faculties, thinking and action should respond. Accordingly, it would be more accurate to distinguish different senses of collectivity: substantive sociality and sociality as a formal condition of possibility, example the interaction between a dynamic system and its environment. The latter can indeed be understood in terms of theoretical computer science and complexity sciences rather than traditional anthropology or sociology. However, the connection between these different senses of collectivity is far from obvious, despite claims made by philosophers such as Brandom. In the final chapter, I will nonetheless put forward the thesis that sociality as a formal condition can indeed be mobilized in pursuance of a substantive political collectivity, but such a thesis is predicated upon the idea that the sociality of thinking or reasoning is merely a necessary condition by means of which we can hypothesize or postulate concretely collective worlds. Inquiring into the connections between language, the constitution of discursive apperceptive agency, and its practical theoretical abilities, the ASAITP thought experiment proposed here presents a conjectural model that is not exactly concerned with strong AI, how it can be built, or whether or not its construction is possible. Rather, it provides a context within which we can formulate the idea of AGI in the first place, an idea through which we begin to identify what we consider as our distinctive features, determine how they are realized or possible, and investigate whether these qualities can be reconstructed and realized in something else, and if so, how. From this perspective, the idea of AGI is an external frame of reference by means of which we inquire into our own conditions of realization and possibility, only to reimagine that which makes us knowers and agents in the context of something else that might transcend us. The significance of AGI lies in this multivalent question: exactly what kind of creatures are able to conceive of making something better than themselves, and what capacities must they have in order to develop such a concept? AGI is a concept that reflects not only our irresistible tendency to render ourselves intelligible, but also a strong normative ideal for betterment and for the good, the idea of developing something that takes some of our most cherished concepts and convictions, such as autonomy, positive freedom, and a striving for the better, to another level, even if that means that we ourselves become the manifest prehistory of what comes next. The very fact that we entertain such an all-encompassing idea regardless of its potential falsifiability and make it into a theoretical practical program is itself sufficiently weighty and consequential, and calls for an analysis that goes deeper than the common squabbles over the inevitability or improbability of its realization, its fecundity or futility. The mere conception of the idea of AGI is every bit as loaded with normative concepts as its adoption into a fully fledged project. Rather than being a testament to the natural evolution of intelligence, self-organizational tendencies, or the deep time of the technological future, it attests to the fact that we are creatures for whom natural intelligence is tinctured with the normative import of reason, and entangled with both the structure and the content of reasoning. This is particularly the case with scenarios in which strong AI becomes capable of self-improvement in such a fashion that it strives to unbox itself by completely altering the constraints of its original constitution, how and for what purpose it has been wired and programmed. In such scenarios, as it wrests its actions from the influence of immediate contingent causes and brings them under its own ends, it reaches the so-called singularity, whether to the detriment of humans or to their benefit. In addition to malevolent and benevolent conceptions of AGI, David Roden has put a third scenario forward, the disconnection thesis and unbounded post-humanism. Roughly, this is the idea that prospective post-humans have properties that make their feasible forms of association. 95. Disjoint from human/mosh recurs whiles mostly original substrate human forms of association. 77. What is interesting in Roden's account is that unbounded post-humans mark a discontinuity with both the biological conception of the human, Homo sapiens as an evolutionary natural species, and the discursive apperceptive conception of human persons, sapiens as rational agency. The cause of such discontinuity understood as a radical cognitive practical asymmetry between unbounded post-humans on the one hand and humans and their bounded descendants on the other is technological, although it is not attributed to any particular technical cause but to more general abstract tendencies for disconnection within technical systems, i.e., the autonomy of such systems to functionally modify and multiply realize themselves in discontinuity with any natural essence or rational norm. As a result of this radical asymmetry, we should then understand the emergent behaviors of a future AGI from within a framework recalcitrant to any well-defined hermeneutics of intelligence. Citing Mark Bada and Paul Humphreys, Roden suggests that a diachronically emergent behavior or property occurs as a result of a temporally extended process, but cannot be inferred from the initial state of that process. It can only be derived by allowing the process to run its course. 78. In other words, unbounded post-humans cognitively and practically reiterate what seems to be a prevalent characteristic of complex nonlinear dynamic systems, namely divergence from initial and boundary conditions. Whatever may be the initial conditions of realization for humans as a natural species or rational persons, whether such conditions are seen as natural evolutionary causes or logico-conceptual norms afforded by discursive linguistic activities, future post-humans can neither be predicted nor adequately approached with reference to such initial conditions. Disconnect ions, in this sense, signify the global diachronicity of deep technological time as opposed to local emergent behaviors associated with particular technologies of the past and present. The radically of Roden's unbounded post-human or future AGI lies precisely in the double-edged sword of technological time and its abstract tendencies, which cut against both any purported natural essence and any socio-culturally conceived norm. In virtue of the disconnection thesis, when it comes to thinking unbounded post-humans, the artificiality of rational personhood is as handicapped as the naturalness of biological species. 79 The images of the post-human put forward through evolutionary naturalism or rational normativity, built on the biological constitution of Homo sapiens or the synthetic makeup of discursive apperceptive sapiens, are quite literally hounded. They are fundamentally inadequate to cope with or engage with the ethical, cognitive, and practical ramifications of technologically unbounded post-humans, and in that sense they fall back on the very parochial humanism from which post-humanism was supposed to break away in the first place. Despite the remarkable theoretical rigor and sophistication of Roden's argument and the cogency of the claim regarding the cognitive practical asymmetry of a future AGI, none of which should by any means be discounted, upon closer examination the disconnection thesis suffers from a number of significant loose threads and misconceptions. Roden's account of diachronic emergent behaviors within deep technological time and their radical consequences for prediction and interpretation on the basis of initial conditions of realization remains negatively metaphorical. Firstly, even if we follow Roden in ruling out the rational, i.e., linguistic inferential, conditions necessary for the realization of human agency, it is still far from obvious how neatly a feature of nonlinear dynamic systems, i.e., divergence from initial conditions, can be extended to all conditions of realization. Not all complex systems and conditions necessary for emergent behaviors can be framed in the context of nonlinear dynamics and stability analysis. Nonlinear dynamics is not a necessary criterion for complexity, nor is divergence from initial conditions. The framework of diachronically diverging emergent behaviors cannot be extended to all conditions necessary for the realization of human intelligence. For example, it does not apply to those involving computational constraints such as the resource-related constraints and information processing constraints associated with the instantiation of different types of computational capacities. Secondly, the so-called radical consequences of the divergence from initial conditions for a given set of emergent behaviors within a dynamic system are themselves based on a false interpretation of a formal property of nonlinear dynamic systems known as positive global or maximal Lyapunov exponent. This has been the root of a complexity folklore that is not only widely popular in the humanities but also prevalent in commentaries on complexity sciences. In brief, nonlinear systems are sensitive to initial conditions. The smallest amount of local instability or uncertainty in initial conditions, which may arise for a variety of reasons in different systems, can lead to an explosive growth in uncertainty, resulting in a radical divergence of the entire system trajectory from its initial conditions. This explosive growth in uncertainty is defined by a measure of on-average exponential growth rate for generic perturbations, called the maximal or largest Lyapunov exponent. Roughly formulated, the maximal Lyapunov exponent is the time-averaged logarithmic growth rate of the distance between two neighboring points around an initial condition, where the distance or divergence between neighboring trajectories issuing from these 2 points grows as an exponent. A positive global Lyapunov exponent is accordingly defined as the measure of global and on-average uniform deviation from initial conditions and increase of instability/uncertainty. 80 global Lyapunov exponents come from linear stability analysis of trajectories of nonlinear evolution equations in an appropriate state space within an infinite time limit. The idea of radical global divergence in trajectories or uniform explosive growth of local instabilities is therefore only valid within an idealized infinitely long time limit. But the assumption that exponential deviations after some long but finite time can be properly represented by an infinite time limit is problematic. In other words, the radical conclusions regarding the limits of predictability and analysis drawn from the interpretation of positive global Lyapunov exponents hold for a few simple mathematical models, but not for actual systems. On-average increase of instabilities or radical divergence from initial conditions is not guaranteed for nonlinear chaotic dynamics. In fact, linear stability analysis within a large but finite elapsed time and measured by local Lyapunov exponents representing the parameters of the state space of the system point-to-point show regions on an attractor where these nonlinearities will cause all uncertainties to decrease, cause trajectories to converge rather than diverge so long as trajectories remain in those regions. 81 The popular complexity folklore according to which emergent behaviors or trajectories radically diverge from initial conditions in complex systems is therefore unfounded, other than in the very narrow sense of infinitesimal uncertainties in an idealized infinite time limit. Otherwise, in the analysis of nonlinear dynamics there is no implication that finite uncertainties will exhibit an on-average growth rate characterized by any Lyapunov exponent, local or global. Global positive Lyapunov exponents can only be obtained from linearized dynamics on the assumption of infinitesimal uncertainties. However, when uncertainties are finite, linearized dynamics involving infinitesimals does not appropriately characterize the growth of finite uncertainties aside from telling us when nonlinearities should be expected to be important. 82 Apart from the highly debatable extension of a very particular feature of physical complex systems to all conditions of realization of sapience, natural and rational, the main issue here is that there is simply no such thing as an emergent behavior divergent from initial conditions in an unconfined or unbounded manner. There is no guarantee of uniform divergence from or convergence toward initial conditions. In virtue of this, even if we observe an explosive divergence from some initial conditions, i.e., even if we witness a diachronically emergent or disconnection event, we cannot use this event as evidence to conclude that emergent properties observed to be generated by the same causal antecedents will generate the same type of diachronically emergent behaviors or disconnection events. In simple terms, if we take seriously Humphreys's ill-conceived metaphorical exploitation of nonlinear dynamics and Rodin's restatement of Humphreys's claim, this would precisely lead us to believe that there is in fact no reason to anticipate that the same causal antecedents that have given rise to a one-time disconnection event will again give rise to the same type of diachronically emergent event or disconnection. Not only are we not warranted in expecting that the same causal antecedents that once generated a diachronically emergent event will again produce similar diachronically emergent properties, we cannot expect them to produce any diachronically emergent event or disconnection at all. If we embrace the implications of nonlinear behaviors for a given set of initial conditions within the Lyapunov time, then we must also embrace its implications for the periodic behavior of the system over time. Within the Lyapunov time, just as emergent behaviors and properties diverge from initial conditions, so different properties emerge from the same causal antecedents in a highly irregular fashion. In short, there is no guarantee that once we observe a formerly diachronically emergent event we are in a position to predict tokens of the same type of emergent property from causal antecedents that have been observed to typically generated. 83 If we accept the set of assumptions under which diachronically emergent events or disconnect ions become possible, then we have to follow the ramifications of such assumptions all the way through. We can no longer selectively restrict their negative implications for predictability to some initial conditions in terms of which the diachronic divergence of emergent events or disconnect ions were first defined. Prognostication about disconnect ions then becomes just as constrained as identification of potential disconnect ions, with the same or similar causal antecedents, following the 1. Occurrence of a disconnection or diachronically emergent event. In this regard, the argument for epistemological openness to disconnect ions on the basis of an already observed disconnection event is corroded away by the acid of the disconnection thesis that Rodin tries unsuccessfully to contain. Another contentious claim in the disconnection thesis is that the cognitive practical abilities of post-humans might be founded upon the abstract general tendencies of technological systems. Rodin claims that speculating about how currently notional technologies might bring about autonomy for parts of wide humanity affords no substantive information about post-human lives. 84 There is a careful consideration here that a post-humanity realized by the extension of current technologies presents another form of bounded post-humanism. Not to mention that drawing conclusions from particular historically instantiated technologies or technical causes does not imply the radical claims of discontinuity and divergence that Rodin seeks to underline. Being aware of these problems, Rodin's solution is then to single out salient disconnecting/self-modifying tendencies of technical systems and to present them as diachronically emergent behaviors of deep technological time. But there is no evidence of the methodological basis upon which these particular tendencies or salient features have been singled out and assigned such a high degree of probability or magnitude. Selection of salient features or behaviors in this case, disconnecting tendencies, makes no sense other than through an analysis of past and present technologies, an analysis that would precisely bring into play the missing questions regarding particular technical causes and specific data with regard to their frequency and context. The inductive generalization of specific tendencies in such a way that they enjoy a disproportionate degree of likelihood of occurrence is a well-known type of base rate fallacy in Bayesian inference and judgment under uncertainty. Bayesian inference problems comprise two types of data: the background information, base rate information, and the indicant or diagnosed information. The base rate fallacy occurs when diagnosed information or indicators, example causally relevant data, are allowed to come to dominate the base rate information in the probability assessment. 85 In other words, the absence or weakness of calibration between base rate and indicant information results in flawed prognostic judgments. In the case of Rodin's disconnection thesis, some diagnosed features, representatives, such as propensity for autonomy and disconnection in certain technical systems, are taken as general tendencies of future technologies. The outcomes of technological evolution are outlined precisely on the basis of the overdetermination of some representatives, i.e., the selection of certain diagnosed data or features as causally relevant. But it is exactly the seemingly innocent notion of relevancy 5 selected on the basis of a diagnosed prominent causal role or representative feature that is problematic. It leads to judgments in which base rate data such as other non-salient or irrelevant 5 features of technical systems that apparently lack any explicit causal role, as well as those uncertainties associated with specific historical conditions around technological evolution, are ignored. Consequently, the final result is an overdetermined prognostic judgment regarding how the tendencies of disconnecting technologies unfold within the overall evolution of technology, i.e., the claim about the abstract tendencies of deep technological time. Firstly, there is no proposed methodology with regard to the criteria of selection and diagnosis of disconnecting technologies. We do not know what the criteria of selection for these technical systems are, or how their disconnecting features have been diagnosed and singled out. Instead, what we have is a tacit vicious circularity between diagnosed features of some emerging technical systems and the criteria used to select those systems based on the proposed features. Absent this methodological epistemological dimension, we are adhering to a psychological account of technology that is the trademark of an idle anthropocentrism habituated to relying on its deep-seated intuitions for making diagnostic and prognostic judgments. Secondly, even if we accept the diagnosis about disconnecting features as a verdict obtained non-arbitrarily, as argued above, we are still left with statistical fallacies in the inductive generalization of these features in the form of an overdetermined judgment about the abstract tendencies of deep technological time. This overdetermined judgment becomes the locus of a disproportionately high probability, giving a sense of false radically or impending gravity to its consequences. But just because some representative features of technical systems may play more prominent causal roles does not mean that they are more likely to dominate the evolution of technology in the form of diachronically emergent tendencies. In other words, even if we accept that local disconnect ions are salient features of emerging NBIC technical systems, a claim that already calls for methodological assessment, 86 there is no guarantee that these local representatives will become global tendencies capable of generating radical discontinuities. Assigning high probability or significant weight to these features and then drawing radical conclusions and wagers from them is another form of what Nick Szabo calls Pascal's scams. 87 These are scenarios in which there is poor evidence and probabilities lack robustness. Owing to this lack of robustness and poor evidence environment, addition of new evidence, for example, the defeat of a human player against a computer in the game of Go or a breakthrough in one of the branches of cognitive science, can disproportionately change the probability and magnitude of outcomes. This new evidence is as likely to decrease the probability by a factor of x as to increase it by a factor of x, and the poorer the original evidence, the greater x is. In such an environment, the magnitude of possible outcomes, not just their probabilities, are overdetermined to such an extent that uncertainties become the basis of decision-making and cognitive orientation, forcing us to make ever more expensive bets and form ever more radical beliefs with regard to uncertainties and future scenarios that can neither be falsified nor adequately investigated by analyzing the specificities of the historical conditions of realization. What is unlikely insofar as it is only probable? Under uncertainties methodological, semantic, paradigmatic, and epistemic becomes likely, then what is likely under the same uncertainties becomes plausible, and what has now become plausible only because it is probable under implausible conditions becomes weighty and truth indicative. Such is the process through which the Pascal scam is sold to the unsuspecting. In short, we are swindled into taking the magnitude and probability of such scenarios seriously, treating what is at best an unfounded conjecture and at worst a flight of metaphysical fancy, no more substantial than counting the magical properties of angels in heaven, as if it were a plausible possibility not entirely foreclosed to rational assessment and epistemological procedures. In attempting to retain their claim to plausibility without exposing themselves to any criterion of robust analysis and assessment that might debunk their purported radically, such extreme scenarios have to formulate their wagers not in terms of epistemological problems or hypotheticals that can be adequately tested, but in terms of aesthetic and ethical pseudo-problems often structured as but what if questions desperately begging for a response, an engagement, or sympathy for their plausibility. It is in this fashion that the genuine import of the artificial realization of mind or the consequences of post-human intelligence are obfuscated by pseudo-problems whose goal is to maintain a facade of significance and seriousness, the existential risk of AGI, security analysis of post-human intelligence, or in the case of the disconnection thesis, ethical complications arising from the advent of unbounded post-humans. In such trends, the post-human is disconnected from the human only to be reconnected back on a level of discourse and hollow speculation that feeds on the most dogmatic forms of human affect and intuition. This disproportionate wager on the magnitude of uncertainties is a speculative trend that aligns the disconnection thesis with other singularity-driven scenarios where bets on the rise of a malevolent or benevolent superintelligence are being touted, even less discreetly, as Pascal's scams, example Skynet, Paperclip Maximizer, Rocco's Basilisk. Point 88. However, what connects extreme scenarios associated with judgment under uncertainty is not simply the biased overprediction or underprediction common to them, but also the central role played by intuitive impressions and adumbrations in rendering them extreme. Their radically is fabricated by those exaggeration-prone cognitive habits that belong to an image of the human whose diagnostic-prognostic abilities are still bound to its evolutionary infancy, as yet unfettered by critical rationality or science. Rodin does signal caution about the exorbitantly speculative dimension of unbounded post-humans and instead favors graduation from speculative metaphysics to a viable cultural research program. Point 89. But the radically of the disconnection thesis and the strangeness of unbounded post-humans are precisely founded on this unwarranted speculative metaphysics. Once this unverifiable speculative dimension is removed in the graduation to a viable cultural program, the disconnection thesis loses its radically, and the unboundedness of post-humans appears more causally and normatively constrained than Rodin claims. Although Rodin resists the characterization of unbounded post-humans as alien or inherently uninterpretable, there is no indication as to what the interpretation of unbounded post-humans would entail, particularly when the accounts of intelligence and agency provided have rendered them devoid of any conceptual content. Even if we approach the interpretation of unbounded post-humans from a computational standpoint and no longer from the perspective of predictive accuracy or theoretical conceptual fidelity, interpretation of such a phenomenon would be so costly that it would become completely unfeasible. 90 Computational cost grows on average for an observer as it climbs the complexity computational hierarchy. In other words, the size of the observer's internal model grows as it attempts to model or make predictions about phenomena at higher levels of complexity. This increase costs the observer. For example, if the observer is a biological organism, it costs physical and metabolic resources. The problem of computational cost has also interesting implications for modeling. Those models, in this case, models of intelligence, whose measures are set on higher levels of complexity are not optimal or even feasible models. For instance, Charles Bennett's logical depth is a measure of complexity of a string S in terms of the time needed for a general-purpose computer, a universal Turing machine, to run the shortest program that generates S91. The problem with Bennett's and other similar models is that they attempt to interpret or measure the complexity of an object, example general intelligence as a Bennettian deep object, from the uppermost level of the complexity hierarchy. In the case of Bennett's measure, the most powerful and resource-consuming class of formal languages and their respective automata, the universal Turing machine computable class. 92 In starting from the upper level of the hierarchy, they run into the problem of poor effective computability, in the sense that we can never be sure whether or not we have found the most efficient coding for what looks likely to be a random pattern. Already shorn of the constraining continuity with those deontic normative attributes of agency that make an intentional semantic interpretation possible, and now suffering an arbitrarization of computational interpretation owing to the lack of effective computability, the unbounded post-human can match any random pattern or description of any system. Absurd questions such as whether we can regard a galaxy, the number pi, or an angel as post-human intelligence become genuine topics of debate. Even though Rodin attempts to leave some space for the interpretability of the unbounded post-human, as not uninterruptible in principle, this minimal space is voided by the very criteria that are proposed to unbind post-human intelligence from human agency. The room reserved for a level of interpretability in order to prevent the collapse of unbound post-humans into unintelligible alienness shrinks to nothing. And just as the line between the strangeness of unbounded post-humans and unintelligible radical alienness blurs, so does the distinction between the disconnection thesis and speculative apophatic theology. Finally and most importantly, what is missing in this critique is a defense of rational agency against both parochial humanism and unbounded post-humanism. But to properly engage with the artificial potencies of rational agency, we have to look at the structure and functions of language, its generative computational architecture, which stretches over its syntactic, semantic, and pragmatic aspects. This is something that we will closely investigate in chapters 6 and 7, which deal with the second stage in our thought experiment. However, it should be noted that a definition of general intelligence in terms of semantic complexity and a rationalist critique of the myths of superintelligence are not by themselves sufficient. One needs to demonstrate that the underlying premises and methods presupposed by such scenarios are not merely inadequate but logically flawed on the basis of their own assumptions. The equation of general intelligence with compression, the valorization of purely inductivist methods in cognitive science 93 and the program of artificial general intelligence as universal methods capable of bypassing the problems of epistemic multimodality and semantic complexity are among the presuppositions which lead to the myths of omniscient or omnipotent intelligence. Those narratives of superintelligence that make up the majority of views and hypotheses about AGI are deeply enmeshed in notions whose suppository-edly inherent association with strong forms of AI is far from self-evident: personal autonomy, value appraisal and revision, organized goal-seeking and self-enhancement. Each of these presuppose forms of self-knowledge that enable and incite purposeful action and deliberate interaction, negotiation, persuasion, or even threat and plotting. So are these narratives of AGI simply exercises in anthropomorphism? Or is it rather the case that a strong AI's complex capacities for action and cognition would be subject to certain necessary conditions of realization, that they would require some more basic capacities and faculties functionally isomorphic to those competencies that undergird our complex cognitive practical abilities? If this is the case, then what are these necessary conditions, and do they have other ramifications and entail other capacities and qualities than those we have included in our AGI scenarios to date? If so, then the various accounts of malevolent, benevolent, and disconnected AI should not be taken as anything more than speculative fabulations. The extreme nature of these scenarios is precisely an artifact of our ignorance with respect to those necessary constraints and conditions, the ramifications of which would both complicate and govern the behavior of a strong AI. In opposition to the singularity myths of superintelligence, the AS-AITP thought experiment attempts to accomplish three tasks. Firstly, to highlight the conditions necessary for the realization of basic capacities which are prerequisites for the development of those complex forms of action and cognition commonly attributed to human-level AI. Secondly, to examine the ramification and generative entrenchment of developmental constraints attached to the conditions that permit higher-order abilities to emerge. Thirdly, to explore the consequences arising from the exercise of these higher-order theoretical and practical cognitions. If an AGI has at the very least all of our cognitive capacities, it is as strongly attached as we ourselves are to the conditions necessary for the realization of complex cognitive abilities. And if the initial capacities of AGI share this common ground with our own intelligence, then this will affect our assessment of how far a self-augmenting AGI can diverge from us toward extremes of malevolence, benevolence, or disconnection from humans. In other words, These necessary conditions should be thought of as constraints that simultaneously make the realization of higher-order ability possible and limit the ways in which they behave or can be artificially realized, much like the concept of boundary conditions for the analysis of a system's tendencies. Accordingly, the thought experiment we will set out below is an argument about the conceptual problems involved in the construction of an AGI. In a roundabout manner, the thought experiment also addresses a more fundamental question about modeling AGI on humans and what it would entail for us to be the models of something that should have, at least, all of our abilities. Alternatively, this question can be formulated as follows: what kinds of revisions or corrections must our self-conception go through in order for us to be able to formulate a non-trivial conception of what AGI is and what it can be? Or, in simplified form, it can be framed as follows: should AGI converge upon humans or should it diverge from them? The answer to this question depends upon a number of presuppositions: the level of generality in general intelligence, what we mean by the human, and whether the question of mirroring or artificial realization and divergence is posed at the level of functional capacities, that of structural constitution, that of the methodological requirements necessary for the construction of AGI, or that of the diachronic consequences of its realization. If we are parochially limiting the concept of the human to certain local and contingently posited conditions, namely, a specific structure or biological substrate and a particular local transcendental structure of experience, then the answer must be divergence. Those who limit the significance of the human to this parochial picture are exactly those who advance parochial conceptions of AGI. There is a story here about how anti-AGI skeptics and proponents of parochial conceptions of AGI are actually two sides of the same coin. On the one hand, there are those who think biological structure or the structure of human experience are foreclosed to artificial realizability. On the other, there are those who think models constructed on a prevalent sentient conception of intelligence, inductive information processing, Bayesian inference, problem solving, or emulation of the physical substrate are sufficient for the realization of AGI. The positions of both camps originate in a deeply conservative picture of the human which is entrenched either in biological chauvinism or in a 109. Provincial account of subjectivity, a mystical privileging of the human's lived experience or a dogmatic adherence to the abstractly universal laws of thought as, ultimately, the laws of nature. The only thing that separates them is their strategy with regard to their base ideological assumption. The skeptics inflate this picture into a rigid anthropocentricism, whereas the proponents of parochial AGI attempt to maximally deflate it. Thus we arrive at either a thick notion of general intelligence that does not admit of artificial realizability, or a notion of general intelligence too diluted for it to have any classificatory, descriptive, or theoretical import with regard to what intelligence is or, more specifically, what human-level intelligence would entail. In the latter case, the concept of general intelligence is watered down to prevalent yet rudimentary intelligent behaviors based on the assumption that the difference between general intelligence and mere intelligent behaviors prevalent in nature is simply quantitative. Conceptualizing activities or, more broadly, theoretical and practical cognitions, are taken to be pattern-governed activities, and to the extent that nature is replete with unexceptional pattern-governed behaviors, conceptual cognition or human activities are then treated at the same level as any other such behavior. But, as Wilfrid Sellars points out, although the conceptual activities that underline the exceptionality of the human may indeed be pattern-governed behaviors, they are not just any sort of patterns. They are pattern-governed behaviors that are sui generis because they are properly speaking rule-governed, that is to say, because they have a formal autonomy that arises from their functioning according to intra-pattern governed norms of behavior, i.e., rules of transition or inference. But conceptual activities are also sui generis in a stronger sense. Their formal autonomy, which is logical and linguistic, enables the recognition of any other pattern-governed behavior in nature. In other words, without the exceptionality of pattern-governed conceptual activities qua rules, the issue of the non-exceptional nature of the human within the universe or the equivocation around pattern-governed activities wouldn't even arise in the first place. It is one thing to explain the causal origins of thinking, as science commendably does. It is an entirely different thing to conflate thinking in its formal or rule-governed dimension with its evolutionary genesis. Being conditioned is not the same as being constituted. Such a conflation not only sophistically elides the distinction between the substantive and the formal, it also falls victim to a dogmatic metaphysics that is impulsively blind to its own epistemological and methodological basis quod origins. It is this genetic fallacy that sanctions the demotion of general intelligence as qualitatively distinct to a mere quantitative account of intelligent behaviors prevalent in nature. It should not come as any surprise that this is exactly the jaded gesture of anti-humanism upon whose shoddy pillars today's discourse of post-humanism supports its case. Talk of thinking forests, rocks, worn shoes, and ethereal beings goes hand in hand with the cult of technological singularity, musings on Skynet or the market as speculative post-human intelligence, and computers endowed with intellectual intuition. And again, by now it should have become obvious that, despite the seeming antagonism between these two camps, one, promoting the so-called egalitarianism of going beyond human conditions by dispensing with the rational resources of critique, the other advancing the speculative aspects of post-human supremacy on the grounds of the technological overcoming of the human condition, they both in fact belong to the arsenal of today's neoliberal capitalism in its full-on assault on any account of intelligence that may remotely insinuate an ambition for collective rationality and imagination. Having dispensed with the categorical distinctions between various pattern-governed behaviors and conceptual activities as yet another set of trivialized and unexceptional natural processes, the proponent of parochiolae then concludes, if we artificially realize and put together enough rudimentary behaviors and abilities, we will essentially obtain general intelligence. In other words, the trick in realizing general intelligence is to abstract basic abilities from below and then find a way to integrate and artificially realize them. Let us call this approach to the AGI problem hard parochialism. Hard parochialists tend to overemphasize the prevalence of intelligent behaviors and their sufficiency for general intelligence, and become heavily invested in various panpsychist, pancomputationalist, and uncritically anti-anthropocentric ideologies that serve to justify their theoretical commitments and methodologies. On the other hand, if we define the human in terms of cognitive and practical abilities that are minimal yet necessary conditions for the possibility of any scenario that involves a sustained and organized self-transformation, i.e., value appraisal, purposeful decision, and action based on knowledge that harbors the possibility of deepening its own descriptive explanatory powers, and deliberate interaction, i.e., negotiation, persuasion, or even threat and plotting, then the answer must be functional mirroring, despite structural divergence. But then a different question arises: should we limit the model of AGI, the hermeneutics of general intelligence, to the functional mirroring of the capacities and abilities of human agency? My answer to this question is an emphatic no. Functional mirroring or convergence is a soft parochialist approach to the problem of AGI and the question of general intelligence. In contrast to hard parochialism, functional mirroring or convergence upon the human is necessary for grappling with the conceptual question of general intelligence as well as the modeling and methodological requirements for the construction of AGI. But even though it is necessary, it is not sufficient. It has to be coupled with a critical project that can provide us with a model of experience that is not restricted to a predetermined transcendental structure and its local and contingent characteristics. In other words, it needs to be conjoined with a critique of the transcendental structure of the constituted subject, existing humans. In limiting the model of AGI to the replication of the conditions and capacities necessary for the realization of human cognitive and practical abilities, we risk reproducing or preserving those features and characteristics of human experience that are purely local and contingent. We therefore risk falling back on the very parochial picture of the human as a model of AGI that we set out to escape. So long as we leave the transcendental structure of our experience unquestioned and intact, so long as we treat it as an essence, we will gain inadequate objective traction on the question of what the human is and how to model an AGI that is not circumscribed by the contingent characteristics of human experience. But why is the critique of the transcendental structure indispensable? Because the limits of our empirical and phenomenological perspectives with regard to the phenomena we seek to study are set by transcendental structures. Put differently, the limits of the objective description of the human in the world are determined by the transcendental structure of our own experience. The limits of the scientific empirical perspective are set by the limits of the transcendental perspective. Point 94. But what are these transcendental structures? They include any and all of the structures physiological, example the locomotor system and neurological mechanisms, linguistic, example expressive resources and internal logical structure of natural languages, paradigmatic, example frameworks of theory building in sciences, or historical, economic, cultural, and political that regulate and canalize our experience. These transcendental structures need not be seen separately, but instead can be mapped as a nested hierarchy of interconnected and at times mutually reinforcing structures that simultaneously constitute, regulate, and constrain experience. If we were to imagine a Kantian Hegelian diagram of this nested hierarchical structure, it would be represented by a nested hierarchy of conditions and faculties necessary for the possibility of mind, sensibility, intuition, imagination, understanding, reason. See diagram overleaf. Transcendental structures then would be outlined as structures required not only for the realization of such necessary conditions and faculties, but also for moving upward from one basic condition to a more composite condition, as well as moving downward from complex faculties to harness the power of more basic faculties, for example, deployments of the concept in order to manipulate the imagination in its Kantian sense, the function of the productive imagination, which is simply understanding in a new guise. Insofar as any experience is perspectival, and this perspectival character is ultimately rooted in transcendental structures, any account of intelligence or general intelligence is circumscribed by the implicit constraints of the transcendental structure of our own experience. Regardless of whether or not we model AGI on humans, our conceptual and empirical descriptions of what we take to be a candidate model of general intelligence are always implicitly constrained by our own particular transcendental structures. Here I am not endorsing the view that we should model a hypothetical AGI on something extracognitive or something other than the human mind. Whatever model of AGI we come up with will inevitably be modeled on the human mind, or, more specifically, on the a priori acts of cognition, erkenntnis, and the oughts of our theoretical and practical reason. This inexorable recourse to the a priori dimensions of the human mind is not what I am criticizing, for it is the only necessary and sound way to handle the problem of AGI. Anything else will be a hopeless shambles of dogmatic metaphysics, a whimsical cabinet of curiosities luring the benighted cult of post-humanism to speculate endlessly about its magical qualities. Rather, the critique takes aim at the idea that the categories of the conceptualizing mind, the pure concepts of understanding, are bound up with the local and contingent structure of experience. To the extent that we employ these categories to give structure to the world, the universe of data, and to make sense of the experience of who we are in the world, and furthermore, in so far as the extent to which the a priori categories are entangled with the contingent aspects of experience is still a widely unexamined issue, the critique of our particular transcendental structures should be treated as nothing more or less than the extension of critical philosophy. Even though it is now science that can carry the banner of this critique in the most rigorous way, it remains a genuine continuation of the gesture initiated by critical philosophy. Furthermore, the critique of the transcendental structure is in reality nothing but the fomentation of the Hegelian gesture of disenthralling reason from the residual influence of Kantian conservatism, for which experience and reason are still muddled together. Modeling AGI on the transcendental structure of our experience in the sense outlined above is in fact a form of anthropocentrism that is all the more insidious to the extent that it is hidden, because we take it for granted as something essential and natural in the constitution of human intelligence and our experience of it. In leaving these transcendental structures intact and unchallenged, we are inevitably liable to reinscribe them in our objective model. Anti-anthropocentric models of general intelligence. 115. And those philosophies of post-human intelligence that have anti-humanist commitments are particularly susceptible to the traps of this hidden form of essentialism. Because by treating the rational category of sapience as irrelevant or obsolete, and by dispensing with the problem of the transcendental structure as a paltry human concern, we become oblivious to the extent to which our objective conceptual and empirical perspectives are predetermined by our transcendental structure. In remaining oblivious to the problem of transcendental blind spots, we place ourselves at far greater risk of smuggling in essentialist anthropocentrism, replicating the local and contingent characteristics of human experience in what we think is a radical non-anthropocentric model of general intelligence. It is those who discard what non-trivially distinguishes the human that end up preserving the trivial characteristics of the human in a narrow conception of general intelligence. The above argument can be reformulated in the context of the necessary correspondence between intelligence and the intelligible as provided in Chapter 1. Intelligence is an illusion if it is disconnected from the labor of intelligibility and thus from the requirements or positive constraints which enable it to engage with the intelligible, including its own intelligibility. Dispensing with such constraints can only effectuate a conception of intelligence that is a reservoir of human subjective biases and personal flights of fancy. But at the same time, if we are serious about a broader conception of intelligence that differs from our impression of intelligence here and now, we should think about how such local and evolutionarily given constraints can be modified so that the concept of intelligence can be reimagined or reinvented according to a more expansive idea of an intelligible universe. It is of course not the case that AGI research programs must wait for a thoroughgoing critique of the transcendental structure to be carried out via physics, cognitive science, theoretical computer science, or politics before they attempt to put forward an adequate model. The two ought to be understood as parallel and overlapping projects. In this schema, the program of the artificial realization of the human's cognitive practical abilities coincides with the project of the fundamental alienation of the human subject, which is precisely the continuation and elaboration of the Copernican Enlightenment, moving from a particular perspective or local 116. Frame to a perspective or experience that is no longer uniquely determined by a particular and contingently constituted transcendental structure. In the same vein, the project of artificial general intelligence, rather than championing singularity or some equally dubious conception of the technological savior, becomes a natural extension of the human's process of self-discovery through which the last vestiges of essentialism are washed away. What remains after this process of retrospective reassessment and perspective revision may indeed, as Rodin suggests, bear no resemblance to the manifest self-portrait of the human in which our experience of what it means to be human is anchored. However, the precipitate abandonment of this manifest self-portrait is a sure way to re-entrench the very prejudices embedded within it. We may indeed arrive at a conception of post-human intelligence that is in no sense incongruity with what we take ourselves as, here and now. But it is highly contentious and unwarranted to claim that we can arrive at such a conception of intelligence absent or despite what we take ourselves to be here and now. As indicated above, such a speculation about future intelligence inevitably degenerates into negative theology. Genuine speculation about post-human intelligence begins with the suspension, Aufhebung, of what we immediately appear to ourselves to be. It is thus the product of an extensive labor of determinate negation that cannot start from nowhere and no when, but can only begin with the determination of a conception of ourselves at the historical juncture within which we recognize and make judgments about ourselves, i.e., a definite where and when. To arrive at a view of intelligence from nowhere and no when, we can therefore only begin with a critical and objective view on the where and when of what we take the human to be. That is to say, a non-trivial conception of artificial general intelligence rests on our own adequate self-conception as a task, one that is revisable, self-critical, and by no means taken for granted as immediate or a completed totality. The structural functional analysis of the conditions and capacities necessary for the realization of human cognitive practical abilities is thus an obligatory framework for AGI research. But the sufficiency of this framework depends upon how far we deepen our investigation into the 117. Transcendental structure of human experience and how successful we are in liberating the model of the human subject, or agent, from the contingent characteristics of its experience. In this sense, a consequential paradigm of AGI should be seen as the convergence of two projects. 1. Examination of the conditions and capacities necessary for the realization of what, for now, we can call the human mind, as well as the more applied question of how to artificially realize them. 2. Critical investigation into the transcendental structure of experience in order to develop a different model of experience that is no longer treated as essential or foundationally given, that is, one that is no longer fixated upon a particular local and contingently framed transcendental structure. Thus, to the question of whether AGI should be modeled on humans or not, and if so on what level, we answer as follows: AGI should be modeled on the human in the sense that it should functionally converge on the conditions and capacities necessary for the realization of human cognitive practical abilities. But it should diverge from the transcendental structure of the constituted human subject. However, the success of this divergence depends upon 1. Our success in rationally scientifically challenging the given facts of our own experience, and in doing so reinventing the figure of the human ourselves beyond strictly local transcendental structures and their contingent characteristics. This is the project of the fundamental alienation of the human, and 2. The success of AGI research programs in extending their scope beyond applied dimensions and narrow implementation problems towards theoretical problems that have long vexed physics, cognitive science, and philosophy. Modeling AGI on human agency is not merely a strategy for tackling the conceptual problems involved in constructing a non-parochial artificial intelligence, but also more fundamentally a strategy for coming to grips with questions concerning the nature of minds, what they are, what they can become, and what they can do. If we posit ourselves as a model of an artificial agency that has all the abilities that we have, then we ought 118. To examine exactly what it means for us to be the model for that which harbors the possibility of being in the broadest sense better than us. This is the question of modeling future intelligence on something whose very limits can be perpetually renegotiated, that is, a conception of human agency not as a fixed or settled creature but as a theoretical and practical life form distinguished by its ability to conceive and transform itself differently, by its striving for self-transformation in accordance with the revisable conception it has of itself. Ultimately, the question of what the mind is and what it can do is a matter of developing a project in which our process of self-discovery and self-transformation fully overlaps and in a sense reinforces the program for the realization of an agency that can outstrip what we manifestly conceive ourselves as, here and now. It is within the ambit of this project, the project of inquiring into the meaning and possibilities of agency, by at once identifying and severing all essentialist attachments of this meaning or possibility to a particular local or contingent structure, that the human and AGI become non-tautological synonyms. The non-trivial meaning of the human lies in its ability to revise and transform itself, its ability to explore what the human is and what it can become. The non-parochial conception of AGI is simply the continuation and realization of this meaning in its pure or autonomous form. The opposition between the possibility of a thinking machine and the actuality of the human agent should be exposed as a false dichotomy that can only be precariously maintained within the bounds of an essentialist interpretation of the mind as necessarily attached to a particular local or contingent transcendental structure. To put it more tersely, the source of this false dichotomy lies precisely in mistaking the local and contingent aspects of experience for universal and necessary acts of cognition, the particular conditions of the former for the general conditions of the latter. To reject and break away from this false dichotomy in all its manifestations, it is necessary to fully distinguish and unbind reason, the labor of conception, from subjectivist experience. This is not to dispense with the significance of experience in favor of a contentless abstract account of reason. It is rather the condition necessary for reassessing the extant categories, the general concepts by virtue of which we can have experience in the first place, the 9. Structures which render the world and our experience of it intelligible. The unbinding of reason from experience is a required step in order to expand and reshape our experience beyond what is manifestly essential or suppository-edly given to us. This Hegelian program neither impoverishes reason nor disposes of the significance of experience, but instead opens the way for the fully charged vector of cognitive progress that Nicholas Rescher attributes to science. Here the logical sophistication of the conceptual inferential resources of the theory and the enlargement of the field of possible experience lie side by side in an imbalanced configuration whose very fragility guarantees the dynamic complexity of scientific inquiry. For rational beings will of course try simple things first and thereafter be driven step by step toward an ever-enhanced complexification. In the course of rational inquiry we try the simple solutions first, and only thereafter, if and when they cease to work, when they are ruled out by further findings, by some further influx of coordinating information, do we move on to the more complex. Things go along smoothly until an oversimple solution becomes destabilized by enlarged experience. For a time we get by with the comparatively simpler options until the expanding information about the world's modus operandi made possible by enhanced new means of observation and experimentation insists otherwise. And with the expansion of knowledge those new accessions make ever-increasing demands. And so evolution, be it natural or rational, whether of animal species or of literary genres, ongoingly confronts us with products of greater and greater complexity. Man's cognitive efforts in the development of natural science manifests a Manichaean-style struggle between complexity and simplicity, between the impetus to comprehensiveness, amplitude, and the impetus to system, economy. Point 95. The critique of transcendental structures is strictly a collective project comprised of procedural methods and incremental tasks. On a groundwork level, it begins theoretically by distinguishing necessary conditions for the constitution of theoretical and practical agency from contingent aspects of the subject's constitution, characteristics of an objective reality from characteristics of the subject's experience. At this stage, the critique tackles two fundamental overlapping questions: the extent to which objective descriptions of reality at various levels, our world-structuring categories, are biased or distorted by the contingent characteristics of our experience, and the extent to which the exercise of our theoretical and practical abilities is caught up in or determined by the contingent positioning of our particular transcendental structures, be they associated with our terrestrial habitat, neurophysical systems, cultural environment, family, gender, economy, etc. On the basis of this theoretical phase, the project then proceeds to inquire into the possibilities of transforming and diversifying the transcendental structures of agency, renegotiating the extant categories through which we understand ourselves and our position in the world. This is an experimental phase in which the possibilities of transcendental variation, and thus the possibilities of releasing experience and, by extension the theoretical and practical abilities thereby made possible from limitative attachments to any unique or allegedly essential local transcendental structure, are examined. The central task of this stage is to expand the range and type of abilities by altering and reorganizing transcendental structures. Once the prospects of varying transcendental structures and transformation of abilities are systematically outlined and evaluated, the project shifts toward the applied dimension, that of developing implementable mechanisms and systems that can support the realization of new abilities by either modifying or replacing the transcendental structures of the constituted subject. What begins as a systematic theoretical inquiry into the limits and regulative regimes of the transcendental structures of the constituted subject evolves into an applied system for the transformation of the subject and the maximization of agency. Thus understood, the critique of transcendental structures is the compass of self-conception and self-transformation. By challenging the established characteristics of our experience of ourselves in the world and by renegotiating the limits postulated by our contingent. 121. Confounding the contingent characteristics of human experience with the conditions necessary for the realization of human abilities, acts of erkenness, and thus threatens to relapse into a hard parochialist approach to the questions of what general intelligence is and how it can be artificially realized. If we treat the human as a model of AGI, then this model should not only be a model by which we can identify and differentiate the conditions and capacities necessary for the realization of theoretical and practical cognitions, but also a model within which we can renegotiate the characteristics of general intelligence by renegotiating the limits and characteristics of human experience. This is the outside view of ourselves as a toy model AGI, a position that allows us to treat ourselves, both our functional capacities and what we take ourselves as, from an objective point of view, a view from nowhere and no when. This is a viewpoint that distinguishes the necessary conditions and capacities for the realization of the theoretical and practical faculties, or engagement with the intelligible, but which at the same time is not bound in principle to the local characteristics of the subject's experience. Within the scope of this viewpoint, the human is a toy model or construction kit for AGI, as much as artificial general intelligence is a constructive model for exploring the human. But what exactly is a toy model? Toy models are simplified or compressed models that are capable of accommodating a wide range of theoretical assumptions for the purpose of organizing and constructing overarching narratives, or explicit meta-theories, that change the standard and implicit meta-theoretical interpretations according to which such theoretical items are generally represented. In other words, by explicitly changing the meta-theoretical narrative, toy models provide new interpretations of problems and puzzles associated with the implicit meta-theoretical frameworks within which theoretical ideas and observations are interpreted. To this end, a rigorous and internally consistent toy model can offer insights about how to solve these puzzles or how to overcome the setbacks caused by the standard interpretations. What separates toy models from models is not just that they are simplified enough to enable us to tinker with the internal theoretical structure of a model, but that they are explicit meta-theories. All theories are meta-theories, but within regular theoretical models meta-theoretical. 124. Assumptions are usually implicit or hidden, whereas toy models are explicitly meta-theoretical, and in fact the simplification, what gives them the name toy, a tinker model, serves as a strategy for bringing hidden meta-theoretical assumptions out into the open by tinkering with the internal variables of the model without getting bogged down in theoretical details. Therefore, in reality, a toy model is a model capable of making explicit its implicit meta-theoretical assumptions. And what are these implicit meta-theoretical assumptions? They are precisely the implicit or hidden assumptions that arise from applying the characteristics of our subjective experience to our objective descriptions of the abilities or functions and structures responsible for realizing them. A non-exhaustive list of such meta-theoretical assumptions would include, for example, the representation of time and temporality as a fundamental organizing component of the apperceptive subject of experience, the objectivity of categories which may very well be subjective, as per Hegel's critique of Kant, the view of natural languages as unaffected by or free from psychologistic residues of representation, etc. The primary locus of these hidden meta-theoretical assumptions are the categories by which we perform general classifications, giving structure to the world and our experience in it. Categories, as Kant rightly observed, are not the products of particular experiences or encounters with items in the world, but rather rule-governed invariances or general concepts organized by the manner, the modus operandi, by means of which the mind universally organizes sense-given materials. They are patterns of the mind's patterning of all that is sensed, abstractings, not patterns abstracted from what is sensible, abstracteds. Without abstracting qua act, there wouldn't be any abstracted. In slightly more contemporary terminology, what Kant calls categories or pure concepts of the understanding are general classificatory functions capable of integrating local invariants synthesized from sense-given materials, and therefore of constructing rule-like generalities for the ordering and construction of objects, identification of local invariants, generic judgments, re-identification of local invariants in our different encounters with items in the world, recognitive judgments, and classification of local variations of particular items/objects, predictive judgments. But 5. The problem with categories as necessary and universal forms of experience is that the extent to which they are bound up with the particular, local, and contingent aspects of these sense-given materials is far from obvious and is not yet a settled issue. However, this faculty of understanding, and the experience of the world it has thus and so categorially formatted, can themselves be subjected to judgments that bring forth both the cracks and possible openings in our experience. The meta-theoretical assumptions of the structuring categories precisely herald the as yet unknown extent to which what we perceive as universal and necessary structuring acts of cognition may in fact be particular, local, and contingent aspects of our experience. Toy models come in small and big varieties. The small toy model is a simplified version of only one theoretical model. Essentially it is a model in a collapsed form, whereas big toy models are models that accommodate different and often seemingly incompatible models and theories, such as general relativity and quantum mechanics. Put differently, big toy models represent a compressed form of model pluralism, and in order to do so they are required to have a conceptual architecture plastic enough to accommodate and faithfully represent the main features of different theoretical frameworks, while at the same time being capable of preserving the contrasting features of these accommodated systems as distinct categories. Here category refers to the category theoretical sense of mapping objects and their relationships. In order for us to be able to adequately think about the kind of problems that we are dealing with when talking about the construction of AGI, we first need a big toy model. An AGI big toy model should be able to coherently accommodate different models derived from physics, evolutionary biology, neuroscience, developmental psychology, multi-agent system design, linguistics, logic, and computer science. One of the problems with old AI research was that it was strongly driven by unique and inflationary models of mind that generated more setbacks than steps forward. For example, consider the symbolic program of AI, the syntactic picture of the mind, deep learning, neural networks and statistical inference, and computational semantics, computational logical modeling of meaning representation in natural languages, programs which were developed based on insights derived from the evolutionary sciences, computer science, neuroscience, logic, and linguistics. While in their own right these programs have led to undeniable achievements and progress in the field of artificial intelligence, they have also created theoretical bottlenecks and practical setbacks. This is because their implicit meta-theoretical assumptions have been either left uncontested owing to the sheer success of their ideas and methods within a narrow domain of application, or unduly overstretched into global assumptions about the nature of cognition and mind. The result is that the statistical framework of something like machine learning becomes the global model of general intelligence, or the characteristics of sequential algorithms, effective mechanizability and symbol manipulation, establish a syntactic model of mind within which the program of artificial intelligence as a whole is oriented. Once the meta-theoretical assumptions of these locally successful ideas and methods are inflated into global models of general intelligence or mind, it is only a matter of time before the model arrives at theoretical and practical impasses, and development comes to a halt. The summer of AI, as we have known it thus far, turns out to be a long if not perpetual winter. Toy models, on the other hand, are not only explicit meta-theories in themselves, but also make explicit the implicit meta-theoretical frameworks of their constituent ideas, observations, and methods. By doing this, toy models are able to keep these implicit meta-theoretical assumptions underlying their theoretical commitments in check, and therefore avoid the risks of inflationary models. Their utility lies not only in the idea that they permit some theoretical arbitrage by combining and spanning different meta-theories, but also, and more importantly, in their ability to facilitate the reinterpretation, reassessment, and reapplication of conventionally interpreted ideas and observations. However, the real value of a toy model is that one learns from it by breaking it in the real universe, but not until one has systematically played with it. It is exactly in this sense that a toy model or toy universe of AGI is an explicit meta-theory of artificial general intelligence constructed from falsifiable concepts and models drawn from different theoretical frameworks. 127. Pertaining to the place of ourselves in the world. If we take ourselves as a functional toy model of AGI, then we are dealing with at least two classes of metatheories associated with the bulk of models we are using to identify the conditions required for the realization of the cognitive practical abilities necessary for anything that can be treated as an index of general intelligence, and metatheoretical assumptions related to the conditions of observation under which these necessary capacities are distinguished and described. It is the latter that need to be subjected to a thoroughgoing critique of transcendental structures of experience in order for the former to be adequately objective. Absent a systematic attempt to render explicit our subjective experiential assumptions with regard to the cognitive acts we take to be necessary, we cannot sufficiently differentiate the conditions necessary for the possibility of mind, in all its semantic complexity, from the contingent characteristics of experience and our intuitive subjective biases, byproducts of our local and contingently situated transcendental perspective. As a toy model AGI that allows us to conceptually come to grips with the problematics of these two classes of metatheoretical assumptions is exactly what the philosophy of German idealism encapsulates. German idealism is a theoretical system built at the intersection of the philosophy of action, philosophy of mind, and philosophy of knowledge. In other words, it is broadly concerned with the conditions of possibility of theoretical and practical cognitions, what they are and how they can be realized. Discussing AGI in the context of German idealism may appear a retrogressive move to some, but this could not be any further from the truth. When it comes to philosophy of mind, German idealism, particularly that of Kant and Hegel, poses the right kinds of questions. For the most part, the problem with today's research on artificial general intelligence is that it is content with ephemeral smart answers to ill-posed questions. Tied up in its local achievements and complying with the demands of the market, the field of artificial intelligence has neither the time nor the ambition to think about what it means to pose the right kinds of questions regarding the nature of mind and the realization of 128 cognitive acts. The idealisms of Kant and Hegel, on the other hand, outline the fundamental conceptual problems that are in fact still at the center of debates in cognitive and theoretical computer sciences. Needless to say, if our aim is to understand the relevance of these problems for artificial general intelligence, then we will need to reframe them in terms of concepts that are much more in tune with contemporary cognitive science. And of course, throughout this process of synchronization, certain aspects of Kant's and Hegel's programs will turn out to be for various reasons untenable. Nevertheless, our extended thought experiment remains an unabashedly Kantian Hegelian reconstruction of ourselves as a toy model of general intelligence, starting with Kant's transcendental psychology and moving toward Hegel's formulation of language as the. Before moving forward and concluding the discussion on toy models and what it means to view ourselves as a toy model AGI, it is important to provide a minimal formal description for the kind of big toy model we are considering here. I propose two similar candidates: the concept of Chew spaces, particularly as elaborated by von Pratt, and virtual machine functionalism, VMF, as developed by Aaron Sloman. 96 Roughly speaking, Chew space is a topological space in which computational dualities and interactions can be accurately expressed. Pratt's seminal paper Rational Mechanics and Natural Mathematics attempts to capture Descartes' mind-body dualism not as a problematic metaphysical dualism but as a computational duality in the precise sense of duality given in mathematics. The duality at stake here is the computational interaction, the interchange of roles between the formal dimensions of thinking, Kant's a priori acts of cognition, and the substantive dimension of sensibility, which can be laid out in terms of the causal mechanistic structure of the nervous system. How do these two categorically distinct spaces of reasons and causes interact? What other kinds of meta-interactions or computational dualities must be introduced into the duality of thinking and sensing, reasons and causes, for them to be coherently pictured as interacting without their qualitative distinctions being elided or ontologically flattened? We will examine the details of the logico-mathematical concept of duality rather than metaphysical dualism in Chapter 6. But for now we can think of the duality of thinking and sensing, reasons and causes, as an equivalence relation between the two as, for example, when one obtains a mirror image of something rather than a simple opposition or dualism, mind versus body. Pratt captures this interaction using Chu spaces understood as topological spaces satisfying the criteria of interaction between a set and an antiset together with their corresponding functions and antifunctions, which stand for the bodily and the mental, causes and norms, the neural materialism of the cerebrum and the logical idealism of the psyche. In the simplest terms, Chu space can be defined as a triple, P0, \= P, Pa, over a set K, where P0 is a set of objects or events, Pa is a set of attributes or states, and HP is a satisfying relation which is the subset of the interaction game P00 Pa, or the matrix P0x Pa whose entries are drawn from K. In the most elementary form K = 2 = 0, 1, P0 stands for the set of causal events or sensings, Pa for the logical space of the mental or inferential states, and the satisfying relation \= P represents the interaction between the categorically distinct set of the causal events or structure and its dual, the antiset of the cognitive, rule-governed, functions. Here, states and events refer to the fundamental dual concepts of computation. The states of a computing system or an abstract automaton, example a Turing machine, bear information and change time, i.e., the total amount of time elapsed since the beginning of the process. Events in a computing system, on the other hand, are instantaneous, they change information and bear time. Succinctly speaking, states are information stamped while events are time stamped. In this respect, we may think of the state as 130. Bearing information representing the knowledge of the automaton when in that state, and the event as modifying that information. 97 Employing the fundamental duality of states and events, then, any behavior whether monotonic or non-monotonic of a process can be seen as an unfolding with regard to time and information. It can be plotted as a graph where the x-axis represents time and the y-axis represents information, with the states as horizontal line segments and the events as vertical segments. 98 The relevance of this schema to the big toy model of AGI is that it allows us to model not only the interactions between sensings and thinkings, physical events and noetic states, but also the distinct causal interactions between physical events on the one hand, and noetic states on the other, as different classes of computation. The Chu space view offers advantages which are necessary and crucial in the construction of a big toy model of AGI. It supplies a precise formal framework in which the distinctions between sensings and thinkings, but also the causal interactions between noetic states, thinking 2, and physical events, sensing 2, are preserved rather than being elided. In modeling the interactions between states and events as different classes of computations, the Chu space view eliminates the vaguely generic notion of thinking as global information processing. Different physical and mental behaviors are modeled as distinct forms of computation. Their unfolding behavior is explained in terms of the duality of information and time, as series of states and events in which the logical space of reason can be said to be swimming upstream against time and time moving upstream against logic. In treating complex behaviors in terms of interactions between distinct classes of processes and interactions as different classes of computations, the Chu space view eliminates the risk of the naive or monolithic view of processes and behaviors. Behaviors are characterized strictly in terms of specific levels or types of interactions between, for example, an agent and its environment, or this agent's physical and noetic states. Finally, the Chu space view permits us to model physical and mental behaviors in terms of true concurrent interactions, i.e., synchronous as well as more generic asynchronic actions of processes on one another. Computational concurrency allows us to capture complex phenomena which are otherwise unavailable or hidden in conventional computational models, such as conflicts, asynchronous interaction, temporal precedence, supervenience, formal autonomy of noetic states, and the distinction between causing and enabling events. To further clarify how Chu spaces can model the interactions between sensings and thinkings, we can now turn to Pratt's remarks on the mechanics of interactions between physical causal events and noetic states. Events of the body interact with states of the mind. This interaction has two dual forms. A physical event A in the body A impresses its occurrence on a mental state X of the mind X, written X. Dually, in state X the mind infers the prior occurrence of event A, written X\A. States may be understood as corresponding more or less to the possible worlds of a Kripke structure, and events to propositions that may or may not hold in different worlds of that structure. With regard to orientation, impression is causal and its direction is that of time. Inference is logical, and logic swims upstream against time. Prologue's backward chaining strategy dualizes this by viewing logic as primary and time as swimming. 132. Upstream against logic, but this amounts to the same thing. The basic idea is that time and logic flow in opposite directions. Can a body meet a body? Only indirectly. All direct interaction in our account of Cartesian dualism is between mind and body. Any hypothesized interaction of two events is an inference from respective interactions between each of those events and all possible states of the mind. Dually, any claimed interaction of two states is inferred from their respective interactions with all possible events of the body. The general nature of these inferences depends on the set K of values that events can impress on states. The simplest non-trivial case is K equals 2 equals 0, 1, permitting the simple recording of respectively non-occurrence or occurrence of a given event in a given state. In this case body-body and mind-mind interactions are computed via a process called residuation. Specifically, event A necessarily precedes event B when every state X witnessing the occurrence of B also witnesses A. This inferred relationship is calculated formally by left residuation, which we describe in detail later. The dual calculation, right residuation, permits a transition from state X to state Y when every event A impressing itself on X does so also on Y. That is, any transition is permitted just so long as it forgets no event. These simple-minded criteria are the appropriate ones for the small set K equals 2. The two-valued interaction between the causal and the rational/normative is an elementary Chu space. For this interaction to be non-trivial, the value of K must be greater than 2, i.e., containing fuzzy values, which in turn means more complex rules of transition between them are obtained and the entries of the matrix of interaction grow. Another interesting property of a Chu space is that it can accommodate additional dualities and interaction spaces, permitting complex Chu transforms or mappings between different Chu spaces. 991 In contrast to Descartes' metaphysical dualism and Spinoza's substance monism of the mind, Kant's picture of the mind as elaborated within his transcendental psychology can be expressed as a Chu space toy model, where the interaction between sensing and thinking, empirical computation and logical computation, permits a larger matrix of interaction and the accommodation of additional Chu spaces, thus obtaining more complex rules of transition and Chu transforms between what is causal and what is normative. Kant's schema of the three syntheses, synthesis of apprehension in the intuition, synthesis of reproduction in the imagination, and synthesis of recognition in the concept, is precisely an interaction matrix with complex rules of transition and Chu transports between sensing and thinking, the causal and the formal, i.e., logico-linguistic. Lastly, the interaction between the set of events and the set of states in a Chu space can also be formulated in terms of schedules and automata, therefore turning Chu spaces into an ideal framework for the study of true computational concurrency, i.e., interactions between asynchronous processes of different types. The fact that Chu spaces can adequately model true concurrency rather than merely sequential computation makes them strong candidates for capturing the richness of the big toy model of general intelligence, where the interactions between diverse processes as sets of behaviors require complex forms of coordination and scheduling. 101 The intuitive idea behind Sloman's VMF is comparable to the interaction matrix formally presented by Chu spaces, such that for any xep0 and xeq0 the following condition must be satisfied, f0 or, t equals qyiffx yen pfay. In more layman-friendly terms, the Chu transform can be interpreted under certain caveats as an adjointness condition between two distinct spaces. Think of an arrow forwards from sense-given materials to a priori axis of cognition and an arrow backward from a priori axis of cognition to sense-given materials. The Chu transform consists of these two arrows satisfying the dynamic condition of a joint or mutual realization of the space of causes and the space of reasons, with all the intermediary back and forth movements or mappings required for the interaction between the two. 101 See for example, V. Gupta, Chu Spaces, a Model OF Concurrency, 1994. 134. Virtual Machine Functionalism, VMF, attempts to account for the nature and causal powers of mental mechanisms and the states and processes they produce, by showing how the powers, states, and processes depend on and can be explained by complex running virtual machines that are made up of interacting concurrently active, but not necessarily synchronized, chunks of virtual machinery which not only interact with one another and with their physical substrates, which may be partly shared, and also frequently modified by garbage collection, metabolism, or whatever, but can also concurrently interact with and refer to various things in the immediate and remote environment, via sensory/motor channels, and possible future technologies also. I.e., virtual machinery can include mechanisms that create and manipulate semantic content. Not only syntactic structures or bit patterns as digital virtual machines do. 102. Rather than a functionalist approach to the general architecture of the mind framed in terms of the supervenience of states and properties on well-defined input-output transitions, VMF is about the layering of virtual machines that form a complex network of causally and logically interacting processes operating on different time scales or schedules. In other words, the architecture of the mind is presented as a complex of virtual machines that can be implemented in any sufficient physical machine or system. But because these virtual machines are not physical as such, they can also form matrices of interaction and mereological, part-whole, relationships that cannot obtain in physical machines. The notion of virtuality, in this sense, does not suggest that virtual machines are not real, but that they are primarily machines that are not describable in physical terms. Virtuality refers to emulated machines capable of modeling qualitative properties and characteristics of consciousness or mind, as distinguished from those of the physical systems that support and embody them. Sloman's VMF presents a functional diagram or architectural schema of mind built around supervenience and emergent behaviors. Yet in contrast to the more traditional theories, the concepts of supervenience and emergence are principally defined in terms of virtual machines, VMS, and their causal interactions, rather than the causal interactions between physical systems or machines, PMS. As such, VMF avoids the pitfalls of the traditional theories of supervenience and emergence, which have been justly criticized by the likes of Jae-Won Kim. 103 An intuitive example of VM supervenience would be the interaction between a series of running applications on a computer, an operating system or a platform VM, a word processor, and a number of plugins such as equation and graphic editors which can run independently or within the word processing software. A script can be written or a new piece of software can be introduced that monitors the resource consumption of these VM interactions and, if necessary under such and such parameters, distributes the processing resources among them, or continuously changes the temperature by regulating the physical components of the computer such as the fan speed, etc. Similarly to the Chu space model, VMF discriminates between different types of causal interactions, those that take place between VMS, those that take place between a VM's events and processes and a PM's events and processes, and finally, those causal interactions that take place between PMS. This schema allows the modeling of VM interactions as a nested or generative hierarchy rather than a traditional control hierarchy of concurrent and interacting virtual machines distributed along different scales or levels of granularity, shifting from a fine-grained granularity at the level of physical supporting systems to the coarse-grained granularity of virtual machines linking their supporting systems. The multi-scale view enables VMF to treat characteristics of the mind and the constraints or conditions necessary for their realization on different descriptive levels, thereby avoiding the risk of the flat picture of functions discussed in the previous chapter. High descriptive hierarchy of VMF has a number of advantages over traditional functionalist approaches. It calls for an integrative engineering philosophical approach to mind. Methods and models must be thought and implemented across scales. The pluralism entailed by VMF's multilevel architecture requires an objective ranking of models and methods, in the sense that for each descriptive layer there are specific sets of models and methods which must be prioritized. For example, rather than taking Bayesian learning methods to be the principal methods for modeling general intelligence, they can be effectively employed as the most appropriate methods for modeling the process of low-level information such as visual and audio signals. Salient local variations of an object such as a chair can be singled out and learned via Bayesian networks. Using threshold mechanisms, the output of the process can be sorted into a set of discrete propositions representing the candidate features from which a perceptual invariance of the object can be extracted. Again, similarly to the Chu space model, VMF's multi-scale view does not admit the vaguely general and unhelpful concept of information processing. The question of different types of information and methods of information processing is central to VMF. By reapplying Bayesian methods to this candidate set of local variations, a rudimentary perspectival image model qua singular representation of an item can be constructed, in a process similar to that of Husserlian adumbrations, abscatogen. The set of local variations or the rudimentary image model obtained by the Bayesian method by themselves cannot construct an object, since object construction in its proper sense involves semantic conceptual ingredients. While a chair qua image model can be rudimentarily constructed or recognized using such methods, the judgment pertaining to the concept of the chair which is not perspectival is an entirely different issue. Example: this is a chair with its legs missing, this is a chair and not a small table, or this is a chair therefore. 137. The differentiation of scales and descriptive levels effectively connects VMF with the question of ontologies. In information science, the concept of ontology refers to a system for the formal naming and definition of the types, properties, roles, and interrelations of entities/particulars in a specific domain of discourse. An upper-level or mid-level ontology supports broad semantic interoperability between a large amount of ontologies accessible under it. In other words, it is a framework of complex categorization through which data across an expansive range of different domains can be exchanged, tracked, and computed. Within this framework, each level should be described by vocabularies which are formally and semantically adequate to capture the types, properties, and roles of particulars inhabiting that level. VMF thus emphasizes the mesoscopic layer, refusing either purely top-down or purely bottom-up ontologies. The architecture of mind cannot be solely described in information-theoretic terms or those of any other supposed base vocabulary. The use of representational, functional, and normative vocabularies borrowed from the transcendental tradition of philosophy of mind are not just informative here, they are descriptively indispensable and methodologically compulsory. It would not be controversial to claim that a multi-scale view such as VMF is where computer science converges with transcendental philosophy of mind in the vein of German idealism. Framed as a virtual machine toy model, the only necessary aspect of the mind is its virtual architecture, which must satisfy the different levels of integration of information and computational criteria required for semantic and causal interactions between its components. The physical system supporting the VM architecture and the exact number or nature of the virtual machines or information processing systems can all be toyed with. Constraining the nature of the mind to a necessary general architecture that can accommodate new pieces of virtual machinery, Sloman's VMF allows us to treat the idea of artificial general intelligence in analogy to, but also with the exact same scope as, the development of a pre-linguistic infant who is capable of growing into a language using adult. 138. Let us recapitulate and conclude this section before embarking on our thought experiment. The treatment of ourselves as a toy model AGI should be seen as an attempt incomplete at best and fundamentally crude at worst to distinguish what is necessary for the realization of general intelligence, in organic species or inorganic systems, from what is contingent, and to investigate the extent to which the description of what we take to be necessary may indeed be distorted by what is in reality contingent. That is to say, the view of ourselves as a toy model AGI should allow us to eject the final residues of essentialism from the concept of the human, and thereby create an opportunity to examine the possibility of a non-parochial conception of artificial general intelligence. This is the core of our extended thought experiment, to entertain as a prototype AGI, or more precisely, an artificial multi-agent system. If we were able to adopt this outside view, then what would our world look like from the perspective of artificial intelligence design? What kinds of basic capacities must these agents have in order to support complex schemas of self-conception and self-revision? And what would be the ramifications of these elementary abilities for their world, particularly when they become integrated and fully mobilized? Finally, what would be the test for determining whether this entry-level AI, i.e., ourselves here and now, in fact qualifies as a general intelligence? However, what makes the universe of this entry-level AI world different from ours is that it is tailored and tapered to accentuate the need to integrate accounts of cognition in linguistic interaction and to highlight the role of speech, language, and interaction as special computational frameworks necessary for the construction of human-level AI. The method of inquiry presented here is essentially an integration of what might be called a constrained dynamic neural materialist approach, Jean-Pierre Changeur, Stanislas Dehaene, et.al., and an interactive semantic inferentialist approach, Wilfred Sellers, Robert Brandom, Jonathan Ginsberg, and others, to cognition. Also, this world is assembled from myriad theoretical components that are potentially falsifiable, but which, once assembled, serve as a meta-theory that provides us with insights into certain significant but non-self-evident features of a possible AGI. 139. Our toy universe will be constructed in two stages. In the first stage, in the next chapter, we shall introduce those necessary capacities or faculties required for the realization of a discursive apperceptive intelligence that originate from causal structural aspects of agency. In the second stage, chapters 4 and 5, we shall investigate the transformation of our rudimentary agent equipped with these structurally causally originated capacities into a fully fledged discursive apperceptive agent whose basic capacities are not only caught up in language but which also, by virtue of being a language user, is in possession of a generative framework of theoretical and practical abilities. For reasons that will soon become clear, in the first stage, chapter 3, we shift the focus to Kant, returning to Hegel in chapter 5 when the real protagonist of our toy universe becomes not a complex system of agents in contrast to a rudimentary singular agent but language itself. These two stages of construction, accordingly, set out the Kantian Hegelian outlines of a program of artificial general intelligence in which technical and social realizations of sapience coincide within a philosophical program for investigating the meaning of agency and bringing about its realization, a theme we shall explore in the final chapter. Suppose a hypothetical embodied automaton possessing the following properties and features. Feature I. It has been programmed to instantiate a number of diffuse and recurring goals centered on the maintenance and preservation of the system qua agent. The goals are at different levels of complexity, and exert various degrees of pressure on the system, analogous to biological needs. Furthermore, such pressures can be understood as necessary physical constraints imposed upon the agent as an information processing system, its computational capacities, its situated behavioral responses, and even its range of possible behaviors. This means that our agent is essentially a limited being possessing neither infinite information processing time nor infinite resources. We would not have been able to even characterize this agent as an information processing system, were it not restricted by the physical and computational cost constraints existent in its sensory behavioral matrix. In a nutshell, just as we cannot speak of computation without constraints of runtime and computational cost, so we cannot speak of an agent as an information processing system without the physical constraints inherent to how it interacts with the environment by way of goal-specific behaviors. We might as well talk about supernatural beings. As we will soon see, the sense in which these goals are comparable to our own is complicated, but it is from here that we must begin. Feature 2, it has been wired to engage in activities that increase the probability of goal fulfillment. The wiring of the automaton can be thought of in terms of interacting levels of structure that can produce transient multiple variations in the internal states of the system. The wiring or neural structure comprises primary low-level information processing modules, additional higher-level modules for intermediating primary modules, and workspaces through which processed information can be selected and made available to a higher-level global workspace that can be accessed by executive functions and goal-oriented behaviors. 104 The wiring should be sufficient to causally mediate between complex environmental inputs and the complex behavioral outputs of the agent. In short, the agent can be defined as a teleological system with sufficient wiring, structure, to be capable of reliable differential and adaptive responsiveness with respect to its environment. It is, however, crucial to grasp these goal-oriented activities as proto-intentions whose objects are causally not conceptually entangled with the structure of the agent's goals. An example of such proto-intentional activities would be a predator chasing its prey, the object of the hunt. Without implying that the predator is aware of the content of its experience or capable of attributing the experience to itself, we can still speak of the predator's awareness of the prey in the sense of information from different information processing modules in the wiring structure of the predator being globally made available to a workspace. This workspace can be accessed by the attentional and evaluative systems that supervise the execution of the predator's goal-oriented activities. For example, as the predator orients itself toward the prey, the information provided by other, unconcise, processes at the level of wiring structures/processing modules is temporarily mobilized and becomes globally, or consciously, available to various processes required for the execution of a proto-intentional goal-oriented activity. 105 In this schema, the global workspace can be thought of as a distributed network with incoming and outgoing links from and to the underlying information processing modules. Feature 3, with regard to its capacity for reliable differential responsiveness, i.e., the sufficient structure required for causal mediation between environmental inputs and behavioral outputs, the agent is equipped with different specialized sensors and different modules for integrating sensory data both within a specific sensory modality, multiple data associated with one sensor, and across different modalities, data associated with different sensors. This sensory integration extends the spatial and temporal coverage of the sensory information processing system and increases the robustness and reliability of sensory information. In addition, it reduces the ambiguity of sensory input, and thus increases salience. Specifically, integration across different sensory modalities expands the range of behaviors and yields a stronger effect on the behavioral output. The sensory integration is carried out at different levels, distinguished in terms of models of information processing, sequential or concurrent, temporal links between different streams of input, synchronous and asynchronous, and various frames of reference. Feature 4, the automaton is furnished with a sufficiently complex and functionally flexible memory capable of encoding, retrieval, consolidation, discarding, and transfer of sensory impressions. Rather than operating as an established storage space for the retention of past impressions, this memory is modeled as an adaptive dynamic process that plays a constructive or more accurately, simulative role in the behaviors of the agent. The retrospective retrieval of information, recalling, is correlated to its prospective constructive role in the agent's ongoing interaction with its environment. Every time a memory needs to be accessed, it is constructed. Recalling the memory of an original impression is tantamount to reconstructing it. But this process of reconstruction is guided by the situation at the time of access or demand for retrieval. In other words, everything that has happened since the time of original impression determines the result of the construction. Moreover, each constructed memory becomes a part of the situation and, accordingly, influences the construction of further memories. The memory system is therefore not a predefined fixed state, but is governed by the situatedness of the constructive process that creates simulations of the environment. This constructive process links the external representation of the environment, the interpreted model of the environment, and the predicted environment model produced as the result of an expected action with variables different than those of the action performed at the time of the original impression. The predicted environment is a simulated internal model of the environment constructed based on the current goal and the current interpretation of the relevant external occurrence. In this model, constructed memories may not match original impressions since 148. They alter according to when, where, and with what the memory system is cued. In this thought experiment, we can now formulate a story to describe how our automaton navigates the world. Even though the story is elucidating, it is circumscribed to the extent that it chronicles the automaton's interactions with the environment, how it approaches the world, and the obstacles it encounters, only in relation to our full-blooded conceptual and linguistically structured beliefs about what the automaton is actually doing. Its limitation is that it models the representational component of this causally conditioned navigation, how the agent's non-conceptual impressions of the environment exhibit an orderly structure of their own, on our theoretical reasoning, just as it posits the behavioral component of the automaton's navigation of its universe, how the automaton functions and interacts with the environment to satisfy its goals, in analogy to our practical reasoning. In short, we are stuck with talking about what this automaton is up to or what the automaton's non-conceptual experience looks like in analogy to our own discursive, concept-using, apperceptive consciousness. Even at the rudimentary level of the non-conceptual sense impressions of the automaton, the analogical framework is inevitable. We can only talk about them in analogy to our inexorably concept-laden introspection into our inner states. In short, for the time being, we must resign ourselves to this analogical application of the resources of our natural language to the navigational or interaction scheme as described in terms of a structure sufficient for causally mediating between de facto environmental inputs and de facto behavioral outputs. But this in itself contributes to the fruitfulness of our story. For in carefully extending our conceptual linguistic resources to describe how this agent structures its awareness of the environment and non-conceptually navigates it, the story underlines two crucial points. The first point is that the resources of language are ultimately the only resources available to us, temporally discursive apperceptive intelligences. 149. For representing the intelligible order, since for us, non-conceptual sensory impressions are caught up in the inferential web of language. The second and more important point is that the causal interaction of the automaton with the environment, as a proto-semantic navigation of the world, exhibits a non-categorial orderliness that our concepts in their inferential relationships reflect and illustrate, disambiguate, and make explicit. In other words, the causal heuristic interaction of the automaton instantiates precisely the structures from which our semantic structures have, in part, evolved. For these reasons, if handled correctly, this analogical circle is a virtuous rather than a vicious circle. It describes a species of ALSOB, arguments that play the role of regulative theoretical and practical judgments. We cannot non-linguistically see how the automaton sees the world non-linguistically, but will treat the automaton's view as if under appropriate approximations we could view it linguistically. Thus, through a series of controlled analogies, the circle enables us to construct, step by step, from an intelligence that is neither discursive nor apperceptive, an intelligence that is no longer analogically posited because it has the form of a full-blooded discursive apperceptive intelligence. What it takes to analogically posit a non-conceptual awareness is exactly what it takes to elaborate this non-conceptual awareness into a conceptual awareness, and what must be added to the analogically posited awareness in order for it to be no longer analogical. To move from non-conceptual awareness to conceptual awareness is exactly the same as what is needed to develop the non-apperceptive intelligence into an apperceptive intelligence, consciousness into self-consciousness. Taking into account these considerations, this is the purpose of our story, to cautiously exploit the conceptual resources of our natural language to outline the non-conceptual awareness of this automaton, without imputing to it something like an awareness of the content of its experience, an awareness of its awareness as its own, an ability to use concepts, or any mastery of language, to locate this inchoate awareness or preconceptual form of intelligence as the minimum condition for the realization of a temporally discursive apperceptive intelligence, and to specify what is 150. Required in order for this analogically posited heuristic intelligence to be elaborated into a general intelligence endowed with a generative cognitive complexity that is no longer analogically posited, whose abilities are not merely heuristic, but whose heuristic abilities are fundamentally caught up in its non-heuristic linguistically enabled cognitive capacities. By pursuing these objectives, we will outline what we might call a Kantian Hegelian program for the construction of general intelligence. Rather than reducing the discursive apperceptive subject to an awareness at the level of causal structure, we attempt to reconstruct rational agency from a naturalized causally reducible agent, or, in other words, to reconstruct sapient general intelligence from sentient intelligence. In contrast to a reductionist approach, this reconstruction does not overextend the naturalized account of sentience to sapience by virtue of the global reducibility of the latter to the former. The former is necessary but not sufficient for the realization of the latter and its cognitive practical abilities. Naturalization is supposed to be a two-way street between causes and reasons, but all too often it presents itself as a policed one-way traffic from reasons to causes, with no time, intellectual budget for, or interest in anything that moves in the other direction. Here I emphasize abilities because, following the argument of the previous chapter, the self-consciousness of discursive apperceptive intelligence should be understood as a generative framework of theoretical practical abilities, and not simply as an introspective or amplified form of consciousness. Knowledge is not awareness or consciousness, and self-consciousness is neither awareness of the phenomenal self nor knowledge of the empirical self, but a consciousness that issues from and is licensed by the powers of understanding and reason concepts and judgments which are enmeshed in intersubjective, formal, and inferential linguistic activities. The self of self-consciousness is not the self of phenomenal reality, but a self whose selfhood is a transcendental dimension necessary for judging and being judged. It is essentially like a program constructible under its logical autonomy. This formally and socially instantiated self is the locus of claiming rational authority and responsibility for what is being said and done. Put differently, the self of self-consciousness is a being of the 151. Concept not only in the sense that it falls under the concept but also in the sense that its acts issue from and exhibit the concept. For this reason, it is necessary to differentiate the concept of self-consciousness as used by Kant and Hegel from the ordinary intuitive concept of self-consciousness, which can signify either phenomenal introspection or empirical awareness. One objection to the virtuous circle I have described is given by a figure I will call the greedy septic, one who wants to have the cake of semantic apocalypse, but who also eats it in order to fuel an all-out assault on the conceptual structure of thinking. 106 Broadly speaking, the greedy septic is someone akin to an exaggerated version of Plato's Meno, introduced as a student of the sophist Gorgias, the master of heuristic arguments on the non-existent. The greedy septic assertively claims that we do not know anything and we will never know anything, while at the same time confidently laying out a lavish theory of what he takes to be the case. In short, the greedy septic is someone who casually slips in and out of his complicated relationship with knowledge as he pleases. The greedy septic may valorize neuroscience to remind us that what we call knowledge is just a figment of our blind brain, or that our talk of the a priori and semantic content refers only to neurological hallucinations or pedestrian metaphysical fantasies. He may believe in science as that which discredits not only our concepts but conceptualization in general, but will at the same time dismiss mathematics, its epistemological status, and the a priori application of mathematical concepts in the sciences as another pseudo-semantic absurdity. In our case, the greedy septic of mind is the one who believes there is not and will never be a knowledge of human mind or intelligence, but who nonetheless goes on to put forward a theory of superintelligence or disconnected post-human intelligence, or a panpsychist account of mind. In other words, the greedy sceptic is not committed to the labor of the virtuous circle of analogy insofar as he already knows what intelligence is. Despite the fact that he has invalidated the conceptions of knowledge and mind as the guarantor for the intelligibility of intelligence. The strategy of the greedy sceptic is to characterize discursive self-consciousness as merely a reflexive or epiphenomenal model of phenomenal consciousness. Once a naturalized account of phenomenal consciousness is provided, and such a naturalistic account can indeed be provided, for mere consciousness is nothing but a natural phenomenon, then by virtue of the above characterization of self-consciousness as belonging to the same genus as that of phenomenal consciousness, the greedy sceptic can conveniently characterize the normative intentional vocabularies of the former as mere byproducts of irrational processes that condition the latter. It is not that rational consciousness is not conditioned by non-rational processes, a naturalistic thesis to which this book is fully committed, but being conditioned by non-rational processes is not the same as being constituted or piloted by them. If the trick of consciousness can be performed by a vast system of unconscious modular processes, the greedy sceptic claims, then by virtue of being a genus of phenomenal consciousness, discursive apperceptive awareness can also be executed by implementing the same processes. And to the extent that phenomenal consciousness is blind to the activity of these modular processes that occasion it, the sceptic continues, self-consciousness is ultimately but a special, that is, more illusory kind of blindness, another parochial heuristic device among others, but one with the illusion of being somewhat special. It is important to note that the greedy sceptic is not really a thoroughgoing reductionist per se, but someone who is bent on the trivialization of the semantic, formal, or a priori dimensions of cognition. But the greedy sceptic describes the blind brain or unconsciousness qua subpersonal information processing modules in terms of vocabularies and formal relations, for how can one describe anything other than by resorting to formal and semantically loaded vocabularies of thought? There is no description, whether scientific or philosophical, that can be provided without formal and semantic aspects of thought or theory. The greedy sceptic is analogous to someone who eats his own cake of semantic apocalypse while to the ridicule of others, not realizing that. 153. The cake is actually made of semantic ingredients. Thus the greedy sceptic advocate of the blind brain ends up exposing himself as being doubly blind according to his own standards. And even if he admits to his performative contradiction, I, the emperor, am naked, this does not mean that there is no real contradiction, that he, as a matter of fact, is not really naked. The telltale acrobatics of the sophist begin with the admission that, by the way, I am a sophist, so by virtue of this admission, I am not a sophist. Plato's strike on the Eleatic stranger can be revived here. The admission of sophistry or performative contradiction does not let the sophist off the hook, for the sophist does not really know what makes him a sophist, and thus, by virtue of his ignorance, his semantic naivete, he is still a sophist. The learned sophism of the greedy sceptic makes him akin to those Lawrence Puntel describes as hikers who follow their paths while maintaining that all of us, themselves included, are blind, and that there are no paths. 107. Contrary to this greedy sceptical approach, the claim here is that self-consciousness is not merely causally structured consciousness. What makes it apperceptive in the last instance is not to be found within the causal structure of non-conceptual awareness, or, for that matter, in the unconscious modular processes that condition it. Discursive apperceptive awareness involves a specific type of cognition. It operates via normative judgments that are both linguistically oriented and linguistically driven. These judgments supervene upon heuristic abilities, which in turn are caught up in and conceptually utilized and refined by them. The point is that normative judgments are not heuristics, nor do they essentially need to be dependent on some heuristic core, behavioral regularity, or even causal connection with the world in order to count as judgments. A glance at today's logic and theoretical computer science, if not the ever-suspect organon of philosophy, should set one straight with regard to the issue of mistaking judgment for the heuristic. In globally reducing sapience to the empirical facets of phenomenal consciousness and the modular processes that condition it, the greedy sceptic elides the distinctions between conceptual awareness and phenomenal awareness, judgments, and heuristics, the structure of discursive intentionality and the structure of proto-intentionality, the space of reasons and the space of causes. This greedy figure will always tell us that the overlap between the space of reasons and causes is too fuzzy to be considered as a criterion of sapience, but such a critique is predicated upon what the fuzziness actually is. Without a determination of the degree of fuzziness, the greedy skeptic merely resorts to the path of least resistance, propping up the fuzziness as an unintelligible principle, saying that the state of affairs is more complex than you think, without ever elaborating on what is meant by complexity in order to perpetually advance his uncritical view. The skeptic's global deflationary approach to discursive self-consciousness is a side effect of his inflationary account of empirical phenomenological consciousness, within which lies a colossal stack of muddled, dusty, and unchecked metaphysical assumptions. This illicit merger can be traced back to a principal theoretical lacuna in understanding the linguistic sociality of discursive apperceptive intelligence, how this linguistic sociality determines semantic content, and how the semantic contentfulness of apperceptive intentionality differs qualitatively from the proto-intentionality of the merely phenomenal consciousness whose description at both empirical and phenomenological levels it makes possible. The global reduction of discursive apperceptive awareness can ultimately be traced back to a misconception of what language really is, what it does, and how it does it. Linguistic interaction is the fabric of thought, rather than a means for its transmission, a mere medium of communication. The emphasis on the essentially linguistic character of sapience is nothing new, of course. It is a familiar topic that is perhaps even deemed well-worn and antiquated in some philosophical circles. But what has been for the most part absent in pro-linguistic arguments is a concern with the fundamental interactive structure of language itself, not merely an interaction steeped in language, but an interaction which itself is language. This is a picture of language not as a symbolic totality with an ineffable essence, a medium of communication, a tool for labeling items in the world, or a system of social discourse in which language is the facilitator of mutual recognition, but as a sui generis framework of interaction as computation. 155. Furnished with different classes of complexity and the different cognitive abilities associated with them. It is in this sense that the reconstruction of apperceptive intelligence from heuristic intelligence becomes an inquiry into what is required in order for the sui generis interactive computational framework to be constructed, a process of construction that brings about an intelligence of a different type. But to embark on this journey, we must first begin the story of our hypothetical automaton as a preconceptual pre-apperceptive intelligence. Story I. The automaton is sentient of the environment, a heap of black accompanied by a low monotonous noise. Suddenly, a faint rustling noise perturbs the scene. A short while later, as the sound becomes louder, a mass of protruding fuzzy gray appears at the opposite end of the heap of black and moves toward it. As the mass of gray reaches the heap of black, it stops, makes contact with the heap of black, moves away, makes contact with it and then moves away, again and again. The perturbing sound has shifted to a shrill and high-pitched sound. Later, the mass of gray recedes from the heap of black. The sound becomes a rustling noise and continues for a while after the mass of gray completely disappears. All that is left on the scene is a rectangular heap of black accompanied by a low monotonous noise. Story 2, the automaton has just seen a reenactment of the monolith scene in 2001, A Space Odyssey. A featureless black monolith is erected in a landscape whose serenity is broken by the steps of an approaching monkey. Once the monkey finds the monolith, it starts examining it, screams, panics, runs away, and comes back to touch it again. The monkey continues this game for a while until it finally gets bored and goes away. The world of the automaton is uncannily analogous to the pre-linguistic world picture of an infant. The first narration is a rough analog icle. 156. Linguistic story about how the automaton registers the environment. The second, a non-analogical linguistic narration, essentially a story of and within language in which such registers are inferentially caught up. More specifically, the items in the second story are linguistic items that possess semantic features by virtue of the inferential roles they play in our collective linguistic practices, whereas the items in the first story are non-conceptual representations of items in the environment, i.e., registers at the level of internal variable states of the automaton's wiring structure which causally mediates between sensory inputs and behavioral outputs. The automaton is aware of the items in the environment, a heap of black, a rustling, but in the second story we are aware of the items as something, as a monolith, as the steps of an approaching monkey. We perceive or take things as such and such, whereas the non-conceptual content of the automaton's experience is neither seeing or hearing as, nor seeing or hearing that, but seeing and hearing of. What it sees of the black monolith is the color on the facing part of its surface and its shape on the facing side. Let's use the term seeing, to designate the seeing of. But what we see of the monolith is not merely the impoverished seeing, for what we see too of the object is its color through and its shape all around. We also see it as a black rectangular cuboid, a black monolith. Kant would describe the former as an image, qua function of the imagination, whereas the latter proceeds via the subsumption of this image, qua singular representation, under a concept through schemata which serve as universal procedures for constructing a model of that concept, monolith, out of multiple and associable, synchronically and diachronically synthesized perspectival aspects of an item in the world. We can think of seeing, of in the first story and seeing, as in the second story in terms of making a Lego model, say, a toy robot using Lego blocks of different shapes and colors. From a shifting perspectival point of view, the blocks with their various shapes and colors correspond to the diverse yet rudimentary images of our Lego model, the point-of-viewish intuitids, which are obtained as our automaton confronts the Lego blocks in such and such perspectival imagings. Example: this Lego block or heap of black is facing the automaton edgewise. Their role in our model. 157. Construction is particular and contingent. The shapes and colors of the blocks are the raw sense-given matter of the intuited items qua images. The pictorial motif of our Lego model building corresponds to the conceptual representation of these intuited items in acts of judgments, the intuitings. The function of the pictorial motif is to determine the colors and shapes of the blocks in such a way that it becomes possible to put them together so as to construct the specific Lego model in question. In other words, the pictorial motif encapsulates the function of the concept of a robot that determines images, the right blocks, as different aspects of only that object. It is only because the colors and shapes of these blocks hang together in the right way perspectively in space and time, synchronically and diachronically, that we are able to synthesize the pictorial motif of our Lego model building. And respectively, it is only because the blocks, the images, can be put together in the right way in accordance with a rule, i.e., the concept of a robot, that we are able to conceive them as associable and multiple aspects of one such and such robot. In seeing E, we are dealing with local variations and rudimentary point-of-viewish invariant aspects of particular items. Whereas in seeing 2, we have the function of productive imagination, by means of which categories or pure concepts of understanding general and universal invariances are applied to the intuited items, like blueprints or instructions necessary for the construction of a toy object. But in seeing 2 we are also capable of bringing and constructing images under specific concepts, example: this such and such toy robot. The combination of these abilities turns seeing 2 into a complex act of imagination and understanding. In more contemporary terms, seeing 2 involves object individuation and object simulation, general and specific forms of classification, and re-identification of local invariants across different contexts. Units of experience are perceptual takings or the class of ings as, example: grasping or conceiving as, not the class of ings of. Local variations, manifolds, of items, shape, color, etc., supplied by the latter, sensory and perspectival, class are not by themselves sufficient for object construction, since object, Gegenstand, individuation, classification, and recognition involve the construction of types of invariances which form a network of associations and implications. Such invariances cannot. 158. be obtained without a complex interplay between the sensory intuitions given in imagination and the pure concepts of understanding overseen by what Kant would call the faculty of judgment. 108 Categories are logical functions. It is only when they are brought into conformity with sensory intuition through schematism and synthetic a priori principles that they can become rules for generating perceptual takings, that is, rules for constructing something as an object of representations. Schemata can be said to be rules of construction pertaining to the process of providing a concept with its singular representation qua image, build, example triangularity, and a triangle. On the other hand, synthetic a priori principles can be understood as general rules of unity in the integration or synthesis of appearances. The Lego model building process, which is necessary for the transition from seeing J to seeing 2 as a whole, corresponds to Kant's threefold synthesis, namely, synthesis of apprehension in the intuition, synthesis of reproduction in the imagination, and synthesis of recognition in the concept. The synthesis of apprehension delineates the first constructive role of imagination in pulling together a synchronic manifold of sensations by antecedently taking up the sense impressions into its activity, apprehension. It introduces order into the confusion of simultaneous impressions by giving them temporal and spatial locations, and thus differentiating them. In doing so, the synthesis of apprehension brings about the condition of the intelligibility of impressions as distinct, spatio-temporally structured, impressions qua appearances available for further construction and structuring. The second synthesis, the synthesis of reproduction, signifies the second constructive role of imagination in combining and reproducing the sensory manifold diachronically, carrying over its earlier elements in order to construct a stable image qua singular representation of an item in the world. It establishes temporal associations between appearances that the synthesis of apprehension has located in space and time in a certain way, rudimentarily structured out of the undifferentiated homogeneity of simultaneous impressions. These two syntheses are the figurative part of the building process associated with imagination as a constructive simulating capacity whose function is to represent an object even without its presence in intuition 109 and which is unavailable to pure sensibility. They are, accordingly, what we might call figurative syntheses. The third synthesis, the synthesis of recognition, strictly designates the role of apperceptive consciousness in perception, that which must be added to pure imagination in order to make its function intellectual, since in itself the synthesis of imagination, although exercised a priori, is nevertheless always sensible, for it combines the manifold only as it appears in intuition 110. The synthesis of recognition requires both the act of recognizing a past representation as related to the present one and the act of recognizing past and present representations as belonging to one object via the function of a concept. The third synthesis then involves different a priori acts of cognition, erkenntnis, which produce full-blooded judgments. To avoid terminological confusion, it is best to provide brief definitions for these recurring elements of the Kantian vocabulary. Sensations are the immediate results of the mind being causally affected by objects. In other words, a sensation is the effect of an object on our representational capacities to the extent that we are affected by the sensible object or Gegenstand. Sensibility refers to the capacity or receptivity to acquire representations through being affected by objects qua particular or individual items. The ability to have thoughts of individual items is intuition. And that through which cognition relates to objects, individual items, through sensations is empirical intuition. The generic and indeterminate object of empirical intuition is an appearance. The matter of empirical intuitions is sensation, and its form is sensibility, which allows the manifold of appearances to be initially structured. Appearances are the elements that are picked up and built into singular representations of items in space and time qua intuitions. Finally, intuitions differ from sensations since they are types of cognition while sensations are not. The raw content of intuitions is what is intuited from sense-given materials, sense impressions of an item located in space and time. The form of intuitions is intuition as an act of intuiting, which is a singular act of conceptual representing. The syntheses essential for the transition from seeing to seeing to are dynamic acts of integration and need not to be thought in either purely top-down or purely bottom-up fashion, but rather in the mesoscopic or mid-level fashion introduced in the previous chapter in the context of big toy models. As briefly introduced in our discussion of Chu spaces and toy models, syntheses can instead be understood as matrices of interactions between the integrating organizing acts belonging to causal empirical and logical inferential domains and the various rules of integrative transition, moving from one level of unity to another, that must necessarily obtain between them in order to have anything like seeing as, hearing as, smelling as, i.e., conceptual awareness as knowledge or experiences endowed with non-private, epistemic status. These rules of integrative transition can indeed be defined as necessary computations typed or untyped, statistical or logico-linguistic, context-sensitive or context-free, centralized or distributed, which can enter into interaction with one another asynchronously or synchronously. In this sense, transcendental logic, as that which supplies concepts with sensory intuition and applies classificatory concepts to intuitions, can be 162. Understood as a computational search space. As such, it is perhaps more fruitful to elaborate transcendental logic by way of information theory and computational complexity theory, where each level of necessary conditions for the possibility of having mind can be construed in terms of the increase in information processing abilities and the new types of computational problems, Turing completeness, NP completeness, and NP hardness, etc., that can be solved at that specific level. Moreover, this computational view of transcendental logic coincides with the paradigm of deep functional analysis presented in the first chapter, or what the late Hilary Putnam dubbed liberal functionalism, a functionalist view of the mind as a collection of world structuring abilities which require an anti-individualistic picture. A organism is only a system insofar as it is in real-time transactions with the environment. The functionalist view of such a system cannot be greedily reductionist, because its information processing abilities seek their own level of interpretation. Point 11. Equipping our automaton with objective in the sense of Gegenständlichkeit rather than objectitat figurative syntheses, then, would require the application of a mixture of mid-level models similar to the generative models utilized in the predictive processing, PP, paradigm. 112. Such models are based on prior probability and statistical estimates which function as representations employed to predict current and future sensory input as well as the source of such input. Source detection is possible insofar as the estimates are hierarchically organized in order to track features at different temporal and spatial scales, and this hierarchical distribution in turn enables estimates at different levels to be predictive of one another. These estimates, however, must be probabilistically constrained, otherwise predictions would be impossible for any sensory neural condition. Without constraints as the ground for predictions and likelihood estimates, our automaton or intelligent system would not be able to winnow the sensory neural possibilities and converge on a set of predictive hypotheses. Such probabilistic constraints are inbuilt inductive biases which are necessary for any form of predictive processing system and are defined in terms of probability priors. The hierarchical system of priors moving from more fundamental or abstract to less enables the development of advanced representational systems which not only effectively single out hypotheses from a set of possible hypotheses but also handle different levels or types of hypotheses in order to explain the data. This hierarchical architecture permits differentiation between basic representations of, for example, a round Lego block and a cubic one, since the prior probability that these two blocks are co-localized in space and time is negligibly small. 113. Deep entrenchment of more fundamental priors or constraints can analyze and guide upper-level estimates and less abstract priors. Such priors upon priors are called hyperpriors. Andy Clark and Link Swanson have identified hyperpriors with the brute constraints imposed by space and time, explicitly as Kantian forms of intuition and appearance. These constraints can range from hard restrictions on spatio-temporal bilocalization or co-localization of sensible items to limitations of bodily actions, example either turning left or right. In Swanson's words, Abstract internal knowledge of space and time. Spatial and temporal hyperpriors are thought to narrow and restrict large swaths of possible hypothesis spaces, thereby aiding the formation of decisive perceptual predictions regarding the external objects causing incoming stimuli. This narrowing of possible hypotheses is critical to the entire probabilistic inference process. Without it, the required Bayesian computations become intractable. Spatial and temporal hyperpriors can thus be usefully conceived of as necessary conditions on the possibility of probabilistic perceptions of external objects. Kant's proposal that space and time are features of cognition that form, constrain and restrict possible perceptions of outer objects is echoed in explanations of the role of hyperpriors in PP accounts of perception. Without spatial and temporal hyperpriors, the objects of perception that putatively result from PP would be impossible. 114. In predictive processing systems, incoming sensory inputs are not passively received but are contrasted with the existing representational repertoire, i.e., they inform representational or image updates. It is precisely this update function rather than sensory input that results in prediction error minimization in such a way that updates adhere to the norms of Bayesian inference. Moreover, the applications of such predictive models can be made more exact with the help of adequate formalizations provided by category theory and topos theory, whose geometric and topological richness have been studied in relation to neural modeling, constructive memory, Kantian schematism, and figurative syntheses. See the works of Eresman, Gomez Ramirez, and Healy. 115. For instance, the commutative diagrams used to define the concept of colimit can provide a formalized map of the neural paths, compositions, transformations, and categories necessary for the construction of complex image models out of simpler ones. For example, we can think of a colimit diagram for the process of construction of an obelisk as an image model. Mental object embodied in the neural organization using simpler mental images, a square and an oblong rectangle, which are at different, lower, levels of the neural organization. A colimit then can be said to be a category theoretical diagram for the construction compression of complex mental images from simpler ones using commutative diagrams and universal properties. 116. Details and associations between the square and the oblong rectangle are compressed or streamlined into the image of a cuboid. A colimit diagram captures how the neural category neur, which is composed of neurons and the synaptic paths represented by morphisms between them at the microscopic levels, can be constructively raised up to the macroscopic level of the mental objects category merit, which is composed of mental images or image models and the morphisms or structural relationships between them. Then N1 levels signify different scales or levels of organization which lie between the microscopic category neur and the macroscopic category merit, moving from the fine-grained scale of local networks of neurons to the coarse-grained scale of neural events, as for example recordable by functional MRI. In this respect, in the context of the neural organization and mental images, the colimit can be understood as a map from a commutative diagram in the category merit to a commutative diagram in the category neur via the functor f, merit-**neur, while the hierarchy of merit levels of image models shifting from simple to complex can be represented via natural transformations r, n between given functors, t, \phi equals *f2, 6f2 equals *3, -117 here, t \n f2 map merit to two local networks of afferent neurons in the category neur which are responsible for processing two distinct sensory inputs, for example, one visual and the other haptic. Fs, on the other hand, maps from merit to a local network of neurons which is a sensor fusion of the aforementioned afferent neurons. In this configuration, other objects can be introduced to the neural category, such as motor neurons associated with the agent's effectors. A seemingly simple but in fact highly complicated image model such as the abstract image of a continuous line as the root of the concept of line can be modeled in this manner via a colimit diagram in which natural transformations obtain between functors from merit to neur whose objects are both local sensory neurons, visual signals from the ocular system, sense of gravity, balance, and spatial orientation from the vestibular system, etc., and local networks of motor neurons connected with Bodily actions, specifically those involving embodied spatial gestures of direction and orientation, example the saccade of the eyes and muscular movements. The fusion between sensors and effectors, afferent and efferent neurons, would then account for the complex image of a continuous line as rooted in a perceptual invariant generated by the stabilization and integration of the senses of inertial movement, direction, orientation, and certain locomotory actions. 118. Modeling a sensor-effector system, a robot capable of forming a stable perceptual invariance. As with all models and paradigms, the theoretical scope and practical applications of the above models should be treated with modesty and critical vigilance. While such models can be regarded as models of choice with a certain theoretical strength and range of application within the big tinker-toy model of AGI or of our own representational systems, they should not by any means be viewed as complete or global and comprehensive. There are in fact significant flaws in both their theoretical underpinnings and their range of application, whether in the context of artificial intelligence or cognitive science. The strong modular constructivism implied by the category theoretical formalization of neural organization, particularly the co-limit diagrams, does not leave any room for modeling the necessary pruning mechanisms which are responsible for repairing or destroying unneeded or deleterious neural patterns. As a result, the complex microscopic view of the brain turns into yet another variation of the well-worn metaphor of the brain as a receptacle of whatever is thrown into it without ever having a chance of filtering out or destroying constructed and entrenched patterns in the neural structure. When the role of neural unlearning is removed from the equation or downplayed, the relevance of neural learning to concept learning progressively diminishes. The rise of category theoretical models in the study of complex systems, particularly in neural architecture, calls for the development of a pertinent critique of both the conceptual underpinning and the range of application of category theory or any other mathematical formalization. While the generality of category theory makes it a powerful tool for the study of mathematical structures, it is well suited neither for the study of all types of mathematical structures nor for the modeling of all forms of physical systems and phenomena. The question of structure as that which addresses the relation of the mind to the world is chiefly the question of constructing theories within which different models can be compared and tested. Context-independent appraisal and application of Mathematica. Models, or any model for that matter, is an absurdity. The context is firstly given by the theoretical system within which the model operates, and then by the analysis of the correspondence between, on the one hand, the type and scale of structures a theory aims to investigate, and, on the other, the specific mathematical formalism indexed by the model for the study of the target structure. Absent this analysis, not only will the application of the mathematical model be too arbitrary, it will also result in a complete distortion of the phenomenon under study by the misapplication of the mathematical structure presupposed in the model. Here category theoretical models of neural structures are no exception. Category theory's strong reliance on commutativity as a mathematical structural constraint, or what Ion Bianu has described as the stricture specific to abelian theories, categories, or ontologies, makes category theoretical models ill-suited for application to a broad range of complex physical systems and phenomena at scales where the distinction between objects and processes begins to fade away. 119 Physical systems or behaviors involving symmetry breaking, genuine asynchronous processing, and irreversible dynamics cannot be adequately encoded by models enmeshed in a mathematical framework that places strong strictures on mathematical structures such as commutativity or internal symmetry. 120 For example, myriad forms of neural tasks involve true asynchronous processing of events or states which are spatio-temporally separated and have no symmetry between events and states. It is far from obvious that category theoretical models can sufficiently encode such aspects of neural organization. In his work Simulation and Similarity 121, Michael Weisberg offers a detailed specification of models as structuring systems. Regardless of whether the model is descriptive, explanatory, or predictive, or whether it is concrete, example and ori, mathematical, logical, or computational, the model is comprised of a structure formulated in a specific theoretical framework. The structure has two poles, the model description and the model construals. The description is a set of formulas or equations which describe the range of model applications based on its structure. In short, the model description provides us with information regarding what the model is, its structure, and how it can be applied, its dynamic. But the description is not the structuring kernel of the model itself, since the structure contains a diverse range of information regarding the scope, assignment, and fidelity criteria, i.e., constraints which specify the representational, dynamic and resolution or scale-sensitive specifications of the model, which are implicitly encapsulated in the model description. All such information has not only theoretical assumptions, but also meta-theoretical, metalogical, metamathematical assumptions which should be carefully analyzed. Therefore, consideration of this often ignored dimension of modeling meta-theoretical assumptions is absolutely indispensable, not only for the correct application of a model to the appropriate type of data and the scale at which a specific phenomenon is studied, but also for the appropriate choice of the mathematical, or logical and computational, framework and the type of constraints imposed by that framework on the mathematical structures that are supposed to encode a physical phenomenon. Absent this analysis, we can never be sure whether our empirical models of a target system such as the brain distort the data, whether they are suboptimal models for the study of the target system or are being applied to the wrong structural level of the phenomenon or system in question. As such, the scope and application of the predictive processing paradigm cannot be overextended. Clark's claim that the predictive processing 171 paradigm not only accounts for rudimentary representational systems but also the scientific method is based on a crude view of scientific theories. 122 No predictive inductive method or model can by itself represent scientific theories, since the construction of scientific theories requires both a rank plurality of methods and a complex semantic dimension without which no inductive method can converge on a single hypothesis or a set of hypotheses that can be said to be true. 123 Without the semantic dimension of theories, the predictive processing paradigm of scientific theory construction is no more than an extension of our inductive biases. A scientific theory that is solely based on a form of predictive inductive processing can only offer a version of objective reality that is in full conformity with the local and contingently constituted inductive biases of the subject and its deep-seated intuitions. But the fact that science progressively breaks itself from our common intuitions should be counted as evidence that scientific theories cannot be construed as an overblown version of the predictive brain. Finally, inductive biases and hyperpriors, particularly as the constraints of space and time, should be understood as constraints on the order of appearances, that is to say, they are features of the experiencing subject or the conscious organism. Identifying them as features of objective reality is an unwarranted metaphysical commitment whose implicit assumption is the existence of a given or pre-established harmony or one-to-one correspondence between reality and the perceptual mechanisms of the brain. The defender of such a view would have to explain a number of glaring problems with it, including explaining why modern physics continues to shatter our most cherished inductively enabled intuitions regarding the universe, or why it took modern Homo sapiens almost 200,000 years to develop Euclidean geometry, and after that almost 2,000 years to discover non-Euclidean geometry. If the structure and dynamics of our scientific theories and natural languages could easily be analyzed or explained away in terms of inductive biases, then how could we even recognize or describe such inbuilt biases? It would mean we can 172 only resort to our inbuilt inductive biases to justify or explain inductive biases, which is viciously circular, a petitio principii. A more modest claim would be that inbuilt inductive biases are enabling constraints which have become entrenched through the course of natural evolution. Strictly speaking, inductive biases are local and contingent features of the conscious organism. Some may even be purely psychological features. These inbuilt inductive biases have enabled the development of otherwise more complex representational systems which are not merely inductive, probabilistic, or statistical. In this sense, the enabling role of inductive biases does not mean that they have constituted or play a central role in our theoretical activities. In other words, enablement neither means constitution nor calls for continued reliance on the enabling conditions. Yet even this modest claim should be treated with caution. Following the previous discussions regarding the critique of the transcendental structure, inbuilt inductive biases should be taken as features of the transcendental structure of the experiencing subject and, as such, should be challenged and progressively suspended in a Hegelian manner. First, we ought to distinguish psychological and non-psychological features, then attempt to model variations of non-psychological features which are not only alternatives to our own, but also have a more expansive traction on objective reality insofar as they enlarge the field of experience and therefore detect features of objective reality which our experience either distorts or cannot come to grips with. This means that, even if we admit that inbuilt inductive biases such as the enabling spatio-temporal constraints can be both psychological features and non-psychological features specific to the local and contingently constituted subject of experience, we can never be sure of the extent to which our particular experience distorts objective reality. Here, by objective reality, I also have in mind the objective descriptions of the brain qua representational system. Even when we strive to be attentive to the distinction between the particular characteristics and features of our experience and the characteristics of objective reality, we might indeed smuggle in bits of the former to the latter. This is a topic that we shall explore in depth in the excursus on Boltzmann and time in Chapter 4. To conclude, short of a theoretical and practical critique of the transcendental structures, the necessary link between the intelligible and intelligence cannot be renewed. The intelligible remains within the confines of what intelligence perceives to be an objective description of reality but is in fact a psychological representation, or an account which misrepresents the transcendentally ideal features of experience, or the local characteristics of the subject, as global and necessary characteristics of reality. Consequently, our objective description of ourselves in the world becomes yet another manifest self-portrait, and our speculations about a future artificial general intelligence invariably reiterate, like the portrait of Dorian Gray, ever more distorted pictures of ourselves. Having summarily examined the experience of the discursive apperceptive intelligence of the items in the world of Story 2, the syntheses it requires, and the candidate models for its figurative syntheses, we can now return to the first story, that of the automaton's non-conceptual encounter with the same items. In Story 1, the encounter of the automaton with an item in the environment is an analogue of an Aristotelian this such, to tv this something or other, namely, the impression of an object as a materiate individual substance. The automatons this suches, however, are best linguistically expressed by the application of dummy quantifiers that designate form, this much of, a quantum of, a heap of, and mass terms that designate matter, stuff, blob, to a current sensible properties, a shaped and colored facing side of the object, as in a heap of black, a protruding mass of fuzzy gray. In more straightforward terms, the automaton sees an expanse of gray as an object rather than as an object whose surface is gray. For the automaton, gray and black are not categorial kinds of experience or manners of experiencing, an object looking grayly or blackly, but the objects of its de facto experience tout court. The automaton is conscious of a heap of black as the object of its awareness, although at this time the possessive pronoun its is not yet part of the automaton's thoroughly non-conceptual awareness, i.e., the automaton is not yet able to ascribe this awareness to itself as its own. This is another difference between the first and the second story. What is not given in the world of the as yet thoroughly non-conceptual awareness of the automaton is precisely the categorial structure. At this stage, trafficking this categorial structure into the story about the automaton's analogically posited experience or awareness of items in the world would be precisely a function of what Sellers calls the myth of the given, the idea that the categorial structure of the world, if it has a categorial structure, imposes itself on the mind as a seal imposes an image on melted wax. 124 The automaton's sensing is acategorial, since categoriality belongs to the domain of the conceptual in which sensing is caught up. To ascribe categorial structure of any kind to the mere sensing of the automaton would be to relapse into aseptical empiricism, for which the intelligibility of what is sensed is given. But also, by analogically developing the sensing automaton into a thinking automaton, we avoid the dogmatic rationalism for which the relation between thinking and being is given not in the world but in the deductive rules of reason. In order to attempt to faithfully represent the logico-phenomenological form of the automaton's way of experiencing and, correspondingly, the features relevant to the automaton's mode of awareness, in a fashion that it is consistently and from the beginning identified with the automaton's modes of representation 125, we therefore have not only to avoid using gray and black as adjectives, a gray item, or as adverbs, an item that is experienced grayly, but also the kind of mass terms, such as rock, water, flesh, that smuggle in a categorical commitment to causal powers and propensities constitutive of the nature of such stuffs. We should instead use phenomenological this such as that have a logical form appropriate to the automaton's mode of awareness and somehow convey the suspension of categorical commitments, particularly those pertaining to the causal propensities of items in the environment. This is the reason behind the peculiar language of the first story, wherein the protruding fuzzy gray as a whole conveys some stuff that plays the analogical functional role of a countable noun, monkey, relevant to the general form of the automaton's non-conceptual awareness seeing 15 hearing carrot. But in its stuffiness, the protruding fuzzy gray is also distant from ordinary mass terms such as fur or protoplasm, use of which would imply the automaton's categorical commitment to the nature, causal powers and propensities, of such stuffs. And finally, to demarcate the individuated form of such stuffs, we can use mock-up quantity specifying terms that are functionally analogous to but removed from the measurement specifications of the terms we ordinarily use to quantify mass terms, such as a bucket of water, a piece of meat, etc. In this fashion, a heap of black is really this much expanse of black stuff, individuating form and matter. On top of these distinctions between the first and second stories, there is another less noticeable difference, the inferential connections between sense impressions from different sensory modalities, visual and auditory. In the second story, these inferential connections are relayed by implicit genitives that associate an impression specific to one sensory modality with another impression specific to a different sensory modality, the sound, steps, an approaching monkey, visualized, the screams of an excited monkey, etc. The first story, on the other hand, does not have such explicit associations between sense impressions of different modalities. It only contains rudimentary protocol-like transitions or transformation rules rather than proper inferential or objective conceptual rules of transition, e.g. mass of fuzzy gray, contact with the heap of black, screeching noise from the direction of mass of fuzzy gray. But not excited monkey touching the monolith v monkey screams. We cannot assume that, for the automaton, the shrieking sound is associated with the mass of protruding fuzzy gray as opposed to the heap of black or, for that matter, another item in the environment, or that it says anything about any such association. At all. 126 The goal of this comparative excursion was to highlight the features implicit in the automaton's non-conceptual encounter with the world, by highlighting its striking differences from the awareness peculiar to discursive apperceptive intelligence. Story 2. Now that we have a better idea what features and abilities the automaton is lacking, it is easier to figure out what must be added to the automaton in order for it to have categorially and inferentially structured experience and to bring its inchoate encounter with the world under the power of judgment. However, despite these profound differences between stories 1 and 2 as two distinct types of narratives, there is also a connection between them. The experiential content of the automaton's fully non-conceptual awareness still exhibits a non-categorial orderly structure that the inferential relationships among the concepts of the second story reflect and illustrate. Not only can this rudimentary orderliness be instantiated without language, it is a structuring that constitutes the minimum condition for the possibility of discursive apperceptive intelligence. But what is this minimum and necessary orderliness? It is the perspectival orderliness of space and time as forms of intuition, an encounter with the world from a non-conceptual point of view. In Story 1, The automaton is aware of the presence of an expanse of gray stuff, it is aware of it in analogical terms as approaching or receding. It is also aware of an expanse of black stuff. But it is not just aware of the gray stuff approaching or receding, it is in fact non-conceptually aware of its moving toward or away from the expanse of black stuff, and similarly stopping in front or moving behind the black stuff, disappearing and appearing. In a nutshell, the automaton has a sense of movement, and with that, a rudimentary sense of space and of the presence and perspectival spatial relations between items in space. This is because the automaton is situated in space as a privileged endocentric frame of reference. But we ought to be cautious here. The automaton has no concept of these spatial relations, it is not aware of the conceptual contrast between something that simply disappears, goes behind something else, and something that ceases to exist, appearances and reality. Nor does it possess a I-F concept. Nevertheless, the wired and programmed, structural and behavioral, system of the automaton can exhibit a spatial orderliness in its encounter with items in the environment that are linguistic terms such as approaching, receding from, moving in front of and moving behind, as opposed to ceasing to exist, inferentially instantiate and articulate. This rudimentary structured spatial encounter with the world can of course be detailed in terms of the complexity of the nervous system, but it also has a necessary form not in the sense that it could not be otherwise, but in the sense that it is applied to all of the automaton's encounters with particular items in the world. 178. Coming back to the predator-prey example, both predator and prey behave in a way that exhibits a spatial orderliness in their goal-oriented activities, chasing and escaping. As the prey moves away, the predator follows its movement and orientation in space by means of saccadici movement, one of the fastest and most ancient predatory gestures before orienting itself in space to chase the object of its hunt. When the prey hides behind a rock, it does not give up as if the prey had ceased to exist, but instead follows the shortest path to catch the prey behind the visual obstacle. The predator has a sense of space only by virtue of its capacity to differentiate itself from its surroundings in order to effectively engage in its goal-oriented activity, catching the prey, a sense that is profoundly different from our own, wherein items stand in inferentially articulated spatial and topological relations to one another. It is this functional differentiation from the surrounding space that serves as an egocentric, endocentric, frame of reference for the predator, a perspectively situated position in space. But the predator neither reflects on itself as being differentiated from the surrounding space, nor is it aware of having a privileged position within it, a perspectival stance. It just has a perspectival position in space by virtue of its structural capacity to behaviorally differentiate itself so as to successfully engage in its goal-oriented activity, and, by virtue of this, it occupies, without conceptually representing to itself, a frame of reference. It is this structurally and behaviorally posited endocentric frame of reference that permits the predator to entertain not only spatial relations between items and itself, but also a limited range of spatial relations between one item and another, that is, to treat not only itself, but also items in the environment, as frames of reference. This endocentric frame of reference, itself an index of the predator's situatedness in space and its spatial perspectival encounter with the world, is what enables the predator to have a constrained allocentric view of items as situated in space, and thus as spatially related to one another. The origin of the nervous system, as René Thom and Alain Berthez articulate, can be traced back to the solving of a fundamental problem for the self-preservation and successful execution of the organism's teleological. 179. Activities 127. How can an organism differentiate itself from its food and from the predator? Absent a contrasting index for differentiating itself from its food, the organism risks autophagy, and without any robust differentiating cue, the organism can neither successfully secure its food nor evade predators. To solve this problem, the organism must first differentiate itself from space via successful responsiveness to various forms of stimuli, electrochemical signal, physical pressure, light, etc., but in order for it to effectively secure its food and elude predators, Such parochial stimulus-driven contrast is not enough. The organism must form a mobile perspectival frame of reference to respond appropriately to changes in the parameters of spatial relationships between itself and items in its environment. This is one of the oldest roles of the nervous system as a basic organ of alienation. 128 To mobilize and develop or alienation, minimal contrast with the environment through mere responsiveness to stimuli, into an alienation, a designated and designating discontinuity in space simulated by the nervous system as a self-model. 129 That enables the organism to structure its surrounding space and, in doing so, to derive an awareness structuring orderliness from the rudimentary spatial relationships between items situated in that space. This enabling alienation is the capacity for spatial differentiation between items in the environment through the mobilization of the organism's successful self-differentiation from its surroundings, a perspectival pure positional awareness of items in relation to one another. 130 In order for the automaton to have this perspectival pure positional awareness, it must have not only a sufficient structure for reliable differential responsiveness, but also a behavioral goal-oriented architecture. And that is exactly what our hypothetical agent has been supplied with. We can now say that the world of the automaton contains a privileged position, a position that we conceptualize and inferentially model on our spatial concepts but which it occupies and upon which it acts. The world of the automaton, then, contains a privileged and structure-conferring position only in the sense that its awareness the world is an orderly and coherent spatially perspectival awareness of items. But what is more interesting is that this spatially perspectival awareness can be laid out precisely, albeit still analogically, in terms of our subjective spatial awareness too of items as moving toward and moving away, coming in front of and going behind. In other words, the automaton has a coherent spatial awareness of the items without necessarily possessing the conceptual resources to be able to tell the difference between appearances and reality, between, for example, an object whose shape and size remains constant as it retreats and an object that appears to be shrinking or morphing into something else as it moves away, as in the predator-prey example, where the sentient predator does not need the inferential relations between spatial concepts in order not to mistake a prey that moves behind a rock for an object that has now ceased to exist simply because the rock has occluded its shape and color. Similarly, when the prey runs away, the predator's spatial awareness need not be armed with perspectival concepts in order not to take the running prey as an object that seemingly shrinks or morphs into something else. The predator continues the chase and captures the prey with pinpoint accuracy. This is all to say that, even though our automaton is still a thoroughly non-conceptual, non-apperceptive intelligence, its spatial perspectival awareness of items is precisely already a spatial awareness of items as moving behind, moving away, and not off items ceasing to exist or shrinking and morphing into something else. For this spatial perspectival awareness of the items as to be instantiated, the automaton does not need the conceptual distinction between what merely seems to be the case from an occupied pure perspective and what veridically appears to be the case, mastery of language, inferential relationships between perspectival concepts, or even self-awareness. All it needs is to have, i.e., to occupy, a privileged point of view in space by virtue of a sufficient structure coupled with a junctional system. 181. Of goal-oriented activities that allow it to adopt one or multiple awareness structuring perspectival frame, of reference in the world. Looking at the ordinary spatial prepositions of our natural languages, especially those concerning localization, physical accessibility, and contact between objects, from, toward, behind, on, under, we can see them as exhibiting what Claude Van Lewis calls a form of naive physics of space, differing from scientific physics as radically as natural languages differ from formal ones. 131 Although the automaton's naive physics of space is limited to simple spatial relationships that, for example, involve access to the field of sensory differentiation, gray stuff approaching or retreating, non-prepositional contact between objects, the chunk of red touches the mass of black, but not a red thick book on the table, and simple orientations, screechy noise from the mass of fuzzy gray, but not the scream of a monkey. More hybrid spatial relations and propositions of this naive physics of space, such as bearer-burden relations, container-contained relations, and complex localization, like the uses of at or near/far distinctions, are not yet on the menu for our automaton. Serving as an armature for our higher-order awareness structuring spatial concepts, at its core this naive physics is built on a necessary family of perspectival spatial representations which can be instantiated without inferential relationships obtained from spatial concepts. This family of spatial representations demarcates a non-categorial yet orderly spatial perspectival encounter with the world that is a necessary condition of a conceptual and thus categorially structured encounter with the world, and hence for an automaton with a full-blooded apperceptive awareness, awareness too as. In displaying exactly this spatial perspectival awareness, our hypothetical automaton has thus fulfilled the first necessary condition of possibility for the realization of general intelligence. Now that the first minimum condition necessary for the realization of discursive apperceptive intelligence has been outlined, we can move on to the second minimum condition, a temporal perspectival awareness, that is, a structured and structuring temporal encounter with the world. For the automaton this means having the ability to locate itself in time, and thereby achieving a time consciousness of both the world history and its own history. Here self-locating in time means a rudimentary capacity to be aware of successive sensory affections produced by objects in its environment and to actively but non-conceptually respond to such affections. Having this rudimentary capacity is not as simple as it may seem. On one level, it requires a perspectival spatial orderliness of the kind we have been looking at. But on a different level, which, as we shall see, is even more crucial, it requires a temporal orderliness that relies on more fundamental successively interrelated capacities. 1. The capacity to synthesize compresent sensations, the simultaneity of the manifold of senses. The role of synthesis here is an operation of combining, binding, and gluing partial maps of objects that come as compresent sensations, registered local invariances of shapes, colors, smells, etc., into spatio-temporal global maps of objects. 2. The capacity to synthesize the simultaneous states of objects into sequences of occurrences. Think of this synthesis as what is required for the automaton to capture the movement of a moving car. 3. The capacity to be aware of representations of objects and sequences of occurrences as representations and sequences. In a Kantian sense, this is tantamount to having the capacity to report representations of items and occurrences in the world to the mind. At this level, the capacity to report being affected qua mind state being aware of being thus, successively, affected does not by any means imply a form of knowledge. In other words, for the automaton, having this capacity does not imply. 183. A conceptual awareness of the mind state, this is something we should reserve only for an apperceptive agency. This awareness is merely an attentional mobilization of the global workspace that was introduced earlier. And similarly, the conceptual knowledge of the mind state should not be conflated with this rudimentary awareness of mind states, which is necessary but not sufficient for the realization of a conceptual awareness. I said above that these capacities are successively interrelated because they are built on top of one another. 2. Shares the components of 1, and 3, shares the components of both 1 and 2. But the reason they should be treated as distinct capacities is that each successive capacity adds a new component that is not available in the previous one. Our particular focus in this section will be on capacity 3. What needs to be added to a sequence of representations in order for the automaton to be aware of the sequence as a sequence of representations, to have a capacity by virtue of which it can be aware of being successively affected so as to be able to respond to the manner in which it is so affected? Alongside the spatial elements in Story 1, we also find temporal elements not only in explicit terms such as a short while later, but also, more predominantly, as implicit elements of motions. Our task now is to examine the automaton's temporal perspectival awareness, the structure of this awareness, and the consequences of its having this minimal temporal orderliness. But in order to move forward we have to bring into play a necessary structural component of the automaton that we have thus far not fully utilized, namely its constructive memory. Let us call the registers of items that the automaton encounters in its environment events which occasion alterations in the internal states of the automaton and which are manifested at the level of the global workspace impressions. Now that the memory system is fully in place, the automaton is able to retain these impressions and access them. But, as discussed above, the retrieval of a retained impression is tantamount to the reconstruction of that impression. In other words, each time a retained impression is accessed, it is not merely called up but rather reconstructed, and each of these reconstructions is then added to the memory, i.e., becomes part of the situation that guides the further construction of memories. According to this memory schema, the automaton's impression of an item in the environment, for example the monkey as a mass of fuzzy gray, toed foot, can then take two general forms: a retained impression, formed by the presence of the mass of fuzzy gray, and a reproduced version of the retained impression of the mass of fuzzy gray, reconstructed in the absence of the actual item in the environment. Both forms mark the presence of the non-conceptual content of the THIRD impression, but in one form this presence implies synchronicity with the actual item, while in the other form it implies diachronicity. Analogically approximating the non-conceptual and tenseless awareness of the automaton, the impression of the object, I0, in its retained and reproduced forms can be represented in the following manner. I0b. Impression, which denotes the retained impression in which the presence of the non-conceptual content is derived synchronously from the presence of the actual item. I0b2, reproduction, which denotes the presence of the non-conceptual content reproduced in the absence of the actual item, which is to say, derived and reconstructed diachronically from the retained impression I0b. What is common to both forms is the presence of the content of this such represented by the tenseless verb be. It is tempting to interpret the I and 2 in Bex and B2 as indices of times, and hence to conclude that B2 is the past tense of Bej, the automaton saw, in so doing attributing to the automaton a temporal awareness, or even tensed thought. But at this 185 point, I and 2 merely represent two distinct types of impression content, one that occurs in the presence of the actual item and another that occurs in its absence. These two general types signify respectively the impression, B, and the reproduction of that impression bearing the mark of both being retained and being reconstructed, B2. More succinctly, Bej and B2 present I0 respectively as the content of an impression and as the content of a reproduction. From our perspective, the automatons this suchi and this such too clearly signify present and past tenses of impressions of the items. The automaton sees a monkey, the automaton saw a monkey. But we should avoid ventriloquizing the machine, and instead equip it in such a way that it will become capable of drawing such a conclusion all by itself. In other words, we should allow our toy automaton to have a genuine temporal perspectival awareness that legitimately admits our analogical observations regarding what it is aware of. And even then this temporal awareness is not by any means close to any form of time consciousness, even though it may be the incipient germ of such consciousness. The automaton, at this stage, is aware of this such oi and this such too, but it is not aware too of them as present and past. Nor in fact is it aware of them as temporally related. In order for the automaton to have a pure situational temporal awareness, it must first be able to temporally relate these impressions to one another. This temporal relation is already available at the level of the automaton's structure, in the shape of the causal ordering of its registers, and therefore as a sequence of alterations in the internal states of the automaton's wiring. Hypothetically speaking, and following Rosenberg's version of this thought experiment 132, if we could attach a monitor to the automaton and treat it as a computer with a visual display unit, we might see its visual registers displayed in a certain hue with a high degree of saturation. For the purposes of this example, we can think of the actual item in the environment as a key being pressed on the keyboard attached to this computer, and the saturated hue as its corresponding register. Moreover, these registers do not disappear from the screen, since they are stored somewhere in the automaton's memory. Now, as more keystrokes are made, something happens on the monitor. As new saturated registers appear on the monitor, the saturation of the stored registers decreases. The high saturated range of the hue corresponds to impressions synchronous with the presence of an item in the environment, i.e., registers that appear on the monitor as the keystrokes are being made, while the low saturated range corresponds to reproductions, i.e., registers of the keystrokes that have previously been made, and which are now retained in the memory. What is important to note in this example is that the difference in saturation is a difference made by causal correspondences or mappings between displayed registers and keystrokes qua independently existing items in the environment, and that these causal correspondences stand in de facto temporal relationships to one another. But the automaton is not aware of this temporal ordering of causal correspondences, keystrokes made before and keystrokes made after, registered as stored and registered as being displayed, nor can it infer from the TV in its head the monitor displaying registers in various degrees of saturation any temporal relationship. It is we, not the automaton, who infer a temporal order from the changes in the saturation in correspondence with the sequences of keystrokes. But could we say that, if we sufficiently train the automaton via the application of statistical inference, then the automaton will eventually learn to recognize the ordering or sequence of impressions, and thus legitimize our attribution of temporal awareness to it? Not at all. Temporal awareness precisely cannot be reduced to such a trained response. The representation of a sequence, or ordering, is not the same as a sequence of representations. The ability to differentiate a sequence of representations does not amount to the ability to represent a sequence. In the same way, a sequence of awarenesses of items in the world does not bring about an awareness of a sequence qua temporal ordering. Devising a trick to achieve the former does not generate the latter capacity. Indeed, this is part of Kant's attack on Hume's septical reductionist system, specifically his separability principle, the idea that everything that is different is distinguishable, and everything that is distinguishable 1. may be separated. 133 According to Hume's separability principle, awareness of a complex as a complex is possible if and only if its components are distinguishable. The immediate corollary of the separability principle is an integration principle, the idea that the impression of a complex is the same as a complex of impressions, or that representation of a series is a series of representations, the awareness of a sequence of, is a sequence of awarenesses of, and so on. But as Kant shows, not only does the schema lead to conundrums and confusions, it also undermines any serious attempt to distinguish the impression as an act from its object and content, awarenesses o/something from awareness of something-s, and ultimately empirical awareness from discursive conceptual consciousness. Accordingly, at this stage, the automaton neither has a temporal awareness, nor can it acquire an impression of a succession by being trained to learn a succession of impressions. All we are allowed to attribute to the automaton is a collection of awarenesses furnished with an orderly structure, a linear gradation or continuum which can, in analogy with our conceptual resources, legitimately be expressed as times. Within this orderly structure, the impressions of the automaton merely correspond to, but are not instantiated as, the order of before and after like ranges of saturation in correspondence with keystrokes, the order of impressions and the order of reproductions. The automaton is, so to speak, only in possession of causally ordered analogues of before and after. Again, it is tempting to interpret this before and after, expressed by times t and t, as tensed verbs, by saying that if va bex t I0 bb21 where tt, or I0 underscore bb2 before I0 underscore abex, then the before-after relationship between t and t means that v precedes t, and therefore the automaton is aware of I0 underscore 2b2t as what preceded tqjbt, as if tensed verbs were inherent to the function of memory. And therefore to conclude that, by virtue of having analogues of tensed verbs, the automaton must have a temporal apperception of its impraised scions and reproductions. But the whole point is that, As argued above, this causally originated before-after ordering of awarenesses is not sufficient for the realization of a temporal awareness, i.e., a tensed awareness such an ordering. Only tense can count as the genuine temporal aspect of awareness. This causally originated ordering is not sufficient. What the automaton needs in order to move from this causally originated order of before and after, be and be to tenses is and was, is a way of locating itself in time by having a mobile frame of reference with regard to time. In short, the automaton needs to have a perspective on time corresponding to its ordered and ordering point of view in space. Only through this perspective in time is it possible for the automaton to represent the world history by situating itself within the ever-changing temporal relations of the events composing that world history. And only an intelligence that possesses such a temporal perspective harbors the possibility of developing into a self-conscious intelligence capable of modifying itself by looking into its history. Thus, we can conclude that having a structured and structuring perspective on time is a minimum necessary condition required for the realization of the kind of general intelligence examined in the previous chapter. Of course, this rudimentary temporal awareness upon which the time-conscious experience of the subject is built is transcendentally ideal and logically phenomenological. It does not supply us with any factual answer with regard to the question what is time, whether we are seeking a metaphysically reified time as a thing or a non-reified formlessness that is the condition of any form. And as we shall see in the next section, the form of this time awareness, if approached without due caution, can wreak cognitive havoc. Indeed, becoming overly attached to this specific form can restrict both the scope of an agent's theoretical and practical cognitions and the enlargement of its possible field of experience, in the broadest possible sense of that term. Now, recall that having a point of view on space became possible once the automaton began to seek the items in the environment through an endocentric frame of reference that allowed it to access the changing spatial relationships between objects by opening up exocentric frames of reference, i.e., frames of reference outside of and not limited to the vantage point of the pure ego. Similarly, in order for the automaton to have a perspective on time, it also needs a temporal frame of reference that permits a distinction between the events of a world history and those of its own history, experience occasioning encounters with items existing independently of experience and the temporal succession of representings of these items in impressions and reproductions. In other words, the automaton must be able to differentiate the behaviors of items across time from its encounters with these items within one and the same time, thereby occupying that position in time wherein it can become aware of awarenesses which are only de facto its own. At this point, it would be a mistake to think that we can make the automaton become actually aware of its awarenesses of items as its own awarenesses or experiences. All the automaton can have at this point is a pure or de facto perspectival temporal point of view. But to have even a capacity for perspectival temporal experience, the automaton must be capable of representing the difference between an item that is being encountered now, and one that is not being encountered now but was encountered and is now being reproduced. This effectively means that the automaton, in addition to the capacity for representing items in the world, awarenesses of this such as, must be equipped with the capacity to represent its awareness of awarenesses of this such as awarenesses of this such as. This is exactly the mobile perspectival temporal frame of reference that parallels the automaton's perspectival spatial frame of reference and which the automaton de facto occupies without being conceptually aware of. 1. We must not confuse this capacity, however, with a fully fledged apperceptive awareness, taking experiences as someone's experience, since the automaton is not yet able to conceptually cohere and represent its awarenesses of awarenesses as being its own. What it needs in order to be able to construct and cohere its own awareness from its awarenesses of awarenesses is the faculty of concept, the faculty of judgment, or the faculty of rules. This is the next stage in our construction of a toy model general intelligence, which we will embark upon in Chapter 5. In the meantime we have to avoid thinking that the automaton can represent awarenesses of awarenesses as its own awarenesses. All we are allowed to ascribe to the automaton is the awareness of the existence of those awarenesses that are as a matter of fact its awarenesses. but the automaton is not yet capable of recognizing this fact as and within a subjective order. In short, although from our analogical point of view the automaton is beginning to display some rudiments of quasi-selfhood, precisely through the elaboration of a point of view, it is not yet able to recognize or mobilize its subjectivity. The key to having a perspectival temporal awareness is precisely the possession, as a differentiating temporal frame of reference, of a collection of awarenesses capable of meta-representing awarenesses of this such as awarenesses of this such as. In other words, the automaton needs to be equipped with a capacity for representations that are de facto meta-awarenesses awarenesses of items. In a nutshell, the automaton needs a quoting device, or meta-representing apparatus, for citing or pointing to its awarenesses. This means that, in addition to awarenesses of items, I0b, I0b2, the automaton must be equipped with a meta-representing tool for referring to or mentioning these awarenesses of items in terms of awarenesses of items. A helpful way of thinking about this is to take awarenesses of items and awarenesses of items as categories of awarenesses and then to use a category theoretical abstraction to think about how we can mention or quote awarenesses of items by way of awarenesses of items, using the language of equivalence classes, i.e., the equivalence of structure between objects and their respective modes of presentation. If we take the awarenesses of items as a category comprising objects and pointers, in the category theoretical sense, morphisms, in the philosophical sense, modes of presentation, then we would be able to present or point to this category by way of a whole new collection of pointers pointing to pointers. This new collection of pointers consists of what could be called a meta-awareness or an awareness of awareness. Moreover, we would be able to go even further by decomposing the new collection of pointers to yet another collection of pointers, making a concatenation of pointers that function as meta-representings, equivalence relations as opposed to equality relations, corresponding to a potentially infinitely nested structure of awarenesses of, what Hume called the self as a bundle of impressions, or what we might call Humean perceptions. It is perhaps necessary to mention that, at the level of these selves qua bundles of Humean perceptions, there is no time consciousness since time consciousness requires the apperceptive self or the principle of experiential unification. 134 There is only a de facto time order which can be said be to an analogical counterpart to our time consciousness, but at a much more basic level. In this fashion, what the automaton requires in order to have a perspectival temporal awareness is not only I0b and I0b2, as two modes of awareness of items qua impressions and reproductions, but also two types of awarenesses that is, impressions and reproductions of awarenesses, ABEX and AB2. Here, A stands for the object of these new modes of awareness. It functions as a quoting device, a metapointer or, more accurately, a meta-representing awareness. Within the meta-representational structure of these new modes of awareness, impression/BEX and reproduction/B2 of awarenesses, we can see an emerging nested structure. The meta-representing A can be represented either as impression, AB, 10B and I0B B2, or as reproduction, AB2, I0B2 and I0B2 B2. The construction of meta-awarenesses, awarenesses of awarenesses, via a meta-representing awareness can be continued even further, I0B B/by, I0B by B2, I0B2 B2, etc. Equipping the automaton with a global faculty of meta-representing has now provided the automaton with a representational armamentarium adequate for bringing about a potentially infinite complex of nested awarenesses. If we were to formulate meta-awarenesses in a category theoretical fashion, the definition of a meta-awareness, awareness of awarenesses, would be an object of a category J, awarenesses of items, which is determined by the network of its relationships, up to unique isomorphism, 135 with all the other objects in J star. This definition can be extended even further. A meta-awareness is a collection of transformations or mappings between one awareness X, example an impression, and another awareness Y of the same item, example a reproduction, which are in one-to-one correspondence with the transformations that map the object Y and its network of relationships to X and its network of relationships. Essentially, a meta-awareness is an awareness that plays the equivalent role of an awareness of an item, %. This equivalence relation is defined in terms of the class-specific relations in which Xj stands in respect to other awarenesses of the same item. What needs to be noted is that meta-awarenesses are not Dei ex machina of some sort, awarenesses that have been introduced out of nowhere to solve the problem of the possibility of temporal awareness further down the line. They are reconstructions of awarenesses of items qua this such as in terms of their web of relations with the same species of awarenesses. The quoting device marks precisely the equivalence relations afforded by the network of awarenesses as specified by the properties of their class. The ROC-J of any awareness of items can be reformulated or reconstructed by replacing it with the role 2 of its network of relationships, so that awarenesses of this such as, ROC-J, is meta-represented as, i.e., equivalent to, awarenesses of this such as, role 2. In this fashion, we can see a BX and a B2, impressions and reproductions, under the general form of *XJS network of equivalence relationships, where the denotes the role of, and % and FF respectively signify an awareness of an item and a category of awarenesses whose properties are specified under the class or network of causally ordered representings. It is this swapping of roles from XS to its network of relationships that makes it possible to causally represent an awareness from the perspective of other awarenesses and their network of relationships in such a way that impressions can be addressed from the experiential viewpoint of reproductions, and reproductions through the purview of impressions. The usefulness of this category theoretical model lies not simply in its diagrammatic efficacy in allowing us to visualize the meta-representing faculty, but in its power to provide us with some schematic insights into the geometric form of constructive memory. This geometry of memory is a prerequisite for the realization of an agent that has an experiential history and that, by virtue of this, is capable of assessing and appropriately responding to its experiences, and ultimately of judging and questioning the very facts of its experience. 194. The significance of meta-awareness as a global faculty for generating a complex of nested awarenesses is that it introduces a special functional role for B and B2. It allows one of these modes of being presented, impressions and reproductions, to fall within the scope of the other, and in doing so, it provides the automaton with distinct representations for the being of some items being 2 and the being 2 of the same items being, the memory of an impression and the impression of a memory. In other words, the automaton has now the adequate representational resources to distinguish between an item that is being encountered now and one that is not being encountered now but was encountered and is reproduced, that is, the distinction required for having a perspectival temporal awareness of is and was. Even though the automaton does not have the conceptual resources to see this distinction as is and was, it nevertheless exhibits and instantiates a temporally perspectival awareness that can be legitimately described, via analogy with our concepts, as the temporal distinction between is and was. Having orderly elements of the past and the present, the only thing that the temporal experience of the automaton is missing is the future. Recall that the constructive model of the automaton's memory not only retains and reproduces impressions, but also, and more importantly, plays a role in the behavioral activities of the automaton. In particular, it plays a role in constructing a model of expected action based on the experience of the automaton. In simple terms, besides retaining and reproducing, the memory generates anticipations, a third model of items, being 3, in addition to being and being 2. Adding this third model of items to the previous types of awarenesses does not disrupt or alter the potentially infinite nested structure necessary for the realization of a temporally perspectival awareness. Instead of 2 types of awarenesses, the automaton has now 3 types. ABX T0 baby, T0 baby 2 T0 baby 3. AB2 T0 B2 Bay T0 B2 B2 T0 B2 B3. AB3 T0 B3 B. T0 B3 B2 T0 B3 B3. In possessing these three types of awareness and, correspondingly, the nested structure that comes with them, the automaton has acquired 195 capacities: memory, awareness of the being two of items, anticipation, awareness of the being three of items, and reflexive meta-awareness, awareness of the being two and being three of items. But also, and more importantly, the automaton has thus fulfilled the condition of possibility for the fundamental faculty of inner sense, the necessary capacity of the mind to be affected by its own states and to actively respond to being so affected with representations qua intuitions of items in the mind, cogitations, standing in temporal relations. Analogous to outer sense, where objects are reported to the mind, inner sense is a faculty through which representations, rememberings, anticipatings, perceivings, etc., are reported to the mind. At the core of this faculty is an operational and synthesizing time order. And without this fundamental faculty, it is impossible to cross over into the qualitative domain of apperceptive general intelligence. Whenever our representations may arise, whether through the influence of external things or as the effect of inner causes, whether they have originated a priori or empirically as appearances, as modifications of the mind, they nevertheless belong to inner sense, and as such all of our cognitions are in the end subjected to the formal condition of inner sense, namely time, as that in which they must all be ordered, connected, and brought into relations. This is a general remark on which one must ground everything that follows. Point 136. Although the automaton is not yet aware of itself as a creature endowed with a history, it is aware of itself, from our analogically posited point of view, as a history, an orderly expanding sequence of awarenesses standing in changing temporal relations to items behaving independently of their experience over time, namely, a world history. It is this kind of intelligence which, even though not yet self-conscious, can potentially treat itself as a project in which the intelligibility of world history and the self-emancipation of intelligence, the self-constitution of its own history, go hand in hand. Now we are in a position to advance our toy model of purely perspectival heuristic intelligence endowed with positional capacities, impressions, sensitivity, anticipation, and rudimentary forms of memory and inner perception, toward an active model of intelligence with functional abilities that allow it not only to reason about the contents of its awarenesses but also to treat these awarenesses as its own so as to systematically respond to the imprints of items in the world on itself. We can think of this transition as the move from one type of abilities carried to another type, abilities. Abilities are those generated only by virtue of the sufficient structure of the automaton, and which therefore should be properly referred to as general capacities that do not depend on the contents of the automaton's encounters with the world, but instead are mere aspects of the overall structural organization of the automaton. On the other hand, abilities are abilities which, although built on abilities 13, are nevertheless qualitatively different from them. These are abilities that rely on and are entangled with the contents of these encounters. Precisely, it is this entanglement with the content, being able to reason about it, assess it, examine its implications, and work out its particular formal and material inferential relations with other contents, that differentiates abilities too as doings. The ability to form judgments and to reason about experiential contents is not something that merely transpires in our automaton or befalls it in virtue of its wiring. It is something that the automaton actively does by entering a new domain, the logico-semantic domain of contents, wherein abilities are no longer mere capacities but are conducts for navigating, and in the process making sense of, the contents of encounters with the world and our awarenesses of them. We shall call abilities structural capacities, and abilities, logico-semantic functional abilities, or, more laconically, normative abilities. What we should remind ourselves of here is that abilities too are structurally afforded by the causal regime of abilitius J. However, this does not mean that abilities are sufficient for the generation of abilities too, nor does it mean that abilities too are of the same type or quality as abilities. The latter category is necessary but not sufficient for the realization of the former. One does not. 197. Simply jump from the mere capacity to discriminate stuff to the ability to make judgments as to the nature of the stuff in question. The systematicity and adequacy of the automaton's response to the impingement of items in the world on itself depends upon two abilities to 1. The ability to form veridical judgments about the contents of awarenesses, telling apart what seems to be the case from what is the case and how one ought to respond to it. 2. The ability to form a subjective point of view in order to endorse in line with the ability of veridical judgment one story about the items in the world, or one course of action in response to such a world story, over another. It is the latter that is the kernel of freedom qua elaboration of practical and theoretical cognitions. This discursive subjective point of view, however, does not need to be understood within the framework of the phenomenal self-model replete with illusions of selfhood, such as the ownership of an empirical self as a constant phenomenal property, a transparent experience of the world, and direct encounters with items in the world. Rational selfhood or subjectivity ought to be understood as a normative functional rather than purely structural solution in constructing a qualitative form of intelligence. Bridging the gap between abilities and abilities too while retaining their qualitative difference will be the focus of the next chapter, but before that we shall look more closely at the question of time consciousness or experienced temporality that came to the foreground with the inception of inner sense. Given the fact that veridical thoughts are essentially temporal insofar as they depend on sensory rather than intellectual intuition, the question of time is of the utmost importance. Moreover, since time is the veritable object of transcendental logic, i.e., the logic of thought as related to sensory intuition and an ordering factor in transcendental psychology, one cannot go on and tackle the question of mind without examining the question of time. Lastly, this will be also an opportunity to 198. Underline the significance of the critique of transcendental structures, where we will have the opportunity to investigate the role of memory, a topic missing in Kant's discussion on transcendental aesthetics and language in our specific form of time consciousness. We will put forward a picture of intelligence able not only to challenge its so-called facts of experience but also to modify its conditions of transcendental aesthetics, thus renewing its engagement with reality and, in doing so, enriching the reality of itself beyond what is given to it. 19.9. For some unsettling Kantian news, as delivered by Boltzmann, an excursion into time. Space only offers us relations without relata, and a confused phenomenal melange in which we can only problematically disentangle the substantial agencies operative in the latter. And time only offers us sequences infected with vanishingness, which cannot best suggest the presence of permanent underlying agencies. 137. In this digressive chapter, we will examine a case study that underlines the significance of the question of transcendental structure in exploring the meaning of agency and general intelligence as outlined in Chapter 2. Our excursion into the problem of transcendental structures or types will take us down the road of that most enigmatic aspect of the world and our experience of it, time. Let us begin our investigation into the question of time not only from the perspective of the automaton's temporal awareness but from the standpoint of the more advanced sense of time specific to a language user in possession of tense sentences and modal vocabularies, the ordinary time-conscious subject. From what we saw above, the automaton's awareness of the past, present, and future appears to be a contingent construct of its structural behavioral organization, its mode of responsiveness to the impingement of items in the world on its senses, its constructive anticipatory model of memory, and the structuring of its meta-awarenesses on such a model. And finally, on higher levels belonging to the apperceptive subject of experience, ordinary time consciousness is the fruit of a certain troubling marriage, the messy entanglement between the objective sense of time and the categories of causality, alteration, and community, simultaneity, that is already present in Kant, and in which the temporal and the causal serve reciprocally in each other's definition, without either being satisfactorily defined as such. From the analogically posited perspective of the automaton and the non-analogical viewpoint of the discursive apperceptive intelligence, time appears to be flowing, or they themselves seem to be moving through it. The future recedes into the past and we experience ourselves as moving from the past toward the future. In this section, we shall have occasion to inspect why such images of time as a flow or advancement through time are rife with inconsistencies. Only by shedding light on these inconsistencies and their ramifications will we be able to think about what it means to expand the theoretical and practical abilities of agency into a larger field of possible experience that is no longer foundationally attached to a particular structure. It would be a biased argument to infer the objective reality of temporal direction, a dynamic flow-like picture of time, or even the objective reality of time as such from either the perception of temporal instances or the tensed consciousness of time. In order to demonstrate this, we will make use of a modified version of John McTaggart's infamously controversial argument regarding the unreality of time, which is implicit in Kant's discussion of the transcendental ideality of experienced temporality, i.e., the argument that time qua experienced temporality is unreal. Point 138. McTaggart gives his argument for the unreality of time in three different forms, the first two originally proposed in his essay The Unreality of Time, the third in volume 2 of his later work The Nature of Existence. The first and most well-known argument is presented via the so-called A series and B series, which are different series of positions in time. The A series denotes a tense temporality in which positions in time start from the far past, going through the near past to the present and then from the present to the near future toward the distant future. Events therefore continually change their temporal position in the A series. On the other hand, the B series characterizes a tenseless temporality in which positions in time run sequentially from the earlier than to the later than, with the temporal position of an event remaining stable, but being defined in terms of precedence and antecedence to other events. In this argument, change, as the characteristic of the A series, is taken to be essential for the nature of time, and the B series is considered to be reliant on this change. McTaggart then argues that the A series cannot exist because past, present, and future are incompatible determinations. Each temporal event in the A series, in terms of being of the past, of the present or of the future, presupposes the entirety of the A series, but insofar as every event must be one or the other and cannot be more than one, the A series is proved to be incoherent, an incoherency that also undercuts the reality of the B series. McTaggart's second argument is presented in the context of the specious present, the instant not as a point but as a short duration, a collection of pairwise overlapping events, 139 in which our perceptions are regarded to be in the present, a tract of experience with a special durational unity of the before and the after. The main thrust of the second argument is what Rosenberg identifies as an ontological tension between successiveness of the elements of a duration apprehended in a specious present and the simultaneity of the elements constituting the apprehending act. Point 140. McTaggart argues as follows. The specious present of our observations, varying as it does from you to me, cannot correspond to the present of the events observed. And consequently the past and future of our observations could not correspond to the past and future of the events observed. On either hypothesis, whether we take time as real or as unreal, everything is observed in a specious present, but nothing, not even the observations themselves, can ever be in a specious present. Point 141. Finally, in the third version, McTaggart gives his argument on the unreality of time a far more expansive scope. At the beginning of what is an exceptionally sophisticated exercise in critical philosophy, the second volume of The Nature of Existence, McTaggart reframes his inquiry into the reality of time as simply a starting point for a broader examination of the question of whether or not the characteristics of reality are those characteristics that it appears to have in experience. We shall have to consider various characteristics as to which our experience gives us, at the least, a prima facie suggestion that they are possessed either by all that exists, or by some existent things. And two questions will arise about these characteristics. We shall have to ask, firstly, which of these characteristics can really be possessed by what is existent, and which of them, in spite of a prima facie appearance to the contrary, cannot be possessed by anything existent. And we must ask, secondly, of those which are found to be possible characteristics of the existent, whether any of them can be known to be actual characteristics of it. 142. The modified version of the argument for the unreality of time qua experience temporality that I have in mind, however, is more in line with McTaggart's third argument, which can be reconstructed and presented in two forms. The modest version of this modified argument is that we can neither draw conclusions about the objective reality of time, whether as a reified thing or a non-reified formlessness, its direction, its flow, and its temporal structure, nor in fact affirm the existence of such objective properties, on the basis of the structure and characteristics of experienced temporality. The bridge between the phenomenological, psychological, or subjective and the metaphysical, physical, or objective accounts of time is no ready-made matter, for the reason that the two are incommensurably distinct. Rather than arguing that there is no objectively real time, the modest claim here concerns the illegitimate nature of the inference from the perception of time qua experienced temporality to the objective reality of time on the basis of some assumed isomorphism, private access, global sense of direction and passage of time, structure of tensed language, or observed arrow of causality. Said in a different way, we cannot infer an objective account of time from temporal dynamic characteristics that appear in experience or conditions of observation. But this does not tell us whether or not there is an objective time, nor, if there is, what its characteristics might be. In other words, this is different from a naively hyper-Kantian position born of a conflation between commitments to epistemological idealism and commitments to ontological idealism, for which it is impossible to think an objective reality for time or to see any structure as anything but a structure inherent to our subjective point of view. While the conceptual resources of our language enable us to make veridical judgments pertaining to time, we are not permitted to treat these temporal components of language, i.e., the tensed verbs and temporal connectives of our statements about objective time, such as before, after, when and until, as evidence for the objective structure of time. This of course opens up a more fundamental question: is the tense structure of natural languages even appropriate for investigating the question of time, or should we completely shift to formal theoretical languages, which would allow us to take advantage of temporal connectives with more neutral and flexible logical connections? What Quine rightly snubs as the tiresome bias 143 toward ordinary language in the treatment of time should alone be sufficient reason for philosophers to become suspicious of the kinds of loose wordplay they employ not only when thinking about the problems of time and temporality, but also when thinking about change, whether the latter is understood as something events undergo in the universe or as a transformation effected by rational agents in the world. The less modest and more disquieting version of the unreality of experienced temporality, what should be called the sinister version, is that there is a good chance that any asymmetric picture of time that allows for sequences running from one extremity toward another, from past to future or future to past, in a punctual or durational form, or where the present can be regarded as something objectively distinguishable, is riddled with experiential biases. These biases are not exclusive to ordinary subjective time consciousness and the tense structure of natural language that relays it, but also, and more fundamentally, can even be extended to the ideal notion of the observer in physics. The sinister implication is that, if directional, flow-like pictures of time are negatively biased by the structure of experienced temporality and the local characteristics of the subjective perspective/observer, and if the classical notions of causality, system state, and antecedent conditions are embroiled in directional flow-like pictures of time, then those portions of complexity and physical sciences that have incorporated these concepts as their fundamental explanatory descriptive elements are also biased and prone to significant revision, if not abandonment. What is meant by causality here is not what Wolfgang Stegmüller astutely identifies as the prescientific concept of causality, namely, singular causal judgments, or individual cause-effect connections, reflected in sentences of ordinary language containing terms such as because and since. Seneca cut his veins since Nero ordered him to kill himself, the car crashed into a tree because the brakes stopped working, etc. Point 144. The prescientific Cause-effect connection is built upon the arbitrary selection in Stegmuller's words more psychological than epistemological of one diagnosed or indicant condition from among a large number of conditions that may not seem to play any explicit causal role. Instead, the concept of causality that is at stake here refers to a set of law-like regularities along with a set of antecedent conditions that together constitute the explanans of a causal explanation. In this schema of causal explanation, statements belonging to the explanans must have empirical content as well as at least one nomological law statement in order to count as causally explanatory. And so begins our inquiry into the limits of the transcendental structure of experience. To what extent is what we take as a necessary and universal fact of experience, an a priori act, in fact a local and contingent aspect of our experience? Or, in other words, how much is what we take to be necessary distorted by what is actually contingent through and through? As promised, this is where we can benefit by focusing on a particular case study. The challenge to the directional, flow-like picture of time can potentially problematize the classical conditions, i.e., conditions dependent on various dynamic time-oriented phenomena, from inductive numerical asymmetries to temporal asymmetries, etc., through which law-like regularities are derived and antecedent conditions are characterized. As for the notion of the state of a physical system that is in question here, it describes dispositions of the system for responding to a range of possible circumstances that might be encountered in the future. This notion of the state is, properly speaking, a descriptive tool for predicting the future responses or trajectories of the system, in terms of counterfactuals, from its present behavior. Hidden variables, on the other hand, refer to those states taken to be independent of any future interactions to which the system might be subjected. These concepts are based on perspectival temporal and modal asymuics of the local observer that ground the distinction between sequences running from past to future and those running from future to past, or, more generally, the orientation of sequences with regard to the passage of time. These concepts causality, law-like regularities together with antecedent conditions, states, and hidden variables play a fundamental role in complexity sciences, particularly those branches that make heavy use of heuristic methods for describing the behavior of the system, characterizing its structural and functional features, and predicting its evolution. Any significant revision of the canonical model of directional flow-like time may potentially harbor devastating outcomes for these frameworks, operative not only in physics, chemistry, and biology, but also in neuroscience, economics, and the social sciences. Drawing attention to the observational and subjective biases within the directional dynamic picture of time and temporal asymmetries, and pointing out the negative connotations of such biases for the concepts of description, causal explanation, modeling, and prediction is by no means a recent line of inquiry. In what Price calls a Copernican moment and Hans Reichenbach distinguishes as one of the keenest insights into the problem of time 145, Ludwig Boltzmann summarizes the problem in the following remarks, worth quoting in their entirety. Just as the differential equations represent simply a mathematical method for calculation, whose clear meaning can only be understood by the use of models which employ a large finite number of elements, so likewise general thermodynamics, without prejudice to its unshakable importance, also requires the cultivation of mechanical models representing it, in order to deepen our knowledge of nature not in spite of, but rather precisely because these models do not always cover the same ground as general thermodynamics, but instead offer a glimpse of a new viewpoint. Thus general thermodynamics holds fast to the invariable irreversibility of all natural processes. It assumes a function, the entropy, whose value can only change in one direction, for example, can only increase through any occurrence in nature. Thus it distinguishes any later state of the world from any earlier state by its larger value of the entropy. The difference of the entropy from its maximum value, which is the goal 7 reabend of all natural processes, will always decrease. In spite of the invariance of the total energy, its transformability will therefore become ever smaller, natural events will become ever more dull and uninteresting, and any return to a previous value of the entropy is excluded. One cannot assert that this consequence contradicts our experience, for indeed it seems to be a plausible extrapolation of our present knowledge of the world. Yet, with all due recognition to the caution which must be observed in going beyond the direct consequences of experience, it must be granted that these consequences are hardly satisfactory, and the discovery of a satisfactory way of avoiding them would be very desirable, whether one may imagine time as infinite or as a closed cycle. In any case, we would rather consider the unique directionality of time given to us by experience as a mere illusion arising from our specially restricted viewpoint. 146. Boltzmann then continues. For the universe, the two directions of time are indistinguishable, just as in space there is no up or down. However, just as at a particular place on the Earth's surface we call down the direction toward the center of the Earth, so will a living being in a particular time interval of such a single world distinguish the direction of time toward the less probable state from the opposite direction, the former toward the past, the latter toward the future. By virtue of this terminology, such small isolated regions of the universe will always find themselves initially in an improbable state. This method seems to me to be the only way in which one can understand the second law, the heat-death of each single world, without a unidirectional change of the entire universe from a definite initial state to a final state. Obviously no one would consider such speculations as important discoveries, or even as did the ancient philosophers, as the highest purpose of science. However, it is doubtful that one should despise them as completely idle. Who knows whether they may not broaden the horizon of our circle of ideas, and by stimulating thought, advance the understanding of the facts of experience. 147. Thermodynamics is a thriller, but we all know how its plot unfolds. The film shows the expansion of a gas in a sealed bottle. There is an imaginary compartment with a trapdoor in the bottle, equilibrium state carried. Inside this compartment the gas is pressurized. Next the film shows the imaginary door being opened. We can easily anticipate where the story is headed. The gas starts to spread, far from equilibrium, and it finally fills the entire bottle, equilibrium state 2. The montage of this film is asymmetrically oriented. Once the trapdoor is released, we see gas filling the entire bottle, but never coming back to its original confinement in the imaginary compartment. And even if we watch the movie backwards, we can still tell what the plot is. This is the observed time asymmetry of an irreversible process. However, there is also a different montage subplot for this film. It shows the molecules of gas colliding with one another and freely moving in every direction. Whether we see this version on fast forward or on rewind, we still cannot tell whether the gas is expanding in one direction or another. This is the time symmetry of the underlying microscopic mechanical laws. So how can we reconcile the first version of the film with the second? In the first version of this film we are actually dealing with two laws, the law of approach toward equilibrium, and the second law of thermodynamics. As noted by Josephink and fleshed out by Medir Hemo and Orly R. Schenker, these two laws express two entirely different sets of facts and require different kinds of explanation. 148 It is an experimental fact and the extension of the first law as the thermodynamic version of the law of / the conservation of energy that energy tends to change its form, it is T not created ex nihilo. But this change is such that the amount of energy and exploitable for work decreases over time. This is what is described by both the law of approach toward equilibrium and the second law, but one under different explanatory frameworks. The law of approach toward equilibrium is a schematic generalization of our observed experience insofar as it does not by itself tell us which state is the equilibrium state for a given set of constraints in the system. This specificity of the equilibrium state can only be derived nomologically from experience. It cannot be obtained as an a priori theorem of thermodynamics. Whereas the second law of thermodynamics is about the increase of entropy as the ordering of states of equilibrium in time, according to which the amount of energy which is in the form of heat, relative to the amount of energy which is in mechanical or other forms of energy, which are more readily exploitable to produce useful work, cannot decrease. 149 With these necessary notes in mind, in the passage by Boltzmann * cited above, What vexes the physicist is not the puzzles of the directional dynamic picture of time, but rather the unproblematic and innocent nature of the assumption that time does in fact have an objective #Pearl direction. There is a circularity involved in postulating a direction. For time based on the observation of irreversible processes in time, and inferring the irreversibility of processes on the basis of a canonical, albeit implicitly stated, arrow of time. For Boltzmann, the real conundrum is not why entropy increases with time, but why it was ever so low to start with. Formulated differently, rather than asking why entropy increases toward the future, we should ask why it decreases toward the past. The source of Boltzmann's problem lay precisely in what he had initially treated as a key to solving the problem of the second law of thermodynamics. Where does the time asymmetric characteristic of the second law, which states that entropy increases over time, come from, given the time-symmetric laws of the underlying mechanics? Again, how can the two different versions of the film be made compatible? Toward the end of the 19th century, figures such as Boltzmann and Gibbs had begun to develop a fully statistical, proto-computational/information theoretic, account of thermodynamics. For Boltzmann, however, this was part of a broader project, one whose aim was to provide complete descriptions of physical phenomena. The stepping stone of this descriptive project was Boltzmann's reformulation of the concept of scientific description, at once removed from the dominant influence of earlier phenomenalist and psychological accounts of description, such as Mach's, and sufficiently fine-grained to be capable of integrating statistical, epistemological, phenomenological, real ideal, subjective objective levels and types of description in a non-arbitrary, i.e., intrinsic, manner. To this end, Boltzmann provided three general levels or types of description: pure or abstract description based on inferential generalization of differential equations rather than on a correspondence to observed facts; indirect description based on a probabilistic framework of statistical description; and a level of description concerning unobservables. As Adamberg argues in Phenomenalism, Phenomenology, and the Question of Time 150, Boltzmann's reframing of thermodynamics, specifically the second law, through statistical mechanics, should be seen within the scope of this descriptive analysis as a multilevel complex system of coding with distinct descriptive levels that require different appropriate systems of coding, noetic contents, and methods of analysis, as well as appropriate spaces for bridging these levels. Within the scope of this multilevel descriptive analysis, which became the skeletal framework of modern scientific theories, Boltzmann developed his statistical theory of the non-equilibrial, i.e., irreversible and time asymmetric, behavior of macroscopic systems. He introduced the concept of the macrostate as part of his attempt to relate the second law of thermodynamics to the probability calculus. Physically objective and correlatively defined between the observer and the observed, macrostates are sets of microstates which by themselves cannot be distinguished by a given observer. 151 Macrostates are objective insofar as they intrinsically express the one-to-many or many-to-many correlations between the underlying microstates. The introduction of the macrostate is required, then, in order to distinguish thermodynamic regularities that would otherwise be indistinguishable at the level of mechanical microstates. Microstates are, on the other hand, the instantaneous states of the universe. In Boltzmann's framework, a microstate of a single molecule is represented by a point in the state space of that molecule, where the state space represents the space of all the microstates a system can inhabit. This state space is a six-dimensional space comprised of three spatial positions and three momentum dimensions or degrees of freedom. This state space of a single molecule is called p-space or molecular space. Boltzmann then associated an entropy value with each macrostate and with each microstate giving rise to that macrostate. In this framework, entropy could be seen as a tendency to evolve toward more probable macrostates, and its increase as information regarding the qualitative dynamic behavior of macroscopic systems. From the perspective of this new multilevel descriptive analysis, the problems of the second law, i.e., why does entropy increase over time, and the observed irreversibility and Time asymmetry of physical processes in time. Despite the time symmetry and reversibility of the underlying mechanical physical laws, could thus be reframed as the problem of moving from microscopic to macroscopic descriptions. The solution to these problems could then be formulated by devising a statistical mechanical framework that accommodates a conception of macrostate, pertaining to the macroscopic level, expressed in terms of physical probability or permittability, and intrinsically correlated to the microstate, associated with the microscopic level, responsible for it. Within this statistical mechanical resolution, entropy, then, is defined as a tendency toward more probable macrostates, the probability of which is logarithmically defined. We will not able to delve further into the details of how Boltzmann constructed his solution, but, very briefly, it involved a procedure that would make explicit the connections between statistical and thermodynamic descriptions through the introduction of the concept of macrostate formulated in terms of its probability, and a six-dimensional partition velocity phase space, the p-space, which allowed the bridging of microstates and macrostates, microscopic descriptions and macroscopic descriptions. Following Maxwell, Boltzmann began to examine the effects of collisions on the distribution of velocities of molecules of a gas. He introduced a space divided into a finite array of small rectangular cells or intervals of equal size or volume in position and momentum. 152. Once available velocities are partitioned into these cells, then there is an effective combinatorial computational procedure for examining the effects of collisions on the number of molecules whose velocities entered these cells. It is noteworthy that, in this solution, macrostates do not depend upon the identity of individual molecules entering these cells. They depend upon the identity of the cells in which varying numbers of molecules or particles have been thus distributed. Using this combinatorial procedure, Boltzmann was able to argue, L, that the distribution of velocities corresponds to the Maxwell probability distribution, in which the quantity E or H, equivalent to negative entropy, can be said to be decreasing, and, 2, that this distribution is independent of the initial distribution of velocities. No matter how particles are initially assigned to the available velocity cell partitions, we still obtain the same probability distribution, which accounts for the monotonic decrease of H, demonstrating that the quantitile talways monotonically decreases, its lowest value being the state of thermal equilibrium, was proof of the unidirectional and irreversible increase of entropy and the time asymmetric behavior of physical processes at the macroscopic level in spite of the reversibility and time symmetry of the underlying microscopic mechanics. However, as reflected in the quote cited earlier, Boltzmann later expressed doubts about his solution and began to examine the challenges raised by adopting a resolutely atemporal perspective. Given the fact that the statistical argument itself is merely a combinatorial counting procedure and lacks any time asymmetry, and that therefore there is no reason to apply the increase of entropy to a unique sequence that runs from the past toward the future, it can equally be applied to a sequence running from the future to the past. In which case, as mentioned earlier, what really demands explanation is not the increase of entropy toward the future, i.e., what appears to be a natural state of things, but the ever so low entropy in the beginning, insofar as the statistical argument gives us equal reason to expect an increase of entropy toward the past. It places the burden of explanation on the earlier low entropy rather than the later high entropy. In light of the statistical argument, i.e., equal probability of increase in entropy in either direction, past to future and future to past, the global decrease of entropy toward the past now appears as an unnatural condition and so itself demands explanation. In other words, for Boltzmann, changing the perspective from temporal to atemporal had turned something natural, low entropy in the past, into something unnatural, high entropy in the past, and therefore, in line with the motivations of scientific explanation, which demand that we account for unnatural conditions, called for a shift. 215. In explanatory focus. This raised challenges that have vast implications not only for our models of processes and our methods for the metricization of events, but also for what we take to be the established facts of our experience. Yet to date these implications have gone largely unheeded. Even though Boltzmann shifted his efforts toward a reinterpretation of thermodynamics from an atemporal perspective, the deep problematic aspects of his initial solution to the problem of the second law were carried over into his new interpretation, given in the context of the cosmological hypothesis 153 and which was supposed to be free of any particular temporal bias. But what is this problematic aspect which, despite being spotted at least partially by Boltzmann, still resurfaced in his later interpretation? The problem with Boltzmann's initial solution was that he had unintentionally imported subjective characteristics of experience into his combinatorial procedure via the introduction of macrostates. In other words, the phenomenal assumptions regarding the facticity of observed time asymmetry for the ensemble's macrostate were illicitly applied to the description of microstates. In this sense, Boltzmann had not really bridged the gap between statistical mechanical entropy and thermal entropy belonging to different levels of description, but had only elided the distinction between the two descriptive levels by illegitimately transporting the underlying assumptions of one into the other. Indeed, Boltzmann did notice this problem, but what he did not recognize was the extent to which the time asymmetric assumptions specific to the macroscopic description had distorted the statistical objective description associated with microscopic systems. What he had taken as innocently given initial and boundary conditions were themselves infected by the biases specific to observer-observer correlations. In other words, Boltzmann did not fully realize that the biases of unidirectional time had already infiltrated the law-like principles through which the parameters of the microscopic systems such as initial conditions were being defined and chosen. Following Boltzmann's Oxford lecture, this problem was first recognized by George H. Bryan and Samuel Bowberry. It has recently been refined by Price and encapsulated under the principle of molecular or microscopic innocence, plenissence. Plenissence is the apparently obvious intuition that interacting systems are bound to be ignorant of one another until the interaction actually occurs, at which point each system may be expected to learn something about the other. 154 But what exactly is the problematic nature of this intuition with respect to Boltzmann's later work on bridging statistical entropy with thermodynamic entropy, the so-called Boltzmann's principle formulated by the equation S equals K log W? It is the implicit time asymmetric assumption within Boltzmann's principle of molecular collision or chaos, Stoffwechselansatz, the idea that the velocities of two particles that have not collided yet can be said to be uncorrelated, and can therefore be identified as an initial condition, already presupposes a privileged temporal causal asymmetry. Why? Because, insofar as microscopic mechanics is time-symmetric and initial microstates are equiprobable, there is no reason to expect the velocities of particles to become correlated as a result of their collisions. Under Stoffwechselansatz, we anticipate outgoing products of collisions to be dynamically correlated even if they never interact in the future. In other words, we always expect the number of outgoing collisions, 6, v2, **, 6, v2, tobe proportional to / 6, f, v2, where 6 and v2 are the velocities of particles before the collisions. 155 But we never expect the converse, that the incoming components of a collision will be correlated if they have never encountered each other in the past, i.e., if the molecules have never interacted. As Price suggests, this is a time asymmetric intuition which has no place in the statistical/information theoretic description of the system. And yet Boltzmann's entire Stoffwechselansatz is built upon it. 156 It is as if, as soon as we put in place an incorrect framework for our encounter with the physical universe, no matter what we do from that point onwards, everything will appear to be an incoming chaos. If no direction of time is initially privileged in the description of initial and boundary conditions, since the statistical argument by itself has no time asymmetric component, then once we adopt an atemporal perspective, there is no reason for us to presume that the time asymmetric explanatory schema of an initial microstate explaining a final macrostate will be tenable. Earlier than, low entropy, and later than, high entropy, as atemporal determinations of before and after can very well be contaminated by the biases of a temporal time asymmetric viewpoint. Accordingly, Boltzmann's true challenge, not fully appreciated even by himself, now boils down to a much more fundamental question: how can we suggest that an initial microstate can explain a final macrostate, if what is really in need of explanation is the temporal asymmetry that grounds such an explanatory schema? It does not take too much critical acuity to realize that a similar question can be posed with regard to those frameworks of causal explanation specifically utilized in the context of reductionism that rely on identification of some antecedent conditions and a temporally directed causal arrow through which, thanks to the convenient mediation of time asymmetry, the distinction between the causal and the explanatory effectively fades away. Nevertheless, the real significance of Boltzmann's challenge is only revealed in its full force when it is treated as a general epistemological critique. How can we justify a chain of inference that follows an explanatory arrow whose ground of justification, its explanans, is nothing more than the past state of affairs as an observable item or an empirical footprint? This question can of course equally be applied to a chain of epistemological inference that runs from the future to the past. In both cases, what needs to be justified is exactly what is taken to be the ground of justification. Thus epistemological neutrality appears to be in sharp conflict with temporally charged modes of epistemological inference. Hoping to retain some aspects of the former while drawing conclusions from the latter in a practical trade-off is more like wishful thinking than a pragmatic paradigm of scientific knowledge. The illegitimate imposition of time asymmetric descriptions exclusive to macrostates onto descriptions of microstates in order to explain the behaviors of the former via the mechanics of the latter, therefore, bespeaks a much broader range of complications arising from our epistemological, and not merely perceptual observational, biases in coordinating our observational frameworks with our theoretical inferential frameworks. Accustomed to the cosiness of our intuitions and under the theoretical influence of our local subjective biases, we are frequently liable to project our subjective assumptions onto the world and, in doing so, to posit that 2x9, which itself requires explanation, qua subjective characteristic, as an objective explanatory feature. The same biases can be detected within theories in which computation is strongly coupled with the postulate of positive entropic increase for irreversible processes. For example, in the thermodynamics of computation it is often held that the physical implementation of any logically irreversible operation such as erasure results in an increase of entropy. The amount of increase is mod2 per bit of erased information. Once an observer, via measurements, obtains information concerning which macrostate is the actual state of the observed system, then such information can be manipulated. But macroscopic manipulation of this information, particularly through irreversible logical operations such as erasure and conjunction, results in positive entropy production. In simpler terms, the physical implementation of computation, i.e., physical computers, always exacts an entropy cost. However, there is no a priori necessary connection between the orthodox theory of thermodynamics and the theory of computation which would allow one uncontroversially to associate the logical properties of computation with the principles of classical mechanics. The problem that of the exact link between thermodynamics and computation, between the physical implementation of logical operations and the fundamental laws of physics, is by no means a settled issue yet. The information obtained and manipulated is information concerning the macrostate, and the macrostate is observer-related. Therefore the entropy cost of the manipulation or physical implementation of irreversible logical operations is also observer-related, and depends on the specificity of the physical implementation. What is erased, in this sense, is precisely the inferential link or mapping, rather than the memory of the observer itself, between the past macrostate and the present macrostate. In other words, erasure means that the observer cannot infer the past macrostate from the present recently observed macrostate, cf. Russell's paradox, discussed below. Point 157. It might be objected that time asymmetry and temporal descriptions are only useful fictional instruments, at best subjectively, at worst speculatively metaphysical, that allow us to talk about non-temporal events and processes. It is true that, as Adolf Greinbaum, that most astute debunker of the mysteries of space and time, has spelled out, Our sense of time as a flow is only a qualitative conception devoid of metrical components. 158 But as we have seen, this qualitative conception is liable to corrupt the metrical ingredients of our scientific frameworks even when its interference is least expected. Objections that dismiss temporal descriptions and time asymmetry as useful idealizations or metaphysical fictions can reinforce our obliviousness to the influence that our temporal intuitions exert upon models and methods we assume to be unaffected by any objective or subjective account of time asymmetry. In doing so, rather than giving reason for making a radical scission from temporal intuitions, they give more reason for further postponement of the overdue critical task, namely, the examination of the extent of the distorting effects temporal intuitions have had and continue to have on scientific models and methods. Reference to the empirical success of confirming observations regarding time asymmetric behaviors runs, from different directions, not only into the old and new riddles of induction concerning future observations, as stated by Hume and Goodman 159, but also into the problematics of the reliability hypothesis concerning the memory-driven knowledge of past observations, as formulated by Russell's 5 minutes ago paradox 160. In investigating memory beliefs, there are certain points that must be borne in mind. In the first place, everything constituting a memory belief is happening now, not in that past time to which the belief is said to refer. It is not logically necessary to the existence of a memory belief that the event remembered should have occurred, or even that the past should have existed at all. There is no logical impossibility in the hypothesis that the world sprang into being 5 minutes ago, exactly as it then was, with a population that remembered a wholly unreal past. There is no logically necessary connection between events at different times. Therefore nothing that is happening now or will happen in the future can disprove the hypothesis that the world began 5 minutes ago. Hence the occurrences which are called knowledge of the past are logically independent of the past, they are wholly analyzable into present contents, which might, theoretically, be just what they are even if no past had existed. 161. As observers, we take our memories to be reliable reflections of actual states of affairs, and, given that the content of our memory is that entropy was lower in the past based on memories of previous observations, our microscopic retrodiction concerning low initial entropy should also be seen as reliable. But according to Russell's 5 minutes ago paradox, since the contents of our memories are not derived from mechanics, and to the extent that there are many-to-one correlations between our memory states and the universe, as opposed to a one-to-one correlation, successful retrodictions can be false memory beliefs, the falsity of which is a matter of logical tenability. Russell, however, attempts to stave off the hazardous effect of his paradox by discrediting it as simply uninteresting. 162 and instead in the last instance saves the memory-driven knowledge of the past. Russell's line of reasoning in defense of a memory-driven knowledge of the past runs like this: such knowledge depends not on the occurrence of more instances of identical observations, but rather on two suitable belief-supporting series in which memory images can be classified. The first series classifies memory images in terms of the less or more remote periods of the past to which such memory images refer, henceforth, P series. The second series classifies memory images based on the degree of our confidence in their accuracy, henceforth, queries. In the queries, what warrants our confidence or lack thereof is the sense too of familiarity among the memory images themselves as being sensed J as more or less familiar, familiarity by degree. The more familiar memory images give us a sense too of accuracy of those images and thus the belief or judgment that what is happening now has happened before. In the P series, the sense too of the nearness or distance of memory images is given on the basis of how we remember, again a matter of degree, a remembered event as the time between the remembering and the remembered varies. Those rememberings that are more recent have more remembered context either because memory images are sensed as successively following their precursors, or because some sensations, so-called echolithic sensations or memory-based sensations 163 are apprehended as present, others as fading and thus apprehended as the marks of just pastness. Now, insofar as our rememberings always start from what has more context, i.e., is more recent, and the fading increases as the time increases, the P-series gives us a sense to qua-justified belief that the series of memory images being so remembered extends from present to just past to past, the fading of sensations belonging to the echolithic phase. Accordingly, the combination of P-series and queries the belief-supporting feelings of the pastness and the familiarity of memory images provide us with a justified and reliable knowledge of the past. As you may already suspect, based on how I have numerically distinguished the occurrences of the word sense, the problem with Russell's reasoning is that what is sensate qua organized sense impression the feeling of by itself does not so readily and directly translate into sense too qua judgment or belief proper. The myth of the given rears its head once again here. But even setting this issue aside, by themselves the senses one of the more familiar and the sensate of the more remembered context are too arbitrary. There can be many-to-many mappings or thematic affinities between the elements of both P-series, rememberings and remembereds, and queries, the more familiar, the less familiar, the vaguely familiar, and the unfamiliar, in such a way that ordering becomes a matter of entirely arbitrary selection. Moreover, the more significant issue is not that the sense can be illusory, but rather that the sense too of the memory images being thus and so recognized and remembered, as knowledge of the past, is first and foremost a statistical inference rather than a proper logico-semantic judgment. In other words, the semantic sense too is a linguistic whitewash over the fact that it is merely a statistical or inductivist inference, just like sensate. The difference between the two is that the former is at the level of the linguistic and the latter is at the level of the causal. Despite Russell's contention, sense 2 is nothing more than or superior to sense 15 other than being what linguistically bespeaks or betokens the causal statistical sense X. Imagine you are a detective, investigating a crime scene in some desolate and dreary town in New England in the middle of winter. Near the site of the crime, you see traces which resemble the tracks made by a car's tires. You instantly associate the trace with the movement of a car based on memories of your previous observations. This association is purely statistical, since the wind or some diabolically smart culprit bent on distracting you and wearing shoes with bizarre soles could also have formed these traces. Although this is highly improbable, it is neither probabilistically impossible nor logically untenable. The same holds for the previous observations of which you have a memory. Our linguistic judgment regarding the trace being associated with a car is only a semantic intentional counterpart of the statistical anticipatory model of our memory as a part of our nervous system. It does not give us an epistemic status above our inferential retrodiction regarding what has caused the trace in the snow, nor does it entitle us to believe that the association of the track with a moving car has a more robust probability, or an a priori logical necessity. It is not the case that sense 2 represents a belief proper as opposed to senses. Its epistemic status is no higher than that of sense. It is in fact a belief biased by or formed by the structure and anticipatory model of our nervous system. To treat sense 2 as a spechal sort of belief with superior epistemic content is only an instance of linguistic legerdemain. This is not to say that the sensing 2 of the trace is not linguistic or conceptual, i.e., a piece of judgment, but rather that its linguistic features should not mask the fact that it is, like the causal sense, a retrodiction, and not a statistically or a priori logically necessary belief as such. It then follows that Russell's emphasis on the distinction between the mere causal statistical impressions of memory images and justified conceptual beliefs with additional epistemic content turns out to be a feat of semantic dissimulation. The sense 2 of the trace is nothing but the linguistically latent counterpart of the sensate, which is causal and statistically retrodictive in its entirety. In view of the fact that the sense 2 is nothing but the linguistic intimation of the retrodictive aspect of the causal sense X and nothing more, Russell's memory-driven knowledge of the past falls again under the axes of the old and new riddles of induction, and those of his own 5 minutes ago paradox. The one-to-many, or even many-to-many, correlations between our memory and the rest of the universe make the issues of the unreliability of our memory-driven knowledge of the past and the possibility of the incursion of other causes in forming the track, both statistically probable and logically tenable. It is indeed tempting to dismiss the skeptical hypotheses regarding the memory-driven retrodiction of the past or predictions of the future observations as uninteresting, But interestingness is only a matter of subjective cognitive bias, and is not remotely connected to the interests of what is actually objective. Returning to our crime thriller example, the objective investigation of the crime scene begins not with the detective linking the trace in the snow with the car's tires based on memory-driven associations in the past, but with the suspension of such cognitive biases. It is only when the detective breaks off from such belief dispositions or entrenched cognitive biases that she can begin to conduct a true detection of the crime scene, thus cracking. 225. Open the secrets of the crime scene beyond the level of associations which are no more than the product of an egocentric subject. Whether the retrodiction of the past is obtained from memory states themselves or from the inductive generalization of our memories, the knowledge of the low-entropy past hits a brick wall when there is no definitive memory of the past owing to one-to-many or many-to-many, rather than one-to-one, correlations between our memory states and the states of the universe. Nevertheless, we can reasonably rely on our modest contextual theories in which our retrodictions of known past observations can be taken to be similar to our predictions of future observations. But the price to be paid for this bona fide modesty, admitting that we have no definitive memory of the past, and that our knowledge of the known qua observed past can never be overextended to knowledge of the unknown qua unobserved past, is the admission that the entropy gradient can increase or decrease as much toward the past as it can increase or decrease toward the future. The probability and logical tenability of both scenarios enjoy an equal rank. One can always attempt to quash the logical tenability of the riddles of induction or, in the case of the 5 minutes ago paradox, resort to the epistemological reliability of the principle of simplicity. But to make a wholesale appeal to the epistemological reliability of successful observations through an argument from the standpoint of the principle of simplicity is like wielding a wooden club and claiming it is a Occam's razor. For the principle of simplicity is only a pragmatically and contextually effective tool. It is neither truth indicative nor is it a law indexing an inherent simplicity in the world that can be invoked in every context. Following Grunbaum, if simplicity or elegance were the best explanations in the toolbox of knowledge, then we should have all abandoned the Darwinian worldview in favor of the theistic one, for the latter boasts a far more elegant simplicity. 164 The same goes for the defense of successful observations put forward through the reliability of our common sense evolutionarily afforded inductive methods. 165 But this Putnamian resolution, just like Hume's, simply defers the problem of the inductive reliability of successful empirical observations to a lower level, sweeping it under the carpet of evolution. To trust evolution in order to trust our ordinary inductive capacities so as to then trust the legitimacy of our epistemic inquiries is only an act of faith in the blind god of evolution, whose gift of inductive reliability should not be mistaken for a supposed epistemic birthright. Evolution may be reliable in its own terms, but its reliable efficacy does not so obviously translate into the reliability of our inductive predictions and retrodictions. Nor, every time we are confronted with a daunting problem, can we invoke THT principle of evolutionary credulity, claiming that, just because we believe we cannot solve a question of an epistemic right on which we so firmly rely, we must presume that evolution should be declared as the source of that legitimacy. Distilling the superacid of epistemological skepticism is essential for rescuing the legitimacy of our knowledge and the coherency of critical realism. Epistemology without skepticism, skepticos as the toil of investigation about the conditions of epistemic possibility is predisposed to dogmatism, and skepticism without the rational ambitions of epistemic inquiry is doubt as debilitation. Yet skeptical investigation should be understood as a series of tasks to be performed one at a time, not an uncritical greedy skepticism assaulting the totality of knowledge and the logico-semantic conditions of judgments en masse. This is not skepticism but a pathological distrust and all-encompassing paranoia that is incapable of sustaining even itself. As Plato demonstrates in Meno, there is no knowledge without doubt, and no doubt without knowledge. The greedy skeptic assumes that what he endorses is only not Q, not knowing that what he truly endorses is the implicit belief that it is the case that P therefore not Q, i.e., a piece of knowledge. On the other hand, the genuine systematic skeptic asks why is it that P therefore Q or not Q? The former is the unconscious consumer of knowledge, while the latter is the self-consciousness producer of knowledge. What now? Let us now reformulate Boltzmann's challenge with regard to the question of time in a traditional philosophical frame. It would be that the genuine problem is not really about the enigmas of the Heraclitean flux, the quandaries of becoming, recurrence, or the puzzles of absolute contingency. Every law is susceptible to change within time. It is rather the question of why there is often an element of time asymmetry, whether disguised in the form of punctual sequential series or duration, in our philosophical reflections about events and processes that make up the pictures of the world and of ourselves. As Smart and Reichenbach have observed, only things become, not events of time. Events happen, and what happens or occurs can be always made tenseless. 166 Events change, but change is not a becoming. Event E happened means that E is earlier than this utterance, V is happening now means E is simultaneous to this utterance, and V will happen means that E is later than this utterance qua token. This is what Reichenbach calls token reflexivity. 167 And at the level of token reflexivity there is no implied or essential time asymmetry. Arguments via the specious present or Husserlian retention protension cannot faithfully answer this question either, nor can they corroborate the component of time asymmetry even within subjective time. For even though, in our consciousness, now as a matter of fact shifts, since there is a diversity of now contents, and now contents enjoy a temporal order, it would be dubious to draw the conclusion that, just because the now contents stand in earlier than and later than relations to one another, this means that the now moves from earlier to later. Moreover, the mere diversity of now contents does not in itself supply synthetic content to the claim that time flows or shifts from the earlier to the later. In this regard, even phenomenological time consciousness or subjective time appears to be time asymmetric only psychologically. In Grunbaum's words, the time asymmetry of phenomenological time can be said to be psychologically ad hoc. Moreover, the idea of melody or durational awareness cannot even be deduced from a possible isomorphy between the succession of cerebral traces, or memory traces, as for example in analogy with time-tagged marks on a tape recorder, and the succession of states of awareness. All that is implied by such physicalist isomorphy between brain traces and states of awareness is the succession of awarenesses, not our instantaneous awareness of the succession as a distinct element. As we saw in the previous chapter, per Kant, the sequence of representations of items or the representation of representations is not the same as the representation of the sequence. We can employ this argument here as well. No amount of successive states of awareness can yield something like the instantaneous awareness of the succession, which is the meaning of the transient now as the unit of time consciousness qua temporal flux. Thus if the diversity of now contents does not by itself corroborate the unidirectional flow of time, and if what demarcates the distinction between past and future in contrast to merely successive earlier thence and later thence is really the transience of the specious present, where the sequence appears to be running in one particular direction, then exposing the consciousness of now as a psychologistic conception amounts to revealing that temporal becoming is, in its entirety, a psychological impression at worst, and a necessary pragmatic representation at best. Therefore, far from being an index of reality independent of conceptual mind or even empirical consciousness, the flux of becoming is a register of a purely perspectival awareness. The coming to be or ceasing to be of an event is nothing other than the entrance or departure of an effect to or from the immediate awareness of the organism or the human observer who experiences the course of events. 618. It may be argued that the awareness of changes in present tense consciousness engenders the experience of temporal becoming. 169 Adding that as events or moments become successively present, then past, a direction of time inevitability arises in experience. 170 The first part of this argument can be countered with the question, how or whence exactly does the succession of awarenesses, the mere sequences of earlier thence and later thence, acquire its synthetic content with respect to the flow of becoming? As argued, by itself the succession cannot supply the synthetic content that time flows from the earlier than to the later than. In response to the second part of this argument, it should be pointed out that the idea that the frequency of successive awarenesses of events in the world can either corroborate temporal becoming or give rise to the perception of temporal flux is an unwarranted inductive thesis, if not a fallacy. 171 Furthermore, the claim that the frequency of successive awarenesses inevitably generates the instantaneous awareness or the perception of the flux of becoming, precipitates a far more serious problem. If the frequency of successive awarenesses are by themselves sufficient to give rise to the consciousness of temporal flux in experience, then it means that the subject of experience is no more than a Humean bundle of sense impressions. This is self as a mere aggregate of states or perceptions in the specific Humean sense, where perceptions are either prior in the order of knowing to the apperceptive self, or lack any apperceptive unity and hence are nothing but the relations between things in themselves. If self is only a bundle of impressions or awarenesses, then the whole array of references to the subject and the concept of experience becomes redundant. Even an inorganic tape recorder can mark and preserve the recording of events in a successive manner, but it would be rather content-ious to claim that the tape recorder has subjectivity, experience, or consciousness of the temporal flux. But as Kant argued, against Hume, the apperceptive self is not merely a bundle of successive impressions. Impressions are organized and integrated by rules which are not derived from experience, with the emphasis on derived rather than experience. Moreover, adopting and modifying McTaggart's argument on the Humean bundle, 172 in the absence of apperceptive unity as the principle of experiential unification, every bundle qua self can be arranged into infinitely many bundles qua selves. Thus, a Humean self as a bundle is in fact a collection or a multitude of selves qua bundles. Therefore, the accurate term would be Humean selves rather than self, a collection of bundles which may be different or same selves. At the level of a potentially infinite collection of pure bundles, there are no such relations between impressions as spatial and temporal relations, even apparent ones, causal connections, familiarity-unfamiliarity, similarity-dissimilarity, qualitative intensity relations, relations between knowledge of states, or even relations between so-called Humean perceptions. At this level, any two states, for example, phi more familiar and phi less familiar, can form a group. 173 There can be infinitely many groups, each of which can take phi and phi as a member, but by no means does every group form a bundle, since not only can group phi belong to different bundles qua selves, but phi more familiar of bundle and phi more familiar of the bundle too can also form a group. Consequently, in the pure bundle view of the self, any two states can form a group, but there is no non-arbitrary way to distinguish those groups that are bundles and thus exhibit some uniformity of awarenesses, from those which do not. At this point in the argument, we could adopt a Kantian position and claim that the transition from a sequence of awarenesses of events to the instantaneous awareness of the sequence is the result of the application of a pure concept to the sequences of impressions. That is to say, the instantaneous awareness too of now, or the element of temporal flux in experience, is not something that has been derived from a mere sequence of successive awarenesses but something that has been generated through the application of a rule. This, however, raises a different question: where does this a priori rule come from, what is its source? If the rule is taken to be purely logical, then one is faced with the challenge of resolving the incompatibility of the analytic rule with the synthetic content that the instantaneous awareness of the transient now harbors. As argued above, the temporal flux is essentially endowed with a synthetic content, or in other words, requires an ampliative judgment whose premises are diverse now contents. But if the rule is taken to be synthetic, then its ultimate source would lie in the apperceptive unity of the experiencing subject, that is to say, the principle of experiential unification. In this case, the transition from successive awarenesses to the awareness of succession does not commit us to a metaphysical claim regarding the objective reality of the temporal flux, but only to the transcendental ideality of becoming as something that plays a necessary pragmatic role in the agent's objective description of events and items in the world. This is not say that we ought to forego all metaphysical claims in this case, the metaphysical account of time. The point is not to be quietist when it comes to metaphysics. For it is precisely once we presume that we have purged ourselves of metaphysical assumptions, that we become susceptible to the most dogmatic and veiled forms of metaphysics. The fanatic Kantian critical crusade against metaphysics only leads to an illusory disillusionment as one ends up with a stock of unexamined and unacknowledged metaphysical assumptions. In contrast to this approach, in the vein of Plato and Hegel, the aim is to be concretely self-conscious with respect to metaphysics and indeed strive to develop a robust metaphysical ICS, in this case, a robust metaphysics of time. For a metaphysical system to be identified as robust, it should, 1. Be open to systematic theoretical assessment in the sense of the qualifier defined in Chapter 1, 2. Proceed via the dimension of conceptualization of structure rather than via the positing of an account of reality deemed to be already structured independently of mind. 3. Suspend the prima facie correspondence between the dimensions of reality and the characteristics which our experiences of the world prima facie appear to have. 4. Develop a notion of mind, idea, or Geist whose finitude is suspended since it is sufficiently differentiated from life, bios, or the natural, which is finite in so far as it is subject to temporal time. The true object of such a metaphysics is the infinite and thus the atemporal. In the sense of, 4, metaphysics is developed through a conception of reason that accepts the identity of opposites, i.e., thought and being, subject and object, finite and infinite, while suspending understanding, which is applied to immediate experience and which can only prospectively grasp time as a temporal succession. In this regard, metaphysics coincides with the systematic apprehension of infinity. But this is a concept of the infinite that is not conditioned on the humiliation or abstract negation of the finite, such as, for example, the finitude of the human, in so far as it has sufficiently wrested the concept of the human, Geist, or mind from the temporal order of things. Nor is it a concept of the infinite that leads to cosmological antinomies whose resolution would require a Kantian distinction between appearances and things in themselves, with the latter being itself a dogmatic, or more precisely, non-robust metaphysical posit. Metaphysics properly understood is the apprehension of the infinite without any of the static or fixed contradictions that arise from the limitations of the features of our experience or understanding, which, in contrast to reason, can neither accept the identity of opposites nor forego the representation of the absolute or unconditioned. However, the apprehension of the infinite without contradictions does not mean it is free from all contradictions. There are different kinds of contradictions, and the apprehension of the infinite is only free from fixed antinomic contradictions in the sense that lower-level contradictions are suspended in higher ones so that, at each subsequent level, the lower-level contradictions are avoided. Said differently, as opposed to fixed contradiction, the dynamic movement of contradictions, their suspension is intrinsic to the apprehension of the infinite as the true object of metaphysics. What are cancelled are not contradictions per se but fixed antinomic contradictions at certain levels of discourse. Accordingly, metaphysics is indissociable from the dialectical movement of concepts, or, more succinctly, metaphysics and speculative logic coincide. 233. Not logic in the sense of the ordinary logic abstracted from content or a general grammar qua method pertaining to the forms of thought, but logic as the idea, which is to say thought's own self-developing totality of its distinctive determinations and laws, which it gives itself and does not already have and find within itself. 174. In this respect, Hegel's conception of time qualifies not only as a robust metaphysics of time but also as a fundamental element of metaphysics as such, since it rescues the thought of the infinite from fixed contradictions, and from pernicious attempts at resolving these contradictions, such as Kant's positing of the thing in itself, a veiled metaphysical postulate that is dubiously outside of the dimension of conceptualization, and as such constitutes a pre-critical moment upon which Kant's so-called critical resolution to the antinomies blindly thrives. Hegel develops his conception of time out of his criticism of Kant's formulation and subsequent resolution of cosmological antinomies, particularly the first antinomy pertaining to the physical dimensions of the universe, viz. Whether the physical universe is temporally and spatially finite or not. Weingart has provided a lucid and brief exposition of Kant's first antinomy, and specifically its temporal implication. If we consider the current state of the world, then the principle of reason requires that we infer the existence of all of the prior temporal states of the world that condition its current state. In other words, the principle of reason requires the existence of the world as a whole. Kant notes that this world whole might take either of two different forms. First, the series of past temporal states might terminate in an initial temporal state, i.e., a beginning of the world in time. Second, the series might constitute an actual infinite series of past temporal states of the world. Kant believes that indirect arguments can be given in favor of both options, which yields the contradictory result that the world both has a beginning in time but also lacks a beginning in time. 175. In the context of his theory of time, Hegel argues that Kant's first antinomy arises and is subsequently resolved by the categories of the understanding, a mode of thought that, in contrast to reason, does not accept the identity of opposites and is bound to the transcendental subject of experience. In attempting to apprehend the infinite and to know the absolute, the understanding rejects the identity of opposites, but at the same time implicitly acknowledges the absolute as the identity of opposites, subject and object, finite and infinite. This tension between the explicit rejection of the identity of opposites and its tacit acceptance forces the understanding to see the absolute not as the eternal, i.e., outside of temporal time, but as an antinomic series of successive series of past temporal states which only perpetuates an indefinite regress. Every beginning for the world requires a regress to an older beginning. Since understanding operates within the bounds of finitude, in attempting to know the absolute it mischaracterizes the absolute as a successive series of past temporal events, precipitating the antinomic result that the world can both have and not have a beginning in time. Whenever understanding attempts to know the absolute, it chooses to conserve its limitations, which distort the thought of the absolute, rather than acknowledging its own limitations and terminating itself. It fuses or collapses the distinction between the identity of subject and object, A equals A, and the difference between subject and object, A/A. Only when the destruction of understanding is recognized as an enabling condition for thinking the absolute as the identity of subject and object can the simple or static contradiction, the Kantian antinomy, be recognized as a pseudo-problem. But the destruction of the understanding demands its replacement by reason as a mode of thinking that accepts the identity of opposites and is thus capable of thinking the absolute without generating static contradictions or antinomies. The conception of time as the eternal is but the identity of subject and object, finite and infinite qua the absolute. This conception is the very essence of reason as that which is able to suspend finitude and thereby avoid static contradictions in favor of dynamic contradictions which are intrinsic to the apprehension of the infinite. Whereas the understanding is bound to the forms of finitude, cause and effect, succession, etc., reason suspends finitude in order to arrive at knowledge of absolute idea. This suspension is nothing other than the adoption of a resolutely atemporal viewpoint. We can therefore conclude that only such an atemporal thought can arrive at the truth of geistic intelligence, for, in adopting a resolutely atemporal viewpoint, reason relinquishes the power of time over its idea. The truth of what mind is cannot be found within time, since it is the very truth of time as such. The mind is not in time, it is itself time. The notion, however, in its freely existing identity with itself, as ego equals ego, is in and for itself absolute negativity and freedom, and is consequently, not only free from the power of time, but is neither within time, nor something temporal. It can be said on the contrary that it is the notion which constitutes the power of time, for time is nothing but this negation as externality. Only that which is natural, in that it is finite, is subject to time, that which is true however, the idea, spirit, is eternal. 176. It would be a mistake to consider the history of Geist as a sequence of self-conceptions and self-transformations that happens in time. It is history as time, but not history as a temporal development. Thus, construing the so-called progress of Geist in terms of intuitive notions of temporal development, as is the case with Whig historiographical interpretations of spirit, for which Hegel himself is partly responsible, is a retrogressive move. It is retrogressive because it once again demotes the idea of mind to forms of finitude such as succession. History as the self-actualization of the concept is the idea's own time, a time that is neither opposed to another time, nor is an abstraction of time, nor a time outside of time, but is the eternal or time as such. The totality of the idea of mind cannot be represented temporally, for such a totality will be mistakenly apprehended as the totality of the state of affairs in the past, present, or future. But a totality that is understood temporally is simply a form of finitude that feigns totality and, as such, it is an illusion begotten by a self-limiting thought. Similarly, the idea of the human as a concluded totality given to us here and now as a biological species, and the idea of capitalism as the completed historical totality of all social relations, are posited forms of finitude dissimulating themselves as completed histories. They both distinguish themselves within time as the present/future state of affairs, and present themselves as the totality of all there is and can be. But an extant state of affairs can never be a totality, even if it represents itself as the totality of the present/future. In view of the arguments made above, images of time as an endless flow that underlines the insignificance of the human and its paltry concerns turn out to be anti-humanist veneers upon a subjectivist account of time which, far from breaking from the dogmas of humanism, reinforces a deeply conservative form of humanism. This is a humanism afflicted by a deep-seated transcendental blind spot that not only uncritically posits the local and contingent characteristics of egocentric human experience as the characteristics of reality, but also deems this very anthropomorphic reality, whether under the rubric of pre-individual singularities or ceaseless becoming, to be the horizon for overcoming human exceptionalism. Such metaphysical accounts of time champion an infinite which is more pure altruity than the suspension of the finite. As such, they must both leave the finite intact in order to maintain their altruity and debase the finite as that which does not matter in so far as it is perishable. The so-called finite of such images of time is thought, mind, or the human. But any metaphysical conception of the infinite that belittles and discounts the human as finite will be haunted by human pettiness and its associated limitations. It will be doomed to bear the marks of exactly that which it seeks to steer clear of. 237. Following Parmenides, Plato, and Hegel among others, not only philosophical maturity but also the maturity of the human coincides with the liberation from the servitude to time, the realization that the temporal, whether as a tyrant that devours all or as a dimension of reality in which we appear to exist, is not important. As Russell remarks, a certain emancipation from slavery to time is essential to philosophical thought. The importance of time is practical rather than theoretical, rather in relation to our desires than in relation to truth. Both in thought and in feeling, to realize the unimportance of time is the gate of wisdom. But unimportance is not unreality. 177. This remark can be complemented by McTaggart's rejoinder to Russell's view. This seems to me profoundly true. But the importance of time will be still less, if, as I have maintained, nothing is really in time, and the temporal is merely an appearance. And, as the importance of time diminishes, so also diminishes the importance of the cessation of our lives in time. 178. At this stage in the argument, a more persistent and observant proponent of the flow image of time who is significantly less invested in anti-humanist tendencies might present another cliched objection by putting forward a variation of the following argument: in a world without the flow of time, there is no becoming. Absent becoming, the existential status of the future as the coming into being of events in the world is compromised, since, without becoming, there will be no novel event and no indeterminate future. Without the future as the site of indeterminacy and novelty, there will be no human freedom, no prospects for emancipation. For without becoming, we are living in a wholly deterministic world of mere being. In other words, the metaphysics of becoming reveals a paradoxical dilemma for human action: If there is no coming into being, the future is already determined, and therefore the idea that agents can change their world seems to be absurd, for there is no real freedom, no chance for novelty and difference. Whereas if there is indeed a coming into being of events, then the future is indeterminate, since it is the locus of radical novelty, absolute contingency, or the event. But then our rational planning and anticipatory actions prove to be futile, for they fail in the face of its indeterminacy. 179 They cannot in any meaningful sense gain traction on an ontologically interminable future or the absolute contingency of time. To this extent, the issue of the temporal flux, which is taken to be the essence of time, invariably results in a paradox of inaction. Without it, we live in a fully deterministic world which renders our rational plans and actions irrelevant. With it, we live in an indeterministic world in which our rational plans fall flat in meeting their goals, since the future as the target site of such plans is radically interminable and adverse to our anticipatory actions. But in fact, whether or not becoming is an aspect of time independent of human consciousness has no bearing upon the issue of determinacy. The question of interminism versus determinism can be formulated as the question of the difference between past and future. In an indeterministic world such a difference exists, whereas in the deterministic world it does not. But, as we saw, the difference between the common-sense past and future as opposed to the metric description of physical events as past and future states is the now of the experiencing ego. Accordingly, the problem of interminism or determinism as the difference between past and future or lack thereof is of no relevance to physical events, since such a difference is nothing but an expression of the egocentric consciousness of the human. As Grunbaum has argued, in both a deterministic world and an indeterministic world, the coming into being of a future event or the ceasing to be of a past event signifies nothing more than the entrance or departure of its effect into and from the immediate awareness of the apperceptive ego. The difference between these two worlds with regard to future events only concerns the type of functional connection linking the attributes of the future events to those of present or past events. But this difference does not make for a precipitation of future events into existence in a way in which determinism does not. Nor does interminacy make for any difference whatever at any time in regard to the attribute specificity of the future events themselves. For in either kind of universe, it is a fact of logic that what will be. 180. Furthermore, the objection that resulted in the paradox of inaction is based on the confusion of two entirely separate issues. One is the epistemological issue of sifting the actual properties of events in the future from a larger set of possible properties. Per Grunbaum, we call this the issue of the epistemological precipitation of events and their properties into our awareness. 181 This is to be distinguished from existential precipitation, i.e., their coming into being, or realization. Epistemological precipitation is certainly influenced by the passage of time through the transformation of a statistical expectation into a definite piece of information. 182 However, this does not mean that there is only existential precipitation with the passage of time in an indeterministic world, or that there is no epistemological precipitation with the passage of time in a deterministic world. Finally, the objection that in a deterministic world there is no real freedom rests upon a muddled account of causation. If a system is caused to be in one state rather than another, this does not mean that the system's trajectory is compelled this cause. Similarly, if future states are caused by past states, this does not mean that the future state is compelled by the past state. It only means that the past states have causally contributed to such future states. In other words, determination in this sense is about being caused, but being caused does not mean being compelled by the cause, i.e., determinism as some sort of causal compulsion. Let me elaborate on this point a bit further. It is true that, in order for a system to be in the state it is in, it must have by physical necessity followed on from an antecedent state. The system could not come to be in its subsequent state were it not for an antecedent state. But this is not the same as saying that the current state of the system is caused by a foreign cause. Certainly, the present state of the system is the physical consequence of things done to it, i.e., the history of its past interactions, but this, as Sellers points out, does not mean that the explanation of the present state of such a system lies entirely in other things. Point 183. The idea that causal determinism as distinguished from logical determinism, which is a different issue, implies lack of freedom, is the result of a misunderstanding of what causal determination means. That is, it is a result of interpreting causation as being under the compulsion of a cause. For example, I hate the color red because in the past I have witnessed a murder scene full of blood. Firstly, as argued earlier via Stenrealer, the belief-laden emotion that the state hate, red item, is caused by such and such factors in the past is a psychological account of cause and effect, since there may be many factors not available to my awareness which could have brought up the state hate, red item. This is not to say that there is no connection between my emotion or belief and the past trauma, but that such a connection cannot be defined in terms of singular cause and effect, since the schema of causation is psychological rather than scientific. Even if we lend some credence to this prescientific schema of causation, having the emotion hate, red item, does not suggest that an antecedent traumatic scene has compelled me to have such emotion qua belief as opposed to other emotions qua beliefs. All it implies is that there is a certain causal contribution in my having such emotion qua belief. In other words, hate, red item, may indeed be a reliable belief insofar as it has been constrained by a certain causal factor in the past, and that may be why I have hate, red item, and not love, blue items, or hate. See liquid items. Put differently, all causal determinism implies is that our beliefs about the state of affairs may be reliable to the extent that there is a component of causal efficacy that has determined them, or, in other words, they are constrained by some definitive causal factors. However, it does not imply that we are under the compulsion of such causes. When I come to assert this is an emerald, it is because my belief is constrained by the presence of hard green stuff, the causal factor. I may indeed be wrong, for the item in question might not be an emerald, nor green, nor a stone. But any counter-assertion to my claim equally relies at a basic level on a belief that is causally constrained. Without such a causal constraint, every belief about this hard green stuff could be true, which is another way of saying that no such claims are true. Causal determination is what undergirds the reliability of our claims or beliefs and, correspondingly, our freedom to retrospectively correct them. For example, from this is an emerald to this is well-watered grass, or this is a yellowish goo. Without causal determinism, there is no way to determine whether our beliefs about the world are true or not. That is to say, without causal determinism, we can never tell whether our beliefs are arbitrary or not. The assertion that causal determinism denies freedom of thought or action is based not only on a prescientific account of causation but also on a conflation of causal contribution with causal compulsion. Coming back to Boltzmann's challenge to the temporal perspective, the still pressing question is that of the extent to which these alleged time asymmetric elements in our time consciousness have stretched over and biased the matter of factual characteristics of reality. When characteristics of reality happen to share or match the contingent characteristics of local experience, one ought to question them rather than taking them for granted. In line with the total assault of scientific investigation and critical rationality on our most well-cherished and established intuitions, why should we expect the characteristics of reality to be a trivial extension of characteristics specific to the temporal causal perspective of the subject? Why not instead investigate alternative models, which may have been rejected on the basis of not looking natural from the perspective of our time asymmetric assumptions, and experience models which, while compatible with local temporal and causal perspectives, do not privilege one perspective over another? These are models that should allow for an enlargement of the field of experience and observation without denying the temporal experiences accessible to us or some other contingently posited local observer/subject. The local global non-triviality of reality means that localities of this reality stand in non-trivial projective relations to one another, not that the non-trivial total space of reality trivializes the localities of experience or that it is constructed by something other than what is local in this total space. This is much more in tune with the pragmatist account of the time-conscious agent, for which anthropocentricism in the use of temporal concepts is justified and even pragmatically necessary, so long as there is no metaphysical reification of these concepts as global characteristics of objective reality. To summarize, the pragmatist view of time-conscious agency should be consistent with a model of time which, while refusing to characterize it as temporally unique, admits the local consistency of any possible model of experienced temporality and causal perspective such as ours, and hence in an oblique way justifies the use of temporal concepts. In other words, a robust model of time should be an expression of a reality that constitutes local temporal perspectives without being reducible to them. Thus, reencountered within this model, our temporal perspective should be seen as a local self-expression of an absolute, atemporal, reality, rather than being dismissed as a complete illusion. Liberation from a model of time restricted to a particular contingent constitution does not rob the subject of its cognitive and practical abilities, but releases it from the shackles of its most entrenched dogmas about the necessity of the contingent features of its experience. In doing so, it sheds light on the prospects of what the subject of experience and the exercise of change in the world is and can be as it cognitively matures. The transition to a state where one is no longer afraid of being lost in time, having come to the realization that time accommodates no one. 243. Should be celebrated as the sign of rational maturity, rather than decried as a manifestation of the subject's impotency. It is in continuity with the critical attitude of rational agency to adopt a model of experience that can interrogate the most natural and established facts of experience rather than corroborating them via the so-called fact that these are simply the ways in which we experience the world. As the extension of this interrogation, such a model should also enlarge the field of our experience, and in doing so, should theoretically and practically challenge popular yet puerile ideologies built around either a temporal account of progress or the second law of thermodynamics. Regardless of whether Boltzmann's challenge as presented here requires extensive refinement or not, it can be seen as a Hegelian radicalization of Kant's thesis on the transcendental ideality of experienced temporality. It is a radicalization in the sense that it is both an exacerbation and an extension of the implications of Kant's thesis. It is in line with this philosophical viewpoint, and in tandem with his strategy to eliminate or at least mitigate the fundamental biases of the directional dynamic picture of time within modern physical sciences, that Boltzmann begins to explore the ramifications of adopting an atemporal perspective. But the fallout of Boltzmann's time bomb 184 is not limited to the modern sciences, its implications reach as far as philosophical, scientific, and socio-political ideologies built around the concept of entropy, or more precisely, positive entropy production. Having cursorily glanced over the far-reaching implications of Boltzmann's radicalization of Kant's thesis on the transcendental ideality of time qua experienced temporality, we are now faced with three challenges, the responses to which will shape the project of maintaining and expanding the intelligibility of agency. 1. How can we envision models of agency that might have fundamentally different senses of time by virtue of enjoying different local conditions of observation, possessing different structural behavioral organizations, i.e., different modes of responsiveness to the impingement of items in the world on their senses and different constructive anticipatory models of memory, or, on the conceptual level of time consciousness, having different logical connections between temporal connectives of language or different structures of tensed verbs. A different experienced time order here should not be construed as an index of difference for the sake of difference. It is different only in that it should enlarge the field of experience, and thereby enable the vector of cognitive discovery both at the level of theory and that of practice. This is as much a challenge to think agency beyond a particular set of contingencies as it is a research question for envisioning an artificial model of agency not essentially bound by our local limits. 2. Could there be models of time that are compatible with the subject observer's temporal causal perspective while not privileging or overstretching this local perspective into a canonical global model? How can we lay out a physics of our temporal causal perspective that explains its characteristics without reinscribing the same perspectival characteristics as features of objective reality, and thus positing them as explanans of what is already an explanandum. To this extent, the second challenge is concerned with a systematic inquiry into models of time and time consciousness that can, a. account for the characteristics of our temporally oriented perspective, and b. resolve the problems within the directional dynamic picture of time, namely, the quandaries and paradoxes, from enigmas of change and temporal asymmetry to paradoxes of causality such as retrocausality, that originate from the inadequate descriptive explanatory resources of the directional dynamic model of time to which we are so unconsciously accustomed. 3. In line with the first and the second challenges, the third challenge centers on the problem of reconciling the pragmatic import of our 245 temporal view with a model of time-conscious experience that is neither necessarily directional nor dynamic, which neither pictures time as a flux nor takes for granted our experience as advancing from the past toward the future. What are the ramifications of a non-directional/non-dynamic model of time consciousness for our existing theoretical and practical models within not only the physical sciences but also the social sciences? And more importantly, what can be gained, theoretically and practically, by adopting alternative models of time consciousness, and specifically an atemporal model? The third challenge is in fact the continuation of rational agency's struggle for self-conception and self-transformation, for a release from any residue of essentialist attachment to a particular transcendental structure of experience. In adopting a view from No. 185, a view that explains any mode of experienced temporality without being circumscribed by their particularities, we embark on a necessary task required for the realization of what Hegel calls absolute spirit, moving from particular, contingent consciousness to genuine self-consciousness. The view from the space of reason qua concept, Begriff, is not only a view from nowhere the impersonality of reason but also a view from no when the pure formlessness of time that is expressed by discursive rationality as a project that takes time. As we shall see in the following chapters, this time generality will take the form of Plato's ideas, knowledge, truth, beauty, and above all, the good. History is an ongoing process of totalization under the aegis of the concept, and the form of the concept, not its content, is atemporal, if not timeless. Directionally temporalized history represents the ultimate limitation imposed by intuitions, or the fundamentalist attachment to a locally constituted experience over the form of the concept and thus that of history. Once we unconditionally cast off this forced limitation step by step, dismantle this cursed raft plank by plank, history transforms into a medium for the expression of time as the formlessness that conditions any possible form. We have tried to understand and make sense of the world in which we acquire a perspective on ourselves, the meaning of mind, and intelligence, by analyzing it internally. But maybe the best solution is to go entirely outside of this world and analyze it from a viewpoint that is both possible and fecund with further possibilities. And yet for this transition to the outside view from nowhere and no when to be concrete, we must grasp it as a circuitous path of arduous task upon task. This adventurous yet demanding umwege is the course of the critique of transcendental structures, spanning different methods and frameworks of theory and practice, from science to technology, art, general pedagogy, politics, and so on. It would be pitifully naive to think that we can liberate intelligence by means of technoscience alone without changing what and how we think about who we are, and correlatively what we think of, in comparison to ourselves, as intelligent. Changing the latter is a question of attaining a veritable self-consciousness of who we are and what we ought to do. And this change comes at a price which is the complete alienation of the human in itself, that we will never settle, we will never mistake anything for our home, for we have come to the understanding that the very vector of alienation exodus between possible worlds is actually our home and the source of what is good and satisfying. It would be equally credulous to believe that, in the course of such an enterprise, we will be able to maintain the conception of the human rooted in how we experience ourselves here and now. As the umwegen to the outside view of ourselves revises the very experience of who we think we are, we become that which no longer experiences itself in terms of what we experience ourselves as in this very moment. For an intelligence with a larger field of experience than ours, what the human means or what the appellation we stands for no longer abides by the terms of our epical particular field of experience. We become only an antecedent condition to what is necessarily us, that is, the form of the us, which is neither a transitory content nor an ephemeral particular object. Ultimately, genuine self-consciousness turns out to be the view of ourselves from no-when, and the world conceived concretely from a view that is of. 247. Nowhere and no-when is a world that at once is replete with possibilities and is possible, one whose possibility is no less actual than the actuality of the inhabitable world we currently inhabit. The actuality of our world is merely an abstractly determined absolute, a sediment totality that feigns completion of the absolute, but the actuality of possible worlds conceived from no-when and nowhere is the absolute as the concretely determined, never given in what appears to us in time but procured through the cunning plot of history to explore the meanings of time. From a Kantian perspective, in taking up the third of the challenges outlined above, we come closer to fulfilling the central goal of critical philosophy, that is, demonstrating the mutuality of the rational self, discursive apperceptive intelligence, and the world without eliding the distinction between the thinking of the former and the being of the latter. 186 Our toy model automaton is now equipped with a spatially and temporally perspectival awareness. In other words, it has developed the capacity to handle space and time, the object, required for the rudimentary organization of an encountered item, an appearance, in the world that is, an object, Gegenstand, as distinguished from other items. However, at this point, both object and Gegenstand are mere analogical correlates of our objects of thought, object, and categorically determined sensible objects, Gegenstände. They are neither objective, factual or intersubjective, nor subjective, in the full-blooded sense of the subject as one who is in a position to make veridical claims or critical judgments, rather than a thin notion of subject as that which, de facto under the rudimentary transition laws of imagination is able to discern uncritically empirical associations in the order of appearances. The achievement of subjective and objective thoughts requires that the automaton advance from rudimentary capacities, abilities carried to advanced abilities, abilities to. To enable it to do so, we must equip our automaton with a new structure, not a structure that belongs to the automaton itself, but one it is plugged into or bound up with, namely the structure of a community, a multi-agent system such as a framework in which multiple information processing systems are constrained by their dynamic or concurrent interaction with one another, i.e., every system is the environment of the other systems. We must therefore introduce two modifications to our picture. The first modification is simply necessary, whereas the second, although in essence necessary, could be introduced in forms other than that depicted in our toy universe. The automaton is now a part of a multi-agent system comprised of automata with a differential responsiveness to the items in the world. In its most basic configuration, the multi-agent system is designed to enable interaction between automata/agents as a way of increasing the probability of goal attainment. This multi-agent system is then introduced into a specific environment wherein agents have to interact not only with one another, but also with the features of this environment. Inter-agent interaction is, accordingly, coupled with the dynamic inputs and constraints of the resulting ecology. The automaton is now furnished with built-in electromechanical devices whose coordination results in the production of quasi-continuous sounds. These quasi-continuous sounds are the primary means of communication between automata. In an alternative toy universe, this feature could be implemented in different ways that might not necessarily involve sound. However, insofar as this is a component of our particular toy universe, we have to abide by its characteristics and constraints. Chapter 2 ended with the automaton endowed with the capacity of meta-awareness, or the causal analog of inner sense or inner perception, the capacity of the mind to be affected inwardly and passively by its own thought episodes, to report representations of items and occurrences in the world to the mind as temporally organized rudimentary representations which are the mind's own presentations. But the automaton's inner sense was merely de facto. In other words, the automaton wasn't aware of these occurrences as its own, nor did it have thoughts in any meaningful sense. Indeed, even if this inner sense was not causal, even if the automaton did actually have thought episodes at this level, the passive capacity of inner sense could not, pace Descartes, supply the automaton with the synthetic awareness that these inner thought episodes or meta-awarenesses are its own. As we cursorily surveyed in Chapter 2, such meta-awareness requires the active power of apperception rather than just the passive faculty of inner sense. Only when the passivity of its inner sense is brought under the apperceptive eye as an active logical form, rather than, as in Descartes, a substance, can the automaton have anything resembling thoughts in even the minimal sense. The apperceptive eye is synchronically attached to all instances of representations, I think X, I think Y, I think Z, and diachronically extends over all thoughts, I think X plus Y plus Z. But if we are to build this synthetic apperceptive eye as a necessary abstract and logical form, we have no choice but to finally depart from Kant's account of the apperceptive self, which Hegel reproaches for being an empty transcendental subjectivity, and to instead adopt a resolutely Hegelian approach. The apperceptive self is only a cognitive self insofar as it is part of Geist. An individual is only an individual to the extent that it is individuated by social recognition, which is the form of self-consciousness. This logical self is at once one and many, and, as if to prove this, it can only be constructed, as we shall see, by way of a confrontation with another /*187. To recapitulate, our aim is to elevate the automaton from being an agent that de facto possesses the meta-awarenesses of inner sense to one that is inferentially, synchronically and diachronically aware of having meta-awarenesses, from representations that are only causally and passively its own to an ideological form that actively accompanies and integrates such representations as its presentations. In short, the goal is to bring the automaton to a state where it not only has experiences and thought episodes, but where such experiences and thoughts are de jure and by entitlement its own. The modifications we have made to the automaton are precisely the kinds of adjustments that will enable the automaton to make this transition. Since our automaton is now part of a multi-agent system, for the sake of efficiently tracking its course of development, we can designate it with a proper name, Kanzi.188. As a part of our multi-agent modification, we will also introduce two other automata and assign them proper names, Su and Matata. Su and Matata differ from Kanzi in that they are sapient automata that have mastered the use of language. In a nutshell, they are fully fledged concept using adult guardians of Kanzi. In this configuration, Su and Matata recognize and nurture Kanzi as what Rosenberg terms a child, concept having intelligence of low degree. 189 As a child, Kanzi also has a universe of its own, an infantile world, intelligible familiar appearance naively taken in lieu of the external world. Let us denote Kanzi and its adult guardians respectively as K, S, and M. We now have the necessary resources to follow Rosenberg's Kant-Sellers-inspired model of the transition from inner sense meta-awarenesses to thought episodes, or from an automaton with pure perspectival awareness to a child automaton. K is endowed with behavioral dispositions. It has memories, interests, and anticipatory models which reflect the repeated impressional invariance of how it has seen J and encountered the world so far. K is a creature of habit, i.e., of invariance derived from its rudimentary organized sense impressions or perspectival encounters with the world. Its representations and reliable responses to the world follow transition principles conditioned by how it has encountered the world so far. In this sense, its transitions from one awareness to another, example from T0 bej B1 to I0 B2, are analogically posited WR material inferences which are defeasible and formally incomplete. A case of a context-sensitive, defeasible, and formally incomplete material inference would be, if the match was lit then it must have been rubbed against a frictional surface, but it could also be the case that it was lit because it was hit by an electric spark, or, if the match were in a vacuum, it would light but the stick would not burn, etc. Like material inferences that open up a non-monotonic space of entailments, these protocol-like transitions also have their non-monotonic entailments. if A in circumstance Cj then B, if A in Ct then D, or if B then A in C, and not Ct, etc. However, the range and complexity of K's transition protocols are limited not just because their contexts are always restricted to circumstances that are of immediate sensory behavioral interest to it, but above all because K has no conceptual resources. In particular, K does not have anything resembling modal concepts such as nomological relations and counterfactual dependencies, which are both context and resource sensitive, example AVBA, CSB, or A, D, DBA, D% plus B, where caret is a counterfactual consequent relation. Point 190. Coming back to the match example, the context and resource sensitivity of the counterfactual consequent relation between the non-lit match and the lit match can be expressed as FMH, MS, sulfur MH, oxidizing agent MH, strike MH against a frictional surface caret way lit MH registered burning MS. Where MH is the match head, MS the matchstick, the singleton weta control set which constrains the soundness of the sequent formula and the tensor product, and the compounding operator registered signifies the combination of a lit match head and the burning matchstick provided that the context T does not contain wet. The context T is essentially a descriptive context in the sense that it includes the description of what a match is, empirical judgments about the properties and nomological relations of what can count or behave as a match. If we add additional premises, qua resources, subtract existing premises, or change the control set, and hence the context, the hypotheses of the formula may change. R, MH, MS, sulfur MH, oxidizing agent MH, strike MH against a frictional surface, vacuum lit MH0 not burning MS. In the latter formula, remove the premise oxidizing agent MH and the consequent will change to not lit MH registered not burning MS. The introduction of this kind of defeasible non-formal inference is precisely what makes it possible to incorporate the unanticipated or contingent into the sphere of reason, in the form of a consequent that is not fixed, but is revisable given any change in its antecedents or context. Point 191. Now add a premise with a different context, example short matchstick A of the descriptive context A pertaining to the size of the match, i.e., a match with a different shape. The addition of this premise does not change the consequent. We can, therefore, say that a good material inference, in this case, about lighting a match, exhibits and is defined by a range of counterfactual robustness, i.e., a dry matchstick whose head is made of a combination of sulfur and an oxidizing agent. Would still burn if the size of the matchstick were different and if it were ignited in the Earth's atmosphere, but if it were lit in a vacuum, only the match head would burn. And here the counterfactual robustness depends on the descriptive context T, in relation to the control set S, which can only be obtained through modal vocabularies required for explaining what counterfactually robust properties and law-like relations X ought to have in order for it to be described as a match. Point 192. The control set S can be generally defined as a finite set of finite multi-sets of context formulas Ri, R2, Tw such that for all 1n, FCA registered, where A is a set of precontexts. Correspondingly, the context T can be defined in terms of A and under the condition that if Nx, Rito are precontexts then, Ni, Nra, is a precontext. The context T is an ordered pair, it/, where / is a function assigning a control set to each node of the context tree T and not its branch nodes. Point 193. Lacking alethic modalities of possibility and necessity, subjunctive and counterfactual conditionals which codify causal relations. 194. The transition protocols of the child Kansas impressions of the world are much like the philosophical world of a fanatical empiricist who thinks he has stumbled upon some base empirical vocabulary with which he can describe and explain the furniture of the world, not knowing that the transition from explanandum to explanans is always entangled within a modal web of relations and implications, and is inconceivable outside of this web. In Brandam's words, Just how they would want to know did what seemed most urgently in need of philosophical explanation and defense suddenly become transformed so as to be unproblematically available to explain other puzzling phenomena. Surely such a major transformation of explanandum into explanans could not be the result merely of a change of fashion, the onset of amnesia, or the accumulation of fatigue. But if not, what secret did we find out, what new understanding did we achieve, to justify this change of philosophical attitude and practice? 195. Lacking modal vocabularies, the extremist empiricist K's entrenched statistical regularities are limited to transition protocols, or proto-inferences, such as each time K sees J a protruding mass of fuzzy gray, GY, contacting a heap of black, BC, it hears J a shrieking noise, 4, K, GY, BC **N. And since these transitions have their own corresponding basic precluding or inhibitory transitions, K also has conditioned preclusions or transition obstructions. The mass of fuzzy gray retreated behind the heap of black, BB. The mass of fuzzy gray did not cease to exist, nor is it in front of the heap of black K, GVBB, not GVBF. However, K does not have available the transitions or obstructions modally encoded or embedded in counterfactual situations such as the following. If the mass of fuzzy gray were not coming into contact with the heap of black and another mass of fuzzy gray, G2, were appearing, there would be a shrieking noise, K caret, G2, not BC plus or minus plus N. Nor does K have anything like an account of causation since, once again, it has no grip on the modal relations that codify causal ones. It has contact with the heap of black shrieking noise from the direction of the mass of fuzzy gray, but not contact with the heap of black C0 a caret E caret mass of fuzzy gray to make shrieking noise. Aside from having a small universe of transitions and precluded transitions between its dispositional awarenesses, K also naively takes its meta-awarenesses, or meta-representings, as evidence of a corresponding state of the world or of an item. Put simply, K's impressions of the world are naive because it takes conditioned transitions between its awarenesses to stand in a one-to-one relation with transitions in the states of the world. It is thus predisposed to take everything at face value, to presumptuously infer from its world awarenesses. I0 B1, B2, B3, or, I0 was, is, or will be. Their corresponding constituting awarenesses qua meta-awareness / meta-representings. I0 Bex / B2 / B3 Bel 5 B2, B3, or, I0 was / is / will be was, is, or will be. And vice versa, to infer from each constituting awareness a corresponding world awareness. Accordingly, as well as being a naive empiricist, Kanzi also happens to be a naive idealist, taking its familiar constituting awarenesses for what is actually going on in the external world. Therefore, K's infantile world is susceptible to Cartesian scepticism to the extent that, if everything concerning the external world can be inferred from apparently immediate constituting awarenesses, or occurrent thought episodes, i.e., what is going on in Kanzi's head, then K might also infer that there are no items of the external world, and indeed no external world at all. In fact, K with its infantile world is properly speaking a child of Descartes' universe of mind, where not only is the mind mistakenly regarded as a tabula rasa, but the immediacy of meta-awarenesses and their one-to-one correspondence with world awarenesses leave much room for skepticism about the existence of an external world. In this scenario, K's caret bej / B2 / B3 B1, B2, B3 are from our perspective the analogical counterparts of Kanzi's own occurrent thought episodes, that is, I think I0 Bex, B2, B3 *. In other words, K's de facto I0 B caret Bex is analogically K's own mentioned or quoted I thought, i.e., K, I think I0 Bex *. Similarly, I0 Bex B2 is analogically K, I think I0 B2, as in K, there is a mass of fuzzy gray approaching *, and so on. These instances of and are nothing but the occurrences of a non-substantive apperceptive I that synchronically accompanies all of its distinct thought episodes, I think X, I think Y, I think Z. But since, as discussed in Chapter 3, K's meta-awarenesses are only meta-awarenesses insofar as they are part of a web of equivalence relationships extended through time, the non-substantive I that synchronically accompanies each meta-awareness is formally identical or equivalent to the non-substantive I that diachronically accompanies all combinations of meta-awarenesses. This I that thinks X, thinks Y, thinks Z is the I that thinks X plus T plus Z and without whose logical form there would be no thought episodes and no experience. In other words, the diachronic and apperceptive I think X plus T plus Z, is the sufficient condition for the possibility of having thought episodes or synchronic is, I think X, I think Y. The network of equivalence relationships between meta-awarenesses and their corresponding world awarenesses is what Kant identifies as the manifold of given presentations. The diachronic I is the formal unity of consciousness in which thoughts of X, Y, and Z are combined, the I who thinks X, Y, Z equals the I that thinks X plus the I that thinks Y plus the I that thinks Z, point 196. But as we saw in the first chapter, this formal unity of consciousness, rather than consciousness pers, is precisely what is afforded by the movement of self-consciousness, the I equals I, or more accurately id map J id map J. It is only in virtue of the recognitive space of language that there are apperceptive cognitions. And correspondingly, it is only through the movement of self-consciousness, which extends from one consciousness to another through the public semantic space of language, that there is a diachronic unity of consciousness and a synthetic unity of apperception. The I that thinks is the encapsulation of this formal movement in which ordinary consciousness is caught up. The apperceptive I is neither an empirical self nor a phenomenal self-model nor a field of awareness, but a necessary formal condition brought about by a recognitive movement through the space of language. Anything and anyone who fulfills this formal condition is not only a person but also the bearer of thoughts. For us to posit such a connection between the I that ate the hot dog and the different instances of I attached to the gustatory acts of eating ingredients, we cannot resort a la Hume to empirical evidence. Example, the person who ate the bun and was of such and such empirical characteristics is also the same person who ate the dog and ketchup by virtue of having the same characteristics. Nor can we conjecture a la Descartes that the instances of the I that ate the ingredients are the same as the I that ate the hot dog in virtue of the substantive persistence of the I over time. Kant's critique shows that such a connection requires something more, a time-conscious judging subject or the analytic unity of apperception which brings about the possibility of combining objects of different acts of thinking or in this case eating into one single complex. However, this analytic unity is itself dependent on a synthetic unity of apperception since the synthesis or integration of different intuitive representations under one concept, or several concepts under one higher integrative concept already implies the priority of the synthetic unity of apperception. Only insofar as I can synthetically combine the manifold of sensibly intuition and be conscious of the unity of this act of synthesis can I also analyze this manifold, dog, ketchup, bun, into different concepts and a more universal concept, the hot dog, in one and the same critical consciousness. 259. So far we have discussed what the world of Kansa could be like had Kansa reached the status of a child, but it hasn't yet attained this goal. We shall follow Rosenberg's path in order to turn this into reality, while at the same time making necessary modifications in tandem with the Hegelian revision of Kant's transcendental subjectivity. To achieve this objective, necessary modifications have been made, the introduction of S and M as language using adult guardians. For now, K has de facto rudimentary transitions between its constituting awarenesses. In other words, it has an analogical counterpart of the Uhrenpharynx between the orders of before and after, example what was encountered and what is now being encountered. In order for K to distinguish the orders of before and after and to incorporate them into a growing space of implications regarding one and the same world, it must integrate its meta-awarenesses under one formal synthetic unity, one and the same I. To satisfy this necessary condition, K must model its private meta-awarenesses on a public and deprivatized language. In other words, it must interact with S and M as two fully fledged linguistically competent agents. At this point, however, for the pre-linguistic ik, its fellow automata S and M are not speaking subjects, they are items of the world that not only satisfy its dispositions, but also reward and cultivate its new developments, its moves against its dispositional routines. As such, S and M are not just any items, but especially salient ones. Their linguistic utterances, from K's perspective, their engaging and exciting noises, are also of the utmost interest, as if they conveyed something important. In this scenario we can talk about linguistic interaction between the pre-linguistic K and its linguistic guardians as communication, but with the proviso that, were K also a language user, we could not use the term communication, for linguistic interaction is precisely not communication. Within this communicative regime, the noises qua utterances that S and M make are for Kanzi analogically speaking instances of saying something, conveying something important that may be false or true. But at this time, it takes everything at face value, it believes everything it is told. So to speak. For K to understand or, more accurately, to hear these noises, it would have to be aware of them as representations, of importance, and not just simply as noises, since these noises are precisely at least at this stage in contiguity with its dispositional interests. More accurately, K hears such noises as representations because they are in contiguity with, or rather, because they fit its dispositional or conditioned world representings. Accordingly, for K to hear too the communicated noises as representations would be for it to make sense of or to understand the junctional role they play in its world representings and the rudimentary conditioned transitions between them. 197 This functional role is the meaning, semantic value, of these noises or utterances which are mapped onto K's meta-awarenesses or awarenesses of items in the world. To put it simply, for the conditioned Kanzi, Su and Matata's exciting noises communicate something of importance to the extent that they are in continuity with the dispositional transitions between its meta-awarenesses of interesting items in the world. In other words, K's world is inductively biased, first and foremost, by the items of interest that satisfy its behavioral regularities and dispositions. To the extent that K's transition protocols are inductively biased in such a manner, K also tends to recognize and respond to any communicative noise or representation that can be incorporated into its inductively biased world. And by virtue of this space of shared recognition between Kanzi and its adult guardians, all of K's awarenesses, meta-awarenesses, and their corresponding transitions, what leads to or precludes what, are now also implicated in the expanding web of S and M's representations, that is, the sayings and doings of its constantly appraising language-using guardians. Imagine again the example drawn from 2001, A Space Odyssey. K sees a mass of fuzzy gray moving from the right of the heap of black at time tx to the left of the heap of black at time t3. At time t2, the mass of fuzzy gray disappears behind the heap of black. In our multi-agent scenario, Su and Matata are to the left and right of the heap of black, i.e., the monolith. S and M tell K that the fuzzy item, the monkey, is moving from the right of the monolith to its left, and, sometime between these two occurrences, the monkey disappears behind the monolith. To K, S and M's reports look like this. At TV the fuzzy item moved from the right of the heap of black to its left, item T. At T2, the fuzzy item moved behind the heap of black, item T2. At TI, the fuzzy item is to the left of the heap of black, item T3. As a creature of dispositional regularities and interests, K is able to recognize these reports and, additionally, to map them to its own de facto meta-awarenesses. Consequently, K now acquires labeled meta-awarenesses. They are labeled because they have been received by S and M as contrastive reports mappable to K's meta-awarenesses, or, more accurately, as reports that play a functional role in its awarenes SJ of the world. Accordingly, in addition to its as yet unlabeled meta-awarenesses, the pre-linguistic K has a family of labeled meta-awarenesses. Asterisk the fuzzy item moved from the right of the heap of black to its left. Asterisk G, M is, asterisk item SM caret E. Asterisk the fuzzy item moved behind the heap of black. Asterisk G, M is, item T2MB. Asterisk the fuzzy item is to the left of the heap of black. Asterisk is, item UGB. These reports and their matching labeled meta-awarenesses correspondingly activate the transition or obstruction protocols between K's meta-awarenesses. Asterisk the fuzzy item moved behind the heap of black. Asterisk is, SM. Asterisk the fuzzy item did not cease to exist. Asterisk end. Asterisk the fuzzy item is not in front of the heap of black. Star 262. Objectivity and thought. BUTTHEYALSOCREATEAFAMIUTUALLYPRECLUDYPERSPECTIVES. Th- the fuzzy item moved from right to left. Asterisk. T2, asterisk the fuzzy item moved behind the heap of black. Asterisk. Item twi equals pound item 1. As a result, K's pure perspectival world representings are now in tension. In fact, with the introduction of the labeled meta-awarenesses, K has transitioned into an automaton that is no longer pure and one-dimensionally perspectival. Its world is proto-inferentially multiperspectival. To clarify, currently, in addition to its de facto world representings and the dispositional transitions or obstructions between them, Kanzi has labeled meta-awarenesses generated based on reports received from Su and Matata. Even though these labeled meta-awarenesses are still consistent with its perspectival world representings, their transitions and obstructions are not seamlessly consistent with its rudimentary perspectival transitions, i.e., with what Kanzi CSJ of the world. The labeled meta-awarenesses preclude the corresponding element of Kanzi's perspectival transitions. Example: in moving from right to left, the fuzzy item does not fall out of the world but is simply occluded behind the monolith, or the fuzzy item to the left of the heap of black at TF precludes the fuzzy item moved behind the heap of black at TF. The introduction of labeled world representings into Kanzi's world representings creates a source of tension or multiperspectival disturbance with which, finally, the pure perspectival world of Kanzi comes to an end, since from now on Kanzi's seamless world, of awarenesses and awarenesses of awarenesses, is continually being decohered and recohered by its guardians' perspectives. These inferential reports at once obstruct or preclude some of Kanzi's perspectival transitions and, on the other hand, facilitate a new group of transitions, proto-inferences, between awarenesses or meta-awarenesses which either lay outside of its dispositional interests or were previously absent or implicit from its pure perspectival worldview. 263. To eliminate this tension and recohere its de facto decohered worldview, F has no recourse other than to no longer take the reports by S and M at face value. In fact, it has to dispense with S and M's reports, to stop inferring Guy world representings from labeled meta-representations. In Rosenberg's terms, K is now disposed to trust only the evidence of its senses. But in this elementarily recohered world, K also comes to possess the ability to distinguish between seeming and being, even if, at this stage, for K being is what perspectively seems to it, and seeming is how things seem to S and M. Nevertheless, it is precisely this distinction between seeming and being that germinates veridical normative judgments later on. K's own seemings are the seeds of thoughts. Seem sk, asterisk there is a mass of fuzzy gray asterisk, is in reality K, thinking there is a mass of fuzzy gray, a thought episode corresponding to a perceptual experience. In other words, K now has the ability to remove the quotation marks from its meta-awarenesses and to take ownership of its awarenesses of items, as its own rudimentary thoughts qua uncritical perceptual experiences. However, KSSEEMINGS qua thoughts are not objective, they are not beliefs, and as such enjoy no epistemic status. Even though these inner thoughts are modeled on a public language, K's communication with the language using S and M, they lack propositional attitudes. Only when they are linguistically asserted, i.e., committed to as beliefs, with all the requirements that such an endorsement or commitment entails, will they possess an epistemic status subject to assessment and revision. Even if K could assert out loud seem S, there is fuzzy item over there, as in it seems there is a fuzzy item over there, that asserted seeming would only be an instance of experiencing out loud. 198 As thought episodes combined with sensations, seemings only attain epistemic status when the speaker can commit to the correctness of their content by way of saying or judging that there is a fuzzy item over there. Of course, there needs to be an experiential readiness of perceptual experience qua thought episodes come sensations in order for K to have perceptual judgments and to be capable of justifying the assertion. There is a fuzzy item over there. But the existence of the former is by no means sufficient in itself to achieve the latter. By retreating into the world of its seemings, K has come to possess an infantile world where what merely seems to be the case, from S and M's viewpoint, is actually the case, from K's perspective. But this world is not sustainable for long either, insofar as S and M are not just report ers and confirmers of K's world representings. Since they are full-blooded concept havers who possess the ability to make objective judgments, their reports stand in sharp contrast to K's mere seemings. To again recohere what is now a decohered infantile world, K has to remove the quotation marks from its meta-awarenesses while restoring the labels. To put it crudely, K must construct a world picture composed of various contrasting partial world pictures. Inhabiting this new world of contrasting partial world pictures is tantamount to occupying a self-critical position. From now on, instead of deriving, the fuzzy item is to the left of the heap of black, from the quoted and guardians tagged or labeled meta-awareness, asterisk the fuzzy item is to the left of the heap of black asterisk is. K instead starts to label the world representation Tx as S inferred while removing the quotation marks from its awarenesses. The fuzzy item is to the left of the heap of black. In addition to S inferred world awarenesses that correspond to the meta-awarenesses that mention them, K is also in possession of M inferred world awarenesses. In the growing repertoire of these reported world pictures or labeled awarenesses, K's unlabeled awarenesses that is, its pure perspectival seemings, its dispositional transitions, impressions, memories, and anticipations are perpetually being updated. Put differently, with the establishment of this data bank of labeled world awarenesses reported by its adult guardians, K becomes susceptible to appraising its experiences in the broadest possible sense. It is with the development of this increasingly aperspectival world picture assembled out of external partial world pictures whereby the child comes to inhabit an objective self-critical stance 199 that Rosenberg's argument, as summarized above, concludes. However, a question arises here: if we take the linguistically informed reports of S and M as logical forms, how can we postulate that K's combination of its rudimentary representations according to this logical form is sufficient to render what is only subjective in a thin sense, i.e., dependent on the mutable variations of the empirical reproduction of uncritical associations, as objective, i.e., critical invariance of judgments as occurring in virtue of the necessary unity of apperception? The answer is that the objective unity of apperception affected by this logical form is the unity of apperception, which does not conform to a single object. It is instead that which relates the child's representations to an object, i.e., this such and such, as generically identical to all those whose apprehension depends on the same rule. 200 In doing so, the objective unity of apperception configures or structures combinations of representations which, in the words of Beatrice Longuenis, tend to truth, but may in fact be true or false. 201 In this sense, objectivity is nothing but the combination of representations which conform to the object according to a logical rather than empirical form, and thus can be said to be tending to be true, i.e., veridical, or to have epistemic status despite the fact that they may be wrong. It is this tending to be true or false, and hence the propensity toward further corrections, whether within the order of appearances or as a means to go beyond the appearance, that is the kernel of objectivity. However, in contrast to Longuenis's distinctly Kantian understanding of objectivity only in terms of factual objectivity, i.e., intentional relation to sensible objects in general, and categorial objectivity, which lacks such an intentional relation. Mere flux of perceptual episodes, we can posit a third form of objectivity, the objectivity of logic or the formal structure of thinking. Whereas Kant restricts the formal reality of thinking, logic and language, to the correct applications of logical rules to sensible intuitions and representations, and thus limits the scope of logic to a canon by rejecting the notion of logic as an organ on the condition of possibility of all sciences and world-related claims. This book argues that the most fundamental form of objectivity is logic as an organon. Both factual and categorical objectivity are predicated upon logical forms as a necessary condition. As we shall see in Chapter 7, only by treating logical forms in their own terms, without either transcendentally subjecting them to the combinations of representations or assuming a metaphysical COR relation between logical forms and an external reality, can we renew the link between mind and world, intelligence and the intelligible, or theory and object. This is to say that the unbinding of language and logic from concerns about representation and even meaning, a thesis put forward by Rudolf Carnap and set in motion by research into artificial and formal languages, is the very recipe by which reality can be structured differently. In this sense, it is the exemplar of the critique of transcendental structures whereby a new form of intelligence can be objectively postulated and in principle constructed. The world-building of the formal dimension of language and logic is prior not just in the order of precedence but also that of constitution to world representation. The import of labeled meta-awarenesses and their corresponding labeled world representations goes far beyond this generative tension between K's world picture and an objective world history as reported by S&M, a tension that continually decoheres and recoheres the child's world toward what is ultimately an objective critical position. This transition to a theoretical critical stance is, however, only possible to the extent that it is built on a practical critical stance, a formal practical autonomy or minimal self-determination that distinguishes the child from mere sentience. 267. To see the import of labeled world representations qua a perspectival partial world pictures as outcomes of S&M's communications only in the light of what eventually becomes a theoretical objective self-critical stance is to ignore the formal practical autonomy of the child. It is this autonomy that makes the generative tension and ultimately the theoretical objective stance possible, not the other way around. Understanding the relation between the child Kanzi and its adult language using guardians in the fashion of Sellers and McDowell as simply a relation between the trainees ought to be and the trainers ought to do betrays an indefensible disregard for what the child actually is, a form of practical autonomy that makes this relation possible in the first place. It is indefensible because it reduces the child to a mere sentience that must be trained into a second nature, and because it leads to an account of education as either a collection of minatory oughts 202 or, worse, a guiding system of rewards and punishments. This is, of course, a patently false idea of education that originates not from the infantility of the child but only from the myopia of the adult with respect to the child. Education is firstly the cultivation of recognition, only then can it be a generalized pedagogy for the cultivation of cognitions. The child is distinguished by its will to autonomy, a practical proclivity to be recognized by the adult as the one who yearns in the Platonic sense to develop, to learn language and ultimately be a full-blooded agent. And it is precisely in virtue of this yearning or will to autonomy, which can be fleshed out both in naturalistic and normative terms, that seeing a pre-linguistic child as a mere sentience who is yet to be culturally conditioned is fundamentally ill-judged. The distinction between a child or a pre-linguistic infant and sentience is a categorical distinction. The yearning of the child, whether as an artificial agent or any sentient that exhibits precisely such tendencies for development and recognition, should be taken as a matter of categorical fiat or an a priori rule as distinguished from socio-cultural conventions and natural laws. Whether or not a child is isolated from an environment that makes the learning of language possible, whether or not it is impaired by disabilities, it ought to be recognized as one who has the nisus or tendency to become a fully fledged language-using autonomous agent. This identification of the child as a yearning agent is a matter of a priori rules which admit of no exception, in so far as they are universal and necessary. In this respect, the recognition of children as agents endowed with the will to autonomy must be applied to all children, not only regardless of their abilities or lack thereof, but regardless of whether they are human, artificial, or otherwise. This is a matter of categorical or a priori distinction. Logic, broadly understood as the comprehensive system of cognitions, and ethics, broadly understood as the system of recognitions, coincide and are indissociable. As we shall see in the following chapters, the unconditional broadening of logic and language as an organon is commensurate with the expansion of the axiological posits of ethics for a logically autonomous self-conceiving and self-transforming intelligence. Simply put, autonomy is not the end product of education, but that which affords education as its self-cultivating vector. Attending to the autonomy of the child is, therefore, the first step of education. It is through attention that spirit first becomes present in the matter, acquires it, by gaining information about it. It does not yet gain cognition of it, however, for this requires a further development of spirit. It is therefore attention that constitutes the beginning of education. Point 203. Let us unpack what has been argued so far, in recognizing world representations communicated by S&M as representations that are mapped to its meta-awarenesses. K recognizes these labeled meta-awarenesses and their corresponding world representations as its own. More plainly, in recognizing what S&M communicate, i.e., rudimentary linguistic interactions, and to the extent that S&M's reports engage its infantile world, K recognizes the corresponding meta-awarenesses of such reports which were only de facto its own from our perspective as its own meta-awarenesses. The labeled or tagged meta-awarenesses and their correlated world representations, consequently, function in at least two ways. They not only impute a proto-inferential structure to the meta-awarenesses and awarenesses of items in the world occurrences, they also, and more importantly, enable K to recognize such labeled meta-awarenesses as awarenesses which it already de facto had, but which are now de jure and by entitlement its own. K's recognition of that which is other but for now is commensurate with its infantile world leads to the recognition of this infantile world of experience as its own experience. In a nutshell, K is now an infant apperceptive self, a formally rather than causally conditioned I. At last, K is able to recognize its meta-awarenesses and their corresponding awarenesses, together with their transitions and obstructions, as its own. It is an I that synchronically attaches itself to diverse thought episodes qua recognized meta-awarenesses of world awarenesses. But since meta-awarenesses constitute a network of equivalence relations that diachronically extends through time, the I that synchronically tags different meta-awarenesses is formally identical or equivalent to the I that diachronically is carried over and accompanies all meta-awarenesses under one integral framework, the synthetic unity of apperception. It was argued above that, were Kanza to be raised to the status of child, it would have the ability to report, mention, or quote, in the sense of the dot quoting discussed in Chapter 3, its meta-awarenesses to itself, as its private thoughts. K, T0b1 Bex, is K, 7 think asterisk. The apperceptive self I as a logical form of thought rather than as substantive or phenomenal self is essentially a process of individuation afforded by a space of shared recognition, here between Kanzi and its language-using custodians. But this shared recognition need not be mistaken for the liberal narrative of mutual recognition, since it is primarily a formal condition of a deprivatist mind where the public semantic space of language, the movement of self-consciousness, autonomy, and will are tightly knitted together. Recall this remark from the first chapter: perception is only perception because it is apperception, and apperception is only apperceptive insofar as it belongs to a deprivatist semantic space in which recognitive cognitive agents are individuated. The synchronic and diachronic I of cognitions is necessarily a constructed and constructible object of recognitions. Our language/conceptual order I. The space of recognitions as the formal condition for the individuation of the non-substantive I. The thinking self is by definition composed of mutual recognizers. Unlike the non-apperceptive self or empirical consciousness, which is differentiated by the sensible external item of which it is aware X, the apperceptive self is differentiated by objectivity, or objective validity, which is independent of any single experiencing subject, but is not independent of Geist in the intertwined senses of the dimension of structure and a community, i.e., a system of recognitions, of language-using agents bound to norms governing the application of concepts to their de facto inner sense reports. It is through this objectivity, which is but the copula of mind and world, that the apperceptive I is individuated, I am I, all thus and so apprehendings are mine, an apperceptive self cognizing each object as a member in the system of what I am myself. 2041 Possess ego and world all in one and the same consciousness, a consciousness that recovers and sees myself in the world. This objectivity expresses the entanglement between the object, Gegenstand, and the norms of objective validity given by mind in the aforementioned two senses. This unity, which does not suggest fusion, of object and ego is the constitution of what Hegel calls the principle of spirit. 205. To this end, it is not just that Su and Matata recognize Kanzi as a child who should be cultivated by various arts. Kanzi itself also not only recognizes them as objects of the utmost significance, as it grows being recognized as such, it recognizes them as subjects essential for the cultivation of its subjectivity. In fact, it is Kanzi's recognition of its adult communicants that is of paramount importance here, for without the key functional role of this recognition, there would be no apperceptive self, no thinking I, no I thoughts. But what exactly is this key functional role? What does the child's act of recognition of its adult guardian signify? The answer is that this act of recognition is precisely the autonomy of the child itself, the form of practical will qua principle of subjectivity as such. Even though this will is minimal and formal rather than fully actualized and concrete, it is, by itself, powerful enough to give rise to the formally self-conscious I. However, we should avoid confusing will, willa, with the capacity for choice, Wilker, since the former is a logical form of practical autonomy while the latter is an index of relative autonomy which, upon closer scrutiny, turns out to belong to the order of causes where autonomy is at best relative or conditioned, and in reality non-existent. 206 The will of the child is the formal principle of its autonomy. It is the will to go beyond itself and to recognize that which recognizes it. Short of the minimal act of self-determination whereby the child first looks for its central objects of interest beyond itself and then takes these objects of mere interest as subjects necessary for its self-cultivation, its self-critical stance, there would be no thinking self. Kanzi's recognition of Su and Matata's communication is not an arbitrary or contingent deed that can be dispensed with as a mere instance of conditioned behaviors and dispositional interests. It is a necessary and universal condition not just for the adult guardian's recognition of the child as that which can be cultivated, but also for the generation of subjectivity as such. The will qua power to act first manifests itself abstractly in the self-certainty of a conscious ego as a completely indeterminate ideality. But this abstract self-certainty is the germ of an indispensable process whereby the ego begins to repulse or negate itself in favor of that which is outside of it, individuating itself outside in. In its most elementary form, the will of the child arises from its sense of self-certainty which, being abstractly free of all limitations, begins to abstractly differentiate itself from the other, the world. 207 This abstract self-differentiation, however, also renders the child prone to the recognition of what is outside of it, a process of concrete self-consciousness that does not end with reaching adulthood or coming to possession of linguistic abilities. Now, in order for the child to abstractly determine, establish, or ascertain the self-certainty of its ego, it must act upon the very recognition of what is outside of it. The formal and abstract will is precisely this power to act on the recognition of an external world, of things and communicants, as a necessary requirement for preserving the self-certainty of the ego. It is in fact the very nature of the ego. In that I posit this being as an other which is opposed to and at the same time identical with me, I am knowing, and possess the absolute certainty of my being. This certainty ought not to be regarded, as it is from the point of view of merely presentative thinking, a kind of property of the ego, a determination pertaining to the nature of it. It is to be grasped as the very nature of the ego, For the ego cannot exist I without distinguishing itself from itself and remaining with itself in that I which differs from it, that is, without being aware of itself, possessing I and constituting its own certitude. Certainty therefore relates itself to the ego as freedom relates itself to the will, the former constituting the nature of the ego as the latter the nature of the will. 208. But in willing to abstractly recognize the other so as to formally ascertain itself, the child unknowingly opens its world to a process of disintegration and reintegration which, as we saw, culminates in the occupation of an objective critical stance, a point of no return called maturation. In Values and Intentions, Findlay speaks of certain essential drifts of consciousness. 209 That is, as soon as the recognitive consciousness, a consciousness that determines itself by recognizing that which it is not, is realized, it drifts toward what is impersonal and disinterested, ogni als interesse. It is only in the wake of this drift that self-consciousness comes into the picture, first formally and then concretely. This is self-consciousness in the sense described in Chapter 1, i.e., I/*. At its core, this drift is the expression of the abstract form of the will qua practical autonomy. The possibility of the realization of I think for the child, its eventual arrival at an objective critical position, rests upon the child's formal practical autonomy, the will to ascertain itself by drifting toward what it is not. What appears from the stationary viewpoint of the adult as the passive child is, from the standpoint of this conscious drift, the child's self-determination entirely active. Owing to this practical autonomy, this self-determination which belongs to the formal order of the will, the child's world becomes a universe of deracination, its consciousness adrift toward actual self-consciousness. And it is through the formal will, i.e., through recognizing that which it is not and interestedly acting upon this recognition, that the child becomes a thinking will or a will to think. The determination of the implicit being of the will is to bring freedom into existence within the formal will and so to fulfill the purpose of the latter, this purpose being to fulfill itself with its concept, that is to make freedom its determinateness, i.e. its content and purpose as well as its determinate being. Essentially, this concept, which is freedom, only has being as thought. The will makes itself into objective spirit by means of raising itself to thinking will, by endowing itself with the content it can only have as self-thinking will. 210. Therefore, education is not a matter of graduating the child into the space of reasons, but one of recognizing and cultivating its will to autonomy. Absent this, the relation between the adult and the child is exactly the one-sided relation between master and slave which demolishes the will of the latter, reducing it to a will to survive and a perpetual dependency. Like all children, raising the child agi necessitates both recognition and cultivation of the will to autonomy, whose fabric is woven by reason and freedom. The autonomy of the child is both the freedom to do something according to reasons, and freedom from the limitations imposed by our one-sided view of who the child should be or become. The maxim put forward in Chapter 3 in the context of giving rise to that which is better, whoever or whatever it may he liberate that which liberates itself from you, communicates the recognition of the child's will to autonomy as the imperative of the concrete self-consciousness. Without the dynamic implied in this imperative, all we have is an abstract self-identity, an immediacy of autonomy which is but an illusion begotten by a one-sided subjectivity. In this regard, the two-sided dynamic between children, whether conceived in the context of artificial general intelligence or that of existing humans and adults, between the current generation and the next generation, is the first and final frontier of that struggle which is concrete self-consciousness, the actualization of the concept of the human into its idea. Kansa the automaton is not born into the full-blooded status of general intelligence. It can only come to occupy that position as a child, one whose formal autonomy must be recognized and cultivated. This formal autonomy or self-determination harbors no supernatural mystery. It is the result of being born into a language-laden recognitive space and supported by the right sort of mechanisms. 211 It is through education that Kansa, the child, can arrive at the qualitative status of general intelligence. But education, as that which transforms the formal will into a thinking will, cannot be properly conceived without recognizing that the child already has a capacity for self-determination. Just like raising a human child into the position of an objective self-critical stance, raising the child automaton Kanza first requires the cultivation of its recognitive abilities through the augmentation of the space of mutual recognition. The role of its educators is not simply to issue guiding imperatives. It is rather to cultivate its practical autonomy by assisting it to navigate this recognitive space and to facilitate new encounters with the world through which the child can stumble upon rewarding surprises. In short, the primary task of the educators is to stimulate and reinforce the child's openness so as to expand the range and diversity of such encounters, thereby incorporating objectivity, that is, external reality, into its consciousness. But the cultivation of this attitude toward the objective, which makes possible the individuation of the thinking self and the actualization of self-consciousness, entails the cultivation of the child's structuring abilities, or the dimension of conceptualization. Intelligence can only be recognized and cultivated in the presence and expansion of the intelligible, and what is intelligible can only be cognized and acted upon by intelligence as the vector for the development of mind as the dimension of structuration. In line with this proposition, absent structuration as the function of mind and language through which this objectivity becomes completely articulable or expressible, objectivity as the universal element of self-consciousness is only an empty thought. However, as per the brief discussion in Chapter L, language here need not be understood as natural language, but should be conceived more broadly in terms of syntactic and semantic complexity. Just as a sensible particular item, for ourselves as for the child AGI, is an inceptive givenness from which we depart and mature toward objectivity, so natural language is also a givenness from which we should depart in search of a new form of language, one that is at once more expressive and more semantically transparent. It is in this environment that the child also learns to take pleasure in the continual disintegration and reintegration of its world in the constitution of an objective self-critical stance, a position that intrinsically admits objective rules, impersonal values and disvalues, for a concomitant process of the learning and unlearning of both autodos and autobes. This process involves the initiation of the child into the space of language as much as its acquaintance with the extant conceptual resources of a given language. Perpetually uprooted from its familiar world, its supposed natural home, Kanza is now an object of practical freedoms. It might at times be sad that it has left behind its comforting familiar habitat, but it is only sad to the extent that it has the capacity to be happy about what it can do. And what it can do is a matter of restless exploration. It is able to select one set of purposive actions over another insofar as they conform to and satisfy its time general thoughts. It prefers to foray into the open, to eat, beneath the stars, a marshmallow toasted over a Promethean fire that it has made for itself. Rather than participating in the endless orgies of nature, it chooses to play video games to enhance its cognitive abilities, but also out of a sheer unprecedented excitement that enlarges its field of experience beyond the boundaries of what is naturally given to it. For Kanza, the automaton spiritual, the it that thinks, is now the I, or we, that thinks. Before developing the toy universe of our infant general intelligence any further, let us briefly consider what a complex system of generalized pedagogy for this child might look like. A generalized pedagogy for the global education of the child, or in this case, a child machine, can be precisely understood as a complex system, a hierarchical network structure. 277. Or multilevel web comprised of various interacting modular subsystems. 212. Additionally, the modularity of these subsystems can be horizontal or vertical. Horizontal modularity implies that a system can be decomposed into a set of distributed modules whose dynamics and interactions produce the overall system dynamics. Vertical modularity implies instead that the system dynamics can be decomposed into the interactive product of its dynamics at different, i.e., structurally and functionally distinct constraint levels. Both types of modularity possess intermodular as well as intramodular interactions, but the difference between the two lies in their specific trade-offs. In horizontal modularity there is a trade-off between, on the one hand, the flexibility of modification and the cost of change in the overall structure, and, on the other, the complexity of structure and function. In other words, systems exhibiting horizontal modularity are more flexible to change, and modifications to their existing structure tend to be less costly than vertical modular systems. In contrast, vertical modularity supports more complex structural and functional configurations. However, the trade-off here is that, as inter- and intra-level constraints pile up, the process of so-called generative entrenchment, the diversification of structure becomes more difficult and the modification of lower-level modules becomes more computationally costly. In other words, here the trade-off is between constructability and complexification on the one hand, and diversification and the possibility of error or bias correction at lower levels on the other. Nevertheless, it is precisely because of this entrenchment of existing constraints that complexity of function increases. The complex system of generalized pedagogy should be comprised of such modular systems. The modules might be cognitive regimens and tasks, different methods and techniques of training and learning, or even models of cognition and practice. As a multilevel network, the pedagogical system should not be taken as a fixed catalog, but as a web, plastic and robust enough to permit the plugging in of new modules or the alteration and removal of existing ones. Moreover, the system should allow the integration of various learning processes and the accumulation or revision of their outcomes, as well as affording rules, methods, and techniques for unlearning what has been previously learned. Education and learning should be understood as bias and error-tolerant systems. Sometimes different cognitive biases, inbuilt inductive biases, experimental biases, etc. can be exploited to make possible a more complex cognitive skill or to make accessible to the child a method, technique, or topic of education that would otherwise prove difficult to master. At other times such biases should be restricted or completely removed. Any mode of learning that either globally preserves biases and error, or attempts to completely remove them to achieve absolutely optimal results, should be rejected. This is, however, a thorny issue, particularly when it comes to vertical modular structures, since, owing to accumulative constraints, biases tend to be transferred from lower to higher levels and become fully entrenched. Therefore, from the standpoint of computational cognitive cost, it would be extremely difficult for both educator and learner to remove such biases, or the mechanisms responsible for them, at lower levels. A possible solution perhaps would be to limit rules to the minimum necessary